This.
Hi, good morning. Just wanted to make sure that you can hear me.
This week.
All right. Thank you for confirming that.
We'll start in another 10 minutes. So we'll update you.
To give a preamble of what today's program is about, I request our head of the department, Dr. P. Kamakshi, to deliver the welcome address.
Good morning, all the dignitaries, our respected director, and honorably former colleague and former director of CSAR CBI in the collection research, president of PSI, CV Prasad sir, vice president of shipping and options. Mukesh Majalai sir, Amit Pande is on the way. Flight is delayed by 2 hours. We'll be reaching at around 12:30. So, Satyasilan from Team Age Consultants also will be joining in the afternoon. Our beloved advisor management, there is Parivalan sir, former colleague of our Eastern Laboratory, Dr. K. Muthamani sir, our head BKMD, Dr. Satish Kumar sir, and all other dignitaries from our laboratory, and also the participants who have joined here offline, and all the participants who have joined online. A very warm welcome to all of you. Very good morning. Actually, the topic of today's seminar, we thought it is the requirement. So, we all very well know, we have been taught about earthquake from dual design strategy, and we have the rigid diaphragm action, how the lateral forces elements, structural elements, lateral transfer mechanism, how it is happening. And we have our response reduction factor, we have our interstory drifts, performance limit states, and all the requirements. Design strategy as such for expert engineer. And on the other hand, now we look at the fast growing infrastructure development activity. It is inevitable that we need to go for some kind of faster construction without much difficulty. We can't will be taking so much time. So we need to have infrastructure to be developed in a very, very limited time with the utmost quality control. That's why this kind of precast and prefabricated structures are finding a very big role now. So we just want to understand from the experts, those who have come here all the way. So we want to discuss much on this, and we want to understand how we are going to bridge the gap. Always it is said that the connections are going to play the major role, whether it is going to act like a monolithic structure, what we expected to happen, or because it will not happen as such, it happens for in situ construction. We need to engineer the joint. So the design of precast system is something different where they have to be engineered. All the joints have to be engineered in order to act like a monolithic structure. So we need to understand from our perspective how it can be seismically qualified. So whether is there a scope of any kind of seismic testing, because something which we cannot be model. So we have this mode shapes and dynamic analysis requirement, which is specified by in our course for lumpedistic model, how to arrive at the lateral forces based on the mode shapes and other things. Based on the irregularities, also it is prescribed to go for uh, dynamic analysis. Whether that mode shapes, whatever we assume, by modeling it in a general purpose software, it is going to follow the same kind of mode shape. That is the thing we just want to understand from the precast engineers. So we have the very best people in the industry, from the industry, who will be interacting, and also we have the very best people from the university. One Professor Pina from Buffalo has joined, has been very kind today, and Professor Weising also will be delivering lecture. We have the very best audience here, as well as the speakers and audience. So I request them to make this event so that the pathway for future of precast, uh, satisfying the requirement of earthquake resistant design will be so some kind of because when we do the testing, why it is done means some of the valves or panels or pumps which cannot be modeled as such in a computer software that easily. So we carry out the test. So that kind of requirement, whether it will be required for a precast construction, joints has to be fully understood, cyclic response of that or energy dissipation characteristics of that, so that backbone models are developed, so that it will be an input for dynamic analysis. Because without inelastic demand or without talking about inelasticity, there is nothing in earthquake engineering. We don't seem that to be elastic. So with that background, I now request, I will not take much time, I will now request our director to welcome our guest to the green welcome. We take the privilege of honoring our former colleague and founder of our laboratory, Dr. Muthamani sir. Honor our Kamaro colleague. Thank you, madam. Thank you, everyone. Now we'll move on to the program.
Thank you, madam. We'll move on to the session. I see that there are some messages saying that the video and audio is we're trying to work it out, but we are getting that some video for some people video is working and some they're not. So we'll try to sort it out as soon as possible. Meanwhile, we'll go on with the function. And now it's time to start the first lecture is going to be delivered by Dr. Pinar, and she's from US. It's midnight for her. And without much ado, I'll just, because the program warrants, we
separately. So these panels in the middle come out if you want to reconfigure them. We have a reaction wall, a large reaction floor as well, and various sizes of actuators, both static and dynamic. More recently, we also got a wind tunnel and an electric furnace. So now we can do earthquake, fire, or wind testing. And we consider ourselves more to be a multi-hazard focused research center or department. Okay, so let's now get to precast concrete structures. That's the topic of the seminar. So as you know, I'm sure there is precast concrete manufacturers in the crowd. As you know, it makes sense to manufacture precast concrete pieces in linear geometries. We have these long pre-stressing beds, and then of course, then we transport them that way as well. But of course, when we build them in place, it turns out that the connection regions typically are also the regions where we need to dissipate the energy. So typically, most of the construction in the US, we focus on connections that mimic the behavior of cast-in-place concrete. So these are now somewhat well developed. We have grouted ducts, grouted sleeves like the ones shown here for reinforcing to go in. We have reinforcing bar couplers and such, but they're trying to make sure that our precast concrete structure behaves similar to cast-in-place concrete. So that works really well. Research has shown that it does dissipate the energy and does what it needs to do, what the design is meant to do. But it also, at the same time, after an extreme event, then your structure may look like the one on the right-hand side, so lots of damage. Although we have this large energy dissipation, large P delta curves, there is also large residual displacements. It's hard to repair these, if not impossible. There's long downtimes. So we've been questioning, are these systems, if we try to mimic cast-in-place construction, do we get resiliency? And part of the reason why we are motivated by resiliency is that, so this is one of the largest earthquakes in the US from 1994 now. But so it was a tragedy that about 60 people lost their lives, but also with that hundreds of thousands of people lost their homes, and there was no water to many buildings. It was very hard to recover from that event, economy-wise and infrastructure-wise. So nowadays we're thinking about, okay, how do we do life safety, but also how do you also make sure our structures are repairable after let's say a design earthquake. So the focus has shifted a little bit more towards resiliency. And that's why I picked my topic to be more on repairability, because precast concrete structures, I'll get to it, it's really great for making repairable structures. So one indication of damage is residual drift, as we all know. And there are guidelines out there that tell us, from observations, limits of residual drift. So I picked one from FEMA, that's the Federal Emergency Management Agency funded study. It tells us, for example, that if your residual drift is 1%, your repair may not be feasible economically. So at that point, we may want to consider demolishing the structure and rebuilding it. So residual drift is one indicator of damage, and can we do something to reduce that residual drift? This picture I picked on the left-hand side, as you can see, this person is vertical. Building has a very significant residual drift. Despite that, they are trying to fix you can see this excavator pushing it or keeping the structure in place. The only reason they're doing this here is because it's a historic structure. That's why they're trying to save it. Otherwise, this would certainly be a candidate for demolition. All right, so then what's the alternative to that plastic hinging, which gives us great energy dissipation, but doesn't give us necessarily that resiliency or repairability? So this idea is to have racking precast concrete elements. And this is not my idea. It came out in the late 90s. Dr. Priestley led a big study called PRESS. And idea here is that to connect precast concrete modules using unbonded post-tensioning. So these are our unbonded post-tensioning. And then that allows the structure to, if there's a lateral excitation, that allows gaps to open. So we intentionally allow gaps to open. And the nonlinearity comes from that joint opening. And because joints can close after the excitation is over, our load displacement curve, the loading and unloading paths are the same. So this is called self-centering, and in these structures, as you can see, P and delta go through the 0 point, so that means there's going to be very small or virtually zero residual displacement. So it eliminates the post-tensioning strands, like a spring brings our structure back to that vertical position. So these are great in terms of minimizing residual displacements, but you do get a little bit of higher accelerations and almost no energy dissipation. So what's typically been done is that you add some yielding elements to the structure. So it could be maybe some rebar go through between modules or some dampers, and that gives us that this flag-shaped curve on the bottom. So it still does the self-centering, very small residual displacements, but it also can do some energy dissipation. And if those dampers or the yielding elements are external to the structure, you can also replace them as well. So after the event, then after the extreme event, your structure should remain operable. Okay, so then with that little introduction, so let me talk a little bit about what we do, what my group does at University at Buffalo. So I picked some examples of experimental precast concrete research here. So none of these are fancy experiments. We're using the strong wall, applying quasi-static cyclic loading. On the left-hand side are our bridge columns that we tested. You can see it's modular. And this is the self-centering column. And with self-centering columns, because there's a lot of racking over the foundation, there's a lot of compression damage at the base. And that moves that pivot point at the base inwards if you start losing your concrete like this. So what we tried here was to use ultra-high performance concrete. These are steel fiber reinforced concretes, cementitious composites that have very high compressive strengths. And we actually removed all the rebar from this bottom module. And you can see this is after the testing. You can see there was almost no damage. In the middle, a similar project where we this time used the bending module and then racking joints on top. So we were trying to combine some or balance some self-centering with some energy dissipation. And on the right-hand side is actually an example from a building-focused research. And this is a shear wall that was not code compliant. So we designed it to have a good likelihood of shear failure. Even though it wasn't meant for that. It's a slender wall, but supposed to fail under shear. It's not code compliant. So what we proposed there was to turn this conventional wall into a self-centering wall by cutting the base of that wall and then adding some external post-tensioning. And you also notice the confinement that we have at the toes of the wall. So essentially, we were taking a conventional cast-in-place, non-code compliant wall, turning it into a precast concrete wall that then does not fail under shear, because when you do that racking motion, you essentially eliminate that shear failure risk for the most part. All right. But the project, so those are some examples of our experimental work, since the seminar today is focusing on experimental work. But the project that I want to go a little bit into more depth today is about these repairable tessellated shear walls. I'll explain what tessellations are in a second, but after acknowledging the students and collaborators here and the funding agency. So as you can see, these are walls that are prefabricated and have many, many modules. And the idea here is that after, again, an extreme event, we don't have to replace the entire wall, but maybe we just replace pieces of it. So we keep the structure operational, or downtimes are short, but we replace some of the modules. Okay, so tessellations, this is are actually used quite a bit by architects. Tessellations just mean repeating patterns of similar modules. So how fitting for precast concrete applications. So on the left-hand side, obviously this is a glass facade, but you can see these little triangular shapes that are repeating. So this is a tessellation. It hadn't been used much in structural engineering. So we said, well, since they're similar modules, can we use it for rapid construction? Can we localize damage within tiles or within the modules? Can we, like I said, repair easily because we can just replace the module? So these were the questions we asked, and that's why we wanted to use it for a structural application. All right, so there's different kinds of tessellations. This is one. So again, repeating patterns. So this is a non-interlocking tessellation, just panels on top of each other. And really the earliest form of this is our masonry construction. So that's been done. But there's also tessellations that interlock with each other. So this shape, for example, this I shape, as you can imagine, in that vertical direction, you don't need any mechanical connections, just the geometry of the modules allow it to be connected. You could create shapes that interlock in multiple directions, so 2 directions. And then you could even create shapes that interlock in 3 dimensions. So we didn't go into 3 dimensions. We looked at 1D interlocking and 2D interlocking tessellations in our study. So as far as we know, we're the only ones that have built a concrete structure out of these tessellations. There's a lot of applications in mechanical engineering, very small, tiny structures, and this 3D printed one comes from there as well. Okay, so we then created this tessellated wall. We called it Tessa wall for structural architectural because we worked with an architect who gave us these creative patterns. So this one has I-shaped modules. Again, 1D interlocking. We made it out of concrete. Of course, when people built this tessellations out of, the little 3D printed ones for mechanical engineering applications, they can have perfect shapes, but with concrete, as you all know, we have construction tolerances. So we put some grout between the modules to meet those construction tolerances. And then we post-tensioned, unbonded post-tensioning on top to give it some self-centering. I know the seminar is focusing on experimental work, but I want to show some other aspects of the work as well. So we built some finite dimensional models. The wall was modeled in 3D. Post-tensioning strands were truss elements that had displacement compatibility with the wall. Here's our validation testing. So you can see one of the modules being built. So here's our I-shaped module. They had these post-tensioning ducts going through to accommodate the strands later. And they actually had a little bit of a taper into the we reach 1.5–2% or 2-inch, I should say, displacements without having much residual displacements. After that, we start getting residual displacements as the concrete starts crushing and we have some damage. And then our model, the finite element model that I showed, if we modeled it with hard contact between tiles, so really non-deformable interfaces, we got a much stiffer response. But when we introduced a soft contact, so we included the properties of the grouts, we got a much better response with it. Or much better match with the test results. Then we looked at modeling 2D interlocking walls. So these are now a little bit different. You can see we have additional legs to these modules. So now they interlock in vertical and horizontal directions. And with the models, we looked at what happens when we change the configuration of these tiles. So the difference between these four walls is within what we call the edge tiles or the modules. And this is kind of like the boundary element of a shear wall. So on the left-hand side, we have separate modules. The discontinuous one. Continuous one has one continuous module. And then staggered ones have two modules along the thickness, and then their joints are staggered across the height. So they're not happening at the same joints across the width. Okay, so then we looked at the load displacement behaviors of these. So let me do this first. Okay, so the Tesla walls, so the tessellated walls, interestingly, it didn't matter what kind of edge pattern we used. They had somewhat similar capacities. But what was interesting was that if you model a conventional wall with similar reinforcing ratio, so you can't have the exact same reinforcing, but similar reinforcing ratios, you get a much higher capacity. So here, really the trade-off is that you get repairability, but you lose strength. So the owner of the building would have to think kind of long-term and say, okay, I will have two walls instead of one. So higher initial investment, but then down the line, if an earthquake happens or a high lateral load event happens, I may not have to replace my structure. All right, and the last aspect of the project that I want to mention is these simpler models we built for the same walls. So we did the three-dimensional finite element models that I mentioned earlier. Then we also did these very simple models where, I should say computationally simple models, where each module is modeled with beam column elements. This is now an OpenSeas model. So and these beam column elements, our tiles are connected to each other with springs. So the interface is captured with these spring elements. All right, so the reason why we wanted to do this more simplified model was because we wanted to do some fragility functions for our tessellated walls. And fragility functions come handy when architects and engineers and stakeholders, so owners, insurers, whoever it may be, are communicating. Because our architect, for example, on the project, gave us many different patterns of tessellation. So I put 4 of them here. These are little beam tests that we've done just to see how they work on. These are just 3D printed pieces, little plastic pieces. But as you can see, really the module shapes are only limited by the architect's creativity. So then as engineers, how can we tell them, how that shape is going to do in terms of probability of damage? And here this is interesting, actually. I think this group may be interested in this. So for fragility functions, some of you may know, you have to define damage states. For conventional walls or structures, we define damage states based on crack widths, etc. But for modular structures, how do we then define damage for the whole wall? Because our wall is composed of multiple modules. So we brainstormed about this for a little bit, and we decided that we're going to do it based on module damage. So we created damage states for slight damage based on a module. And then we assigned the repair effort for slight damage. So we said slight damage is repaired in 1 unit of effort. Similarly, moderate damage, if you have larger cracks, more spalling, that repair will be 10 units. And these units come from our laboratory. We did repair it in the laboratory and kind of measured our time that it took to do these. And then if you have severe damage, then you may actually have to replace a tile. That means the post-tensioning strands have to come out. So that was 100 units of effort. We then add this all up, kind of like a weighted average. So we have 1 unit of slight damage, but 14 tiles that are in that damaged state. So we add that all up and then find a total repair effort. And then we say, okay, to build a brand new wall would be about 1,000 units, because we estimated 25 units to build a single module. And again, this is based on our construction experience in the laboratory. And then by comparing the repair effort to building something brand new, we say to repair this would take 18% of the rebuild effort, and that we consider to be then moderate damage for the entire wall. Hopefully I didn't make that confusing. Then that gave us an ability to be able to come up with some fragility functions and compare patterns of tessellation. So in this one, I'm showing 2 similar tiles. So on the left-hand side, we have Tessa 1, right-hand side, Tessa 2. You can see they have similar interfaces. And on the right-hand side are these fragility curves. And not surprisingly, we got somewhat similar results between the 2 tiles. So that one conclusion could be that if you have similar interfaces, similar interlocking, you get somewhat similar probabilities of damage. But really, I think the interesting part of this project, or this fragility part, was to be able to define damage states for something that is modular. And I think that's all the time that I have. So I hope I know we're the first ones who do concrete walls auto tessellations. It's a brand new concept. There's still a lot more to know. We haven't yet done any dynamic testing or anything, but I hope that that was interesting to you. So with that, if we have time, I can answer questions. And I added some references here in case anyone is interested.
Thank you, Dr. Pinar, for giving us an overview of the research. We pick 1 or 2 questions from the audience participating online or offline. Okay, Dr. Pinar, you can unshare your presentation.
Okay.
All
right.
There will be questions as of now.
All right.
We'll get back.
Yeah, we'll get back to you, ma'am.
Yes.
Dr. Pinar, thank you very much for the presentation. If there are any queries, then we will, I think we have your email ID and we'll contact you later. Some of the participants are having some difficulty with the presentation, so we are trying to figure out. Thank you so much for taking your time out this midnight and sharing your work with us. We hope to see you in India very soon and host in our institute. So we welcome you to our institute at any time. So thank you so much. With that, we move on to the next presentation.
Thank you.
So moving forward, I would like to introduce our director, Dr. N. Anandvalli, CSR Structural Engineering Business. எல்லாமே கட்டாது அவர் பிரசன்டரோட வீடியோ மற்றவெல்லாம் வெயிட் பண்ணுவாங்க.
அதுதான் இங்க இந்த மைக் போக மாட்டேன், மைக் மியூட் ஆயிட்டா வச்சிருக்கான். இப்போ நம்ம பேசினா இல்லை வரணும்ல.
அட்மின் ஒரு
those who are present here and online, all dignitaries, distinguished speakers, and my dear colleagues and the participants have joined online and offline. Vanakkam and Namaskar. So I'll be not talking more on FTech, but about what ACRC is all about. And I hope the presentation is visible to the online members and my voice is audible. So, this year is the 60th year of this great institution called CSR Structural Engineering Research Center, which was established from 10th June 1965. So we worked with one spirit 60 years only to serve the nation, the area of structural engineering. So my presentation will be this way, like initially I'll be giving an overview of what CSR SCRC is all about and what are the recent contributions, scientific as well as industrial contributions. And particular to this particular seminar, Advanced Seismic Testing and Research Laboratory, the journey when we started as a structural dynamics laboratory and today we are at A-Star Laboratory. What are all the different contributions? And a precast and prefabrication, what is the role of CSR, SCRC and how to move forward. As a collaborative team, there are three pillars are there. One is the research, the other one industry, then the academia. So these three pillars have come together so that we'll have an impactful thing for the benefit of the nation. So with that, so CSR, SCRC initially, like initial years, we were concentrating on advanced materials and structural designs, innovation, structural designs. So these are some of the significant contributions during that period. So many of you may not be aware. So I would like to highlight upon few of these things. And one is the fly ash. India's first fly ash building is existing in this campus, where 30 to 40% replacement of cement with fly ash. This is during the period when fly ash was not thought of as a waste and it was not considered as a hazard in 1970s. So we have this building inaugurated in 1974 and still today it is usable, after which we took a number of efforts to bring this into code. So after which CPWD also adopted. And the other one is on the pre-stressed concrete sleepers. So this is a technology from SCRC where the Indian Railways, currently you can see the wooden sleepers is no more. We are adopting the pre-stressed concrete sleepers. Again, the core deform bars. This is one of the import substitution technology which was developed those days, and it was the most earning from the revenue we could generate when we transferred this technology to TISPA. They have taken it up, and then that has generated a lot of revenue for CSIR SCRC. And this is a technology from SCRC. Many of you may not be knowing it. Right now, it is very easily available. So we have created and ferrocement construction. So this is again where corrosion is addressed and many of the applications you can see with the ferrocement construction. And the other things like analysis of Matri Mandir or Tirupati Q complex, the shell folded plates and shells. That was the strength and prefabrication. Today we are talking a lot and the seminar is focused on this. And way back in 70s, we had this prefabrication Tamil Nadu Housing Board Colony constructed with our technology. So the next 15 years, we were focusing on the interdisciplinary, like national capacity building and societal development. Our own scientists and tested in our internal, and then the 37 of such installations are then in the Odisha coast, and it saves number of people. So we also feel very happy when we get the letters from them that this was very useful, and otherwise in the other time it is used as a multi-purpose form. And we also took part in the Indian Antarctica expedition, and the other tower testing research station was established during this period. And the later years, we went on to the interdisciplinary research and development. So where our focus is on structural health monitoring and seismic related studies, and the man-made thing which we focus. And on the case of man-made disasters, it is on impact and blast. So advanced materials for sustainable structures, as we all know, we talk a lot on the sustainability and the depletion of natural resources. This particular thrust area focuses on development of alternative materials. So special multifunctional structures, this addresses specific needs of some of the typical structures. Energy infrastructure, as we all know, we move towards the renewable energy. We also focus on energy infrastructure and the offshore structural engineering. Even though we earlier we worked on this area, right now we are also focusing our research and development. So we addressing each aspect of structural engineering. We have got different laboratories. 10 such laboratories are here with very good state of the art facilities. The first with the advanced seismic testing and research facility, you'll be hearing more during this seminar. And advanced protective structures and mechanics laboratory, we have a gas gun facility and impact drop impact testing facility. And advanced concrete testing and evaluation, our scientists go to the field to do condition assessment. Wind engineering laboratory, we have got a boundary layer wind tunnel. Steel structures laboratory, we have our people work on different high strength steel is the focus right now. And tower testing, where 80 meters. This was one unique facility which was existing for so many years. Right now, we in the country there are two other facilities, but this was created in 80s, where full-scale tower tests can be carried out. Advanced materials laboratory works on various polymers, concrete, and composites. Special multifunctional laboratory, we understand the structures right from the nanoscale to the macro scale. Something in Russia, this is again a unique facility where a different kind of fatigue behavior is we are trying to understand. That. Basically, we work on the piping component subjected to heated loads, all the welded rails, all these and structural health monitoring. As I was highlighting, this is one of the important area which we need to focus. And coming to recent scientific achievement, 3D printed building. This particular building had kind of two kinds of mixes, one without reinforcement, the other one with micro reinforcement. And UHPC mixes and testing of this evaluation. So where we couldn't use the conventional thing, so we went on to the caustic emission. Because of the condition of reinforcement and other issues, we went on. And towards the strategic sector, I think you'll be hearing more on this. We have got a pseudodynamic test facility where we have tested the shut-up rod assembly for the nuclear reactor, and also fuel drop tank for LCH and various other things. And also our fatigue lab, they have done sonar dome, where sandwich segment which were tested under water pressure. So then coming to the defense side, so we were continuously working with DRDO, the Ministry of Defense. So right from glazed reinforced concrete to the glazed steel concrete composites, and also on the numerical side, our contributions were there, and we have designed high capacity storage structures where we could reduce the separation distance and the prevention of synthetic explosion. And recently we have come up with a technology called multi-hit security booth, and now we have transferred it to number of industrial people. Soon we'll be able to see this on front forums. So then coming to another indigenous technology, recent times, emergency retrieval system. So the power companies, they have to import this particular system. So a mandate is there for certain kilometers, they need one such system. So with the aim of doing the indigenization of this, our scientists have come up with a new system, which is 40% less cost than the imported one. And we have transferred it to three such industries, and they have also brought orders, and maybe next year we'll be having these companies, power companies in India will have our own indigenous product. And this also has been tested in our tower testing station. So the other recent development flagship project of SCRC is only renewable energy. So as we see, the countries have huge thrust on this renewable energy. Offshore renewable energy is the future. So keeping in that in mind, so we thought our own technology, like design as well as other aspects, whether we can focus. So a team of scientists worked on both solar as well as wind turbine. So they could come up with the design where I should say that right from the substructure design to aerodynamic modeling, stability and control and fatigue, as well as all these aspects we have covered, and we are coming up with the technology. And the SHM of railway bridge. So number of the right side, you can see the India map with red dots. Those are the places our scientists have traveled and they have done the site investigations by placing the sensors and other things and capturing the response of the bridges. And they have given recommendations as well as how to reduce the longitudinal force thrust on the piers. So all these they have done. And we are also part of the old common bridge when they expanded from narrow gauge to the broad gauge, as well as the new common bridge. We are interested with the structural monitoring. So condition assessment of various power plant structures, that is another area where our scientist team of scientists is working. So the two maps on the left side is with the thermal power plants and the right side is with the nuclear power plants. These are the places where our contributions has been we could contribute to this particular industry. And also, we are, many of our scientists were part of the BIS on various different things and major contributions to highlight some of them, like a basic wind speed map of India revision was with our wind engineering team, and the probabilistic seismic hazard map again, team from A-Star their team, and also some guidelines for ground-mounted solar arrays, which was not available. They have come up with the guidelines, and it has been communicated to BIS, and guidelines for open ground study. I think you will be hearing more on this. And societal contributions, as this slide highlights different aspects. We also have a program called Jigyasa where we travel to these schools and then make them increase their curiosity for science and then try to align themselves to take science as their career. So, and also various other things you can see, like during the COVID period, we came up with a hospital, 10-bedded hospital structure, as well as a folded deployable structure, which can be multi-purpose. Like initially we thought for isolation units, but with multi-purpose. And also climate resilient building with two different technologies, and also PRECAST EPS panel. These two are different aspects. So some of the unique things, recent times, what we have done is like a fatigue behavior of piping system, which we were doing for a long time, and then wind load of air taxis. So this is our internal, we could do it, and then as I told you, common bridge, and also fatigue behavior of the transmission line towers. So these are all real-time hybrid simulation. This is another area where some uniqueness. And our technology portfolio, there are a number of technologies which addresses different aspects. Like we came up with a threaded end anchor bar for Indian rebars. Another thing which we have developed, and textile reinforced concrete where we can get rid of the corrosion, and various products are available, and also water tanks, the flowable composites, and emergency resist. So upcoming technologies. So one is only patented fuse link element. So we are trying to take this where this energy due to the earthquake is taken up by the fuse, and the major elements are saved. And this has been tested, and we are trying to take it to the next level. An expansion joint bridge tech system, where this expansion joint, instead of the conventional one, we are coming up with a composite. So we can have a smooth ride. Like this will be in line with the problems of the existing expansion joint can be overcome with this technology. And
anchoring bars are told, and steel foam concrete composite panels. This is another thing where I'll be explaining in detail a little later, and embedded sensors we have developed, and also high-speed rail. Another area where we'll be a lot of requirements. So our scientists have come up with a smart structural system. So we are talking with the high-speed railway people so that we can at least when it is required, we are ready with the technology. And composite bridge girders and adaptive dampers for piping systems, vibrations, and flexifier where the structural components can be tested.
So we also have our own Journal of Structural Engineering, which is then recognized among the structural engineering community in India, which is from 1973. This is being published, and from 24 we have open online submissions, and we run the program engineering of structures through our academy ACSIR. And we have the PhD programs, industry-sponsored PhD programs, and dual degree programs. So now coming to this particular seminar on precast and prefabricated structures, what is the role of CSR SCRC? So as I told in 70s, the large panel prefabrication, that was our focus. And along with the Tamil Nadu Housing Board, we developed a prefabrication system. So some of the features are highlighted. It's a story size wall panel, and it had a hollow clay block set in concrete, and also room size funicular shell fill panels. So this consumed very little steel. So our aim was to develop indigenous skills as well as techniques on on-site prefabricated construction using local materials. That was the focus. And with this particular technology, we were constructed 144 flats. It is 6 blocks of 24 each. These are a few of the photographs during that time. This is the completed structure which is existing in this part in Chennai. So plate elements. So where the runners are there and prompts around 1.2 meters to 1.5 meters. Again, this is also demonstrated in our own campus as well as this has been taken by few of the industry. And right now, a few of the developments I'll be highlighting. One is on the precast panels for water tanks. So earlier we had a ferrocement water tank. So we wanted to expand this and modular water tanks, whether we can expand the capacity. So we were trying to do for 10,000, 20,000 liter capacity where the panels are prefabricated and we have tested it for leak proof and other things. So these panels are separate and then they can take it to the site and assemble it. And it's less weight compared to RCC and masonry tanks, and also a viable alternative to plastic tanks. And the cost is also roughly nearly the same level. And the other one is on the sectoral built panels. In our campus, we have got two different buildings which we have demonstrated this particular technology. It is 40% lesser weight than the conventional one. It is a sandwich panel, and also it is indigenous. It is also material optimized, and we have also patented it. And this is suitable for any size of the panel. We can do it suitably designed. And the other features is corrosion resistant. We have tested the panels for various tests, and also it has got a precast foundation. So thermal efficiency is around 10 degrees, and cost is also nearly the same level as the conventional construction. So the other particular technology which I would like to highlight upon is on the foam concrete for structural non-structural application. So here again, the advantage of the foam concrete is highlighted, and also for various applications we have different technologies, like different kinds of density, so that the application is appropriately used. So with that foam concrete, we try to develop steel foam concrete composite panels. The advantage is thermal comfort, reduced construction cost and time, as with the prefabricated construction. All these are available in this particular. And coming to a seismic testing facility, what are all the different testing facilities we are having? We have got a. It all started with the structural dynamics lab. So the drawings of the structural dynamics lab, Dr. Mukimani, Dr. Gopalakshan, Dr. Satish Kumar as well. So when I joined this institution at JRF, they were all in this lab. So you can see a uniaxial shape table. That is the first they had a very small lab. With that, they were able to come up with a design guideline for vibration, like machine foundation. They have come up with a book, and then from that, now it has grown into a full-fledged laboratory where we have got a 3D shape table where we can. I think unique facility in South Asia where we have done major testing for the BRNS because the initial sponsors were BRNS and CSIR for headquarters. With that, we created. The space is around maybe 4 meters by 2 meters, 5 meters by 5 meters. So we can test structure G plus maybe 3 of 1 day by 1 thing. We can do it. And then we have also used this facility to demonstrate the shutter facility. That is what we do. And also recently they have done the mast structure for sonar with underwater. And then these are all we also have the heavy duty test floor. So these are all the facilities which we have, and we have expertise what is available. Not only the facility, we expertise gained over the years on various aspects like seismic hazard assessment, seismic performance evaluation of structures, and retrofitting for of existing structures, and seismic control devices. It's base isolators and dampers, and also testing methods like real-time hybrid testing. These are all various expertise available with our scientists in ASTA, and these are some of the tests which I think details will be given by them. So our own products which we develop, as I told, the Secro built or the EPS panels, we
use this facility to demonstrate their seismic performance. And also retrofitted, if you see the middle here, just got a retrofitting by wrapping of the joints, and after which we have also tested it. So again, these are all with the shake table, that is with the static testing. With the seismic performance of the using the shake table, you can see the open ground story, which is very vulnerable to seismic loads, and also other RCC frame structures, masonry structures, which is also very equally important, and the shear wall and the isolated flukes. So these are all the various test photographs you can see here. And other, as I told, the number of developments in the seismic control devices, both passive and active devices we have developed. These are the few photographs of our own technology and how it has been demonstrated. So connections, again, precast concrete connections. This is I think, a major experiment was carried out where a precast large concrete panel. This is for an industry. LNT has tested this, and dry as well as wet requires special attention. And the different connections like wall to wall, wall to vertical horizontal connections, slab to wall. And Dr. Ramana will be giving more on this aspect. So this and also coming to other kinds of beam column joints. So, for example, this particular left side figure shows two joints which are existing like a replica of what is existing in nuclear power. So there was a major program where the nuclear power plants, when the revision of a code came, they wanted to qualify whether it satisfies the need. So we have tested and we have also given the recommendations. And the right side one, to understand how the performance of the FRC, how it is done, how the performance is there, to understand that non-invasive and effective upgradation scheme. This is what we came out with, and the number of test experiments was carried out to prove it. And also, as earlier I was telling, probability seismic hazard analysis. This map of India we have done for NDMA in collaboration with IIT, which serves as a guideline, very now for design and construction industry as well as strategic sector. And other iconic projects which A-Star Laboratory has done during this period, recent years, maybe on different kinds of, not only restricted to the infrastructure or buildings, but other kinds of structures also we have done. A number of them are highlighted here. So false ceiling array, also cable trays and ladders, and shut-off rod assembly. A number of them comes after the first one we did earlier in, I think, 2010 or so. Then fuel tank, switch we have done, and for valves again. Then again, different kinds of valves, and also inverters, battery assembly, all these we have done. And also for the prefabrication industry, few of them approaches, and then we have done. This is a ground plus one story model thing which we have done for a prefab company. And then our people also travel to the site, so where they address the vibration issues. These are all different photographs showing where they have gone to the site and taken, given the recommendations. So I would like to conclude with the Tirukkural which goes this way: Kuru Karivi Kalam Mine Idanooda. To make an act very effective, we should have due consideration of 5 aspects. Like first, what resources we have or what is required, instruments. So we should have appropriate things, and the time of action that is very much required. Like doing it at a later time will not solve our problems. Appropriate time we have to do, and also what action we are going to do, and also in what context we are. All these, if you understand, that is, I think every engineer should understand this, and then do the action so that it will be very effective and impactful. And I would look forward for the collaborations from the industry as well as from academia. That is the purpose of this seminar. And thank you everyone for participating and taking time off your regular schedule and coming here or online, so that we have a good roadmap which serves for all of us. Not only it's for SCRC, but for all of us,
so that we can go together and then solve many of the issues. Yes, sir. Thank you.
Okay, madam. We'll take a short tea break now, and then we'll join for the next session. இதுலதான் வருது
Can you check now whether you're able to hear? Can you check now if you can hear?
now I see whatever I'm
இப்போ நான்
speaking
இதை
now
ஆட்
it is
பண்ணிருக்கேன்,
speaking.
இந்த மைக்கை பண்ணியிருக்கேன். ஸோ
That is
அந்த இதுவும் வரும், இந்த இதுவும் வரும்ன்ற மாதிரி. இப்போ நீங்கள் அது MS Teamஸில் பேசுங்க.
MS Teams here.
ஆ
ஒரு நிமிஷம்.
நீ பேசுறது இந்த மைக் வழியாக பிக்கப் ஆகிக்கும்.
Just pick up in 1, 2, 3.
Now I see whatever I'm speaking now it is speaking. Now I'm speaking from attending. MS Teams here. From speaking as attending. Still YouTube it's not getting, no?
இந்த மைக்
Whatever. Yeah, it's coming. It's fine. Check 1, 2, 3, check. Are you able to hear?
ஸோ ஐ திங்க் இட் இஸ் ஃபைன். கண்டுபிடிச்சாச்சு வெளியே.
ஏதாவது ஜஸ்ட் ஒன்று ஷேர் பண்ணுங்க, ஸ்க்ரீனு வருதான்னு பார்த்துக்கலாம் யூடியூப்ல.
welcome back all the participants. Our next speaker is Sri Yogesh P. Kajale. He is presently the Director of Engineering at CD Shirke Private Construction Technology.
Good afternoon, everybody. Good afternoon, everybody. Thanks for inviting me. Actually, I have very long association. I personally have very long association with ACRC Chennai. The story goes almost last 20 years. And my founder chairman, Mr. Baburao Shirke, BG Shirke, he has the association since 1967 when the ACRC was established. So coming back to the today's topic, earthquake safety of precast structure, I am going to share with you the industry's perspective and industry's experience. What exactly is the sustainability? We all talk about sustainability. To me, sustainability is basically meeting present needs with safety and functionality. These are the two important parameters. It's not only material consumption, other things, carbon footprint, carbon emission, but the most critical and important parameter is safety and functionality. Whatever service life of the structure is envisaged, we must ensure, we as a designer, we as a constructor, must ensure to the end user that that service life is guaranteed with needed functionality. Then the real sustainability is achieved. Now, how the housing construction operates in India? How the housing construction is operating in India? We have the end user. That end user doesn't come directly to the contractor. Okay, it's a disorganized sector completely. So there are housing boards, different government bodies, or a developer. He is not doing any engineering. He is only facilitator. What are the needs of that end user? He basically requires a secured enclosure. He requires usable and functional spaces. All the functional spaces which are usable. That is his requirement. His requirement is reasonable amenities. He is not looking for all types of luxuries and so many things. The reasonable amenities must be there. Speedy delivery. The moment he books a house, the house must be made available as early as possible. That is what is his requirement. Affordable cost. The cost is the most crucial parameter. So all these things must be in an affordable cost. And after getting the possession, whatever house or whatever structure he lives into it, it should have minimal maintenance or absolutely no maintenance. These are his requirements. Now, who meets with this requirement? The promoter comes forward. Promoter doesn't know how to meet all these requirements. He only assures that this is the land, this is the prime location, and I'll provide you the house at this rate. Then promoter engages architect, engineer, and contractor. These are again three different entities. So all these four entities hardly works in coherence, in cohesiveness, and that exactly is the final result what we all see in India. Huge housing shortage, then whatever housing stock has been created has many issues. So we did not spell out too many things. So what are the construction sustainability pillars? There are mainly three pillars: environment, social, and economic. To me, this economic forum is the most critical, that it provides the life safety and it minimizes the life cycle cost. So that with this, how exactly is the role of precast? Yeah. So that way precast is not new to India. Most of our heritage structure can get qualified into precast. It's not the concrete, it's not the reinforcement, but it's some other form of material. May it be timber, may it be stone. So we have a great heritage of having a precast construction, precast structures. during those days we were having the real engineering, the artisanship, and the constructability, rather the construction facilities available during those days, and these structures are still standing. So this is the inspiration for starting the precast. Now, what precast serves in today's scenario? So, whosoever is the constructor or the industry who tries to come up with any precast possible solution, he must ask 3 questions to himself. What is needed, why it is needed, and when it is needed. And to find these answers of these 3 questions, it would be very easy to come up with the best possible solution. Now, to me, best possible solution doesn't mean only arriving at one component or arriving at design optimization method. The solution is basically designing, sourcing the material, component level manufacturing, and installation. So all put together will be the only solution. And with this background, we came up long back in 1970s a system, precast construction system, which was named as 3S system: strength, speed, sustainability, and safety. So that's how the system evolved in 1970s. I won't go through much of this, but today we have capital investment in terms of equipment and machinery to the tune of 1,400 crore. The turnover of the organization is 6,000 crore. Just imagine how capital incentive is the precast construction. It's not that easy. And to survive with this kind of, this almost 25% of your turnover is into capital assets. If we don't get, or anybody who comes forward with this kind of mega scale prefabrication, if he doesn't get the orders, then what happens? Or if his system is doubted, then what happens? So there exactly comes the commitment of industry towards providing the safe and affordable shelters. So with this background, we set up the manufacturing plant, and on the right hand side you will see that the buildings have been completed of much higher stories. Now, what exactly is our commitment? When I am putting so much of my stakes into one business, and if something goes wrong, even a slightest, whole of our business operation will be standstill. So simply imagine what risk is being carried out by a contractor. And unless this commitment, this self-commitment is there, no industry will come forward to establish that their products, their system is confirming whatever has been claimed. So it's not only simple dogmatic assertion that my system performance is mimicking to the cast in situ construction. The jointing are very emulative to the cast in situ construction. That's not the case. So to minimize earthquake disaster risks, our commitment is basically outlaw unsafe typologies and encourage good typologies within the laid guidelines. That is our first prime objective. Propose new technology having been tested for its performance. The new technologies, only those technologies can be proposed which have been tested. I'll just give a very simple example. This is a classroom and you all are students and I'm just a lecturer. You all are attending my lectures. 1 year course is completed, and then you come to the university saying that I have attended 100% lectures. Just certify me that I am a graduate. Is that going to happen? It's not going to happen. You all will require, you, me, everybody is required to face the test paper. Unless in the test paper, you all get qualified up to the minimum acceptance criteria, you are not going to get awarded any degree certificate or post-graduation certificate to that extent. So the technology, new technology, it can be projected very well. It has this advantage, that advantage, reduction in the steel, reduction in the cement, thermal properties are enhanced. These are all claims. These have, unless and until these are established through performance assessment test, no one can accept the technology, or rather should not accept the technology. And that exactly is the commitment from the industry side, because this is my product. So I must ensure that my product is fully tested. Supports facilities to undertake full scale testing. Now such a beautiful facilities have been created at SERC Chennai, CBRI Roorkee, MNIT Jaipur, IIT Kanpur, NCCB Vallabhgarh. Lot many test facilities are available. Are these test facilities being used all 365 days? At the component level, you scientists are doing some investigation, some research, but this must come from the industry's perspective. So industry should come forward and support this facility, that I want this product to be developed and this product is to be, tell me what acceptance criteria should I consider for introducing the product. So that kind of interaction must be there between industry and research lab. Build skill in the artisans. This is very important. See, I may have very best technology. So Mercedes is the best vehicle. It is stated that it won't met with an accident, or even if it met with an accident, no casualty will happen. What has happened with Cyrus Phase 3? So it's not the quality or certification of the vehicle, but who drives the vehicle. That is very important. So it's not the technology which has been certified or had been performed, but who construct with that technology is also very important. So it's a combination of who design the structure, who manufacture the components, who install the components. So all three are the real parameters who will establish that the technology will ultimately perform. So we need to build that skill which will replicate the benefits of the technology. Encourage continuing education and research. Whatever research is happening, that the industries must come forward and encourage all these things. Undertake to build competence in retrofit and unsafe construction, because that is also biggest challenge. India, we have lot many houses, and all houses we all know haven't been built up to the required standard. So a day is going to come when we all will require huge outflow and expertise in retrofitting the existing structure, because all the structure we can't afford to demolish and reconstruct. Actively engage in developing standards. See, my experience, unless I share with you, share with academia, and share with Indian standards, the standard of practices can't develop fully. So there must be a continuous interaction happening amongst all these stakeholders. Updates is fraternity with latest development in earthquake safety. And that exactly is the reason why I am here today with you. So with this objectives, we have done numerous tests on a material level, on a component level, on a sub-assemblage level, as well as on a full-scale level. See, all these tests, like a unit test, then a practical, then a quarterly test, then half-yearly test, and then annual test. So, if the student passes through all these tests, then only the student will be considered as the best educated student. So, numerous tests have been conducted at different levels, and these tests started. We started testing these structures since 1972. During those time, few facilities were available. Now many advanced facilities are available. That left hand corner is the actual site constructed building which was fully loaded with a sandbag, because no other test facility was available during those times. And this test was conducted under Professor C.K. Ramesh of IIT Bombay, who is Jairam Ramesh ji ke pita. C.K. Ramesh. XCBR. Yeah. And when Sir was there at CBRI Roorkee, also we conducted many tests on a component level as well as sub-assemblage level. So now, apart from all these tests, full-scale test is very important, and why it should only be considered as the final acceptance test. One joint can perform very well, but we all know that analyzing the structure on a 3D platform level and then understanding how the load distribution happens, whether there is any alternate load path available or not. If it is not there, then what happens? So these can only be ascertained unless and until the technology undergoes in a full scale test. Now we know that no standards are available. India's standards are available on full scale test. The standard is under publication. The final ACRC has also gave us a substantial comment on full scale testing standard. Maybe probably in 1 year or rather 1 month or 2 months, the standard will be on board. A full scale testing standard on a building. So today the standard is not available. Then adopting new technologies without adequate theoretical and experimental validation can result into a disaster. Really, it can result into a disaster. We all are building. No challenges so far, God forbid, are not there. But something goes wrong or some critical wind or a seismic activity happens, then everybody will get exposed. So unless and until full scale testing is done, it's not really possible. IS 13920 doesn't prohibit precast construction. Doesn't prohibit. What it mentions is that it can be accepted if they are designed to provide similar level of ductility as that of monolithic RC construction during and after earthquake. Now this is the only one qualifying line which is given in IS 13920. With this one qualification line, most of the precasters claim that no, my joint is emulative joint, so I qualify under this line. This is just a presumption, Unless it is tested, you can't establish that yes, it is giving similar level of ductility. So with this, Central PWD has published one office memorandum, rather two office memorandum, what should be the acceptance criteria for full scale test and what should be the sampling. See, here we had a Ahmedabad plane crash. How many passengers were there in the plane? 240 passengers. What was the travel time for those passengers? 8 hours. What stringent norms and tests are applicable for aircraft? We all know how stringent those norms are. On the right side, it's a 24-story building. A 24-story building accommodates almost about 1,000 flats. 1,000 occupants, not flats, 1,000 occupants. Each flat will have somewhere 5. So 240 to 960, almost 4 times more than the aircraft. I'm just taking one small building example. And occupancy time is 50 years. 50 years by life cycle time. Means whole of my life I am going to spend in that building, in that flat. So my lifetime is almost 37 times more than the occupancy in the aircraft. What stringent norms should we have as a building, as a structure? We can't be spared. We absolutely can't be spared. And this exactly is the worry of the industry like us. We really have sleepless night. If we propose something new, which is claimed to be innovative, unless and until it is tested and proven. We can't have, because we know that with our construction, with our design, lot many people are going to stay in that building. Tomorrow my son also might be occupying that building, or some of my relative could also occupy. So understand the commitment, our social obligation. Collapse, if something happens for a building, it's not only the loss of life or economy, it also collapses. It's also collapse of a faith in design, construction practices, standards and norms. The larger public, their faith gets collapsed. Collapse of professional ethics and responsibility. Collapse of beliefs in regulatory bodies. So these are the tangible losses when any structure collapses. We all know few of the precast structures have already collapsed in India, which were constructed. The top is basically a school building, 5,000 school building. It was a single-story school building constructed with precast wall panels and slab. During Bhuj earthquake, 75% of these school buildings have collapsed. Single story. This is there. Then recently, one 3D volumetric prefab structure was also tested in one of the labs in India, and this could not even sustain 20 millimeter displacement, not even 20 millimeter displacement. So it's not only one load path, why we must have alternate load path, how the jointing should happen. Everybody will be under impression that 3D precast is the best because I am casting all 4 walls and a top slab together. So all joints are perfect. But understand, what is the top story and lower story? What is the connection? It's only merely through those dowels, nothing else. And if something happens with that dowel, and those dowels are actually grouted, so nobody knows whether the grout has occupied full space or not. And we can't test 100% joints with ultrasonic test. It's just impossible. This structure was again retrofitted and again was subjected after the failure. Still, it could not sustain 25 millimeter displacement. So this is why the commitment from the industry is there that whatever system I introduce to the public, it must be fully tested. Now, what exactly full-scale testing certifies? It certifies design, it also certifies detailing, it also certifies production, and it also certifies installation. Carried out by that kind of artisan, that kind of skill set, because my completed structure is being tested. Like I am testing a cube, and then can I confirm that the column will take 100% design load because the cube has been tested? It's a material test. It's not a full-scale test. Whether the joint can perform, whether the redistribution can happen between one element. If one element fails or one joint fails, then what happens to the to the entire structure? So full-scale test will only certify all these aspects, not a component level, not a sub-assemblage level. But to come to full-scale test, we have to travel all these aspects: material level test, component level test, sub-assemblage level test, and then full-scale test. Because we can't take that risk after completing full structure. So this is the important role. Now with this background, we also conducted series of full-scale tests. The first full-scale test was conducted at CSIRI CBRI Roorkee. It was in the year 2010. This was basically a representative one room structure of a 24-story building. We had a good results. Of course, that time the reaction wall height was very limited. The reaction wall was extended by providing a structural steel skeleton, and then the structure was subjected. 2 actuators were placed. One was of 50 ton and another was at 10 ton. 50 ton was at the top story and 10 ton was at the middle story. It was subjected to almost 75 millimeter displacement, but no major cracking happened. Then another structure, after introducing that CPWD's office memorandum, wherein it is mentioned that minimum 3 level of a 4-room structure has to be tested, so that the corner joint will also be there, 3 middle joint will also be there, interior joint will also be there, and all possible combinations we can inculcate into the test structure so that the real size performance can be assessed. So the middle one was tested. This is again a representative real size of 22-story S plus 22-story building, and the middle story performance of the middle story was assessed. Then another one is with the middle one is precast column, precast beams, and precast slab with an infill wall panels at the middle floor. The right one is basically a real size representative model of 32-story building, and this is with precast RC wall panels and precast slab. So I won't go through this. I am sharing the presentation with all of you. You can refer this presentation. This is the outcome of the first test, which was done at CBRI Roorkee. And then the second test was conducted. The components were manufactured at our factory. Those were transported to the lab, and then those were assembled, installed at the lab, and then the structure was subjected to the test. Now, what exactly was the first test? Is basically this 17th floor is the floor which was subjected for performance test, because that floor was having maximum drift. in a real size structure of a S plus 22 story building. The floor which is having maximum drift is considered as the critical floor, and then that particular part was subjected to the test. This particular structure was subjected 3 times the test loading. First in the steep direction without removing the infill wall panels. Then after removing the effect of infill wall panel, after completing first test without retrofitting, the same structure was subjected. And then the third test was in the without retrofitting, without repair, the actuators were removed and placed in a flexible direction, and the same structure was subjected again for a pseudo-static reverse cyclic loading. So we may say that this one particular structure could be rather had been subjected to 3 earthquake seismic shocks. Same case happened with precast wall panel and slab, because here the stiffness was tremendous, being all RCC wall panels and a slab and a 4-room structure. The size of this structure is 6.5 meter by 6 meter almost. It's a real size 4-room structure. The stiffness was tremendous. 2 actuators were placed in a synchronization at the top level of 100 ton and 100 ton capacity. So total 200 ton capacity with a stroke of plus minus 500 millimeter. That was the capacity. And in the first case, it was again 100 ton actuator with a stroke of plus minus 250. And then this structure, I'll just show you how the
BG Shirke Construction Technology Private Limited,
this is a
being pioneered in
video
India's
which was
prefab mass
captured
housing
from the first
technology
test.
and having an avid interest in constantly updating and upscaling the technology with improvements in machinery, materials and design, reaffirmed seismic performance of their industrialized 3S prefab system through rigorous evaluation undertaken at National Earthquake Testing Facility, MNIT, Jaipur. 3-level seismically vulnerable, full-scale 4-room segment at 16th, 17th and 18th story of 61.6 meter tall.
And those 4 rooms were taken. The components of those 4 rooms were taken.
With peak ground acceleration of 0.24 G and constructed using 3S prefab system, was tested for pseudo-static reverse cyclic loading in orthogonal
This
directions.
structure could withstand
Experiments
the capacity
completed
of
by
actuator got
loading the
exhausted
structure for 20
at
hours.
120 millimeter
The test house
displacement.
certified the ability of industrialized
not load
3S prefab system to transfer earthquake loads of much higher magnitude than the designed seismic forces through its distinctive connections, and hence the acceptable performance of the system is patently evident in seismic zone 4 for any number of stories. BG Shirke
I just tell you, now typically ours is not a dry jointed system, it's a cumulative or cast wet jointed system. In any system, we need to have a temporary bearing of one precast element to another precast element. In our case, it is 65 to 75 millimeter. When the test loading, the loading cycle was exceeding 75 millimeter cycle, CVR Murthy was also there. Professor CVR Murthy, he said, "No, let us stop the test because it is quite possible that your beam may come out." I was very confident because the first test was conducted at CSR CBRI Roorkee. That time we loaded almost about 75 millimeter. During those time, our bearing was 40 millimeter. So I said, "Sir, nothing will happen." Professor T.K. Datta was also there. Professor T.K. Datta is a very senior, almost 90-year-old maybe. He was also confident, no, nothing will happen. Then what we did, we said that okay, we'll sit below that structure and let's start the loading. Sir Murthy sir bole, no, you are carrying too much of risk. I don't want to miss. You might be confident that the structure will not collapse, but my lab, if something happens, the lab will get damaged. So I don't want to take that risk. So I said, sir, nothing is going to happen because just imagine we then analyze what is the strain levels achieved inside the structure. And then after half an hour, he got convinced that, okay, let's continue. So the same structure was loaded up to 100 ton capacity. Full actuator capacity was exhausted and the displacement level was 120 millimeter. No opening of joint or no severe damage at the joint has happened. That exactly is how the cumulative jointing system should behave, that only confidence will be gained. And unless such test data is available on a ample basis, then only new innovations can also come forward, or we may optimize the design forms. So this particular structure was subjected almost 20 hours loading, one after the other, total 3 times. Then this is a case of that precast RC wall and slab. It's a very steep structure. So you will find hardly any displacement occurring in spite of having 2 actuators. One is here and another is here. 200-ton actuator. The test, we stop the test after exhausting again the capacity of actuator. Hardly anything. Then what sir suggested, let us now cut this particular building because the stiffness will get reduced to the half. See, the intention of, rather the aim of earthquake testing is we must be able to reach up to the failure. Then only we will be able to judge what exactly is the capacity. So we cut this particular part and the stiffness was reduced. And then again the structure was subjected. So this is how, with a wire cut we cut that part, and then this 2-room structure was again subjected with the same 2 actuators, and then the leftover part, this leftover part, this part was also subjected. So we tried to analyze, or we tried to establish what exactly, how is the failure pattern. But unfortunately, we could not reach to the failure level in spite of we reaching to a drift of almost 1%, in spite of we reaching to the shear, the actual seismic shear almost 7 times than the design based shear, we could not reach the failure level. So I'll just show you this video. It's just a time scale video. Here at least you will be able to see the displacement, noticeable displacement. This was 56 millimeter. And this particular part, this leftover part, now the actuator was placed here. This was actually into torsion as well as displacement. But still, no joints were open, or we were required to stop the test just because the capacity is there, but the joints are open. That case didn't arrive. And this part was subject to resist almost 90 millimeter displacement. A reinforced cement concrete 3-level structure. Imagine 120 millimeter going here and there, and again a cyclic loading. Just imagine what will happen. So final outcome of this rigorous test is the RC column beam slab 3 tests and RC wall and slab 4 tests. So final outcome is that the displacement, total displacement was 120 millimeter. In case of RC wall, it was maximum 90 millimeter. The drift level what we could achieve is 0.97% in RC column beam slab, and in RC wall and slab it was 0.67%. The base shear, the actual seismic load which was applied to this structure was 7.81 times more than the design, and it was 11.6 times more than the design. So if I compare the weight of the structure, then it comes to almost 0.63 G, and in case of wall and slab it was almost 1 G. That was the seismic force which was applied to this. And the best part of it is that there were no major cracks and no opening of joints. Minor cracking has happened, but no major cracking, and in fact after removal of the load, the residual displacement within the structure was only 5 millimeter. So the takeaway I already briefed about. So what we believe always in Shirke, that one goal is not my ultimate aim, because setting a goal is just winning once. If I set the system, then I am assured that I am going to win every time, and that exactly is the final takeaway of we taking also efforts and developing the system and offering the system to our client, to our customers, which are fully tested, which are fully right, and which will ensure the performance. where you will be able to see how the construction is happening and what are the photographs of another building will look like after construction. Very massive scale project. 74 buildings for Cisco. And here in this project, when the project started and when the project was completed, that period and how many houses we built, we achieved 12 houses per day. Delivering of 12 houses per day. So with this, I end my interaction with you. Thank you. Thanks for inviting. ACRC is also taking a lot of efforts in coming up with various various technologies at a component level, may it be at a material level. I had an opportunity to interact with your research team on that panel when you used to, when the central government used to fund, and I was one of the member in that panel. So I had opportunity to interact with you on many occasions, particularly with regard to the development of technology. The ma'am has just showed that shear wall with the sandwich shear wall. I know what efforts were taken while developing that particular technology. Thank you. Any questions? If you have any questions, feel free to ask.
Like 1% drift. We require to
Shear wall we could achieve 0.67% with 2 actuators. That's the outcome of the test.
But not go to for ultimate.
Yeah, but see, which lab has that kind of capacity of actuator? Just tell me.
Your displacement comes in the way.
Not displacement. Displacement
capacity of the actuator comes in
no, the load capacity of the actuator. Actuator has a displacement capacity of plus minus 500 millimeter. But the force capacity plus minus 500 mm of 100 metric. What is the largest actuator available in the country? Tell me.
100 mm is very, very big.
Nobody has. See, MNIT Jaipur has the largest actuator.
Then we were
see, when I approached to MNIT Jaipur, no, I visited IIT Kanpur, I visited ACRC Chennai. I had a lot of interactions with you, sir. Dr. Bharat Kumar was also there. Santosh Kapuria ji was there. Then I had interactions with IIT Chennai. Then I went, there was a suggestion that why can't we try tower testing facility, because there I can construct the building, but the loading possible was only in one pull direction. So the performance could not have been achieved.
Sense of centric kind of. Of course, I do a single direction, but a very symmetrical kind of structures. It's supposed to behave in the same fashion in both plus or minus, not the T beam or that kind of action. So, would you suggest that how close we are to the cycling kind of? Suppose you have a limitation, 900 mm or 750 mm, that kind of displacement can be applied only in one direction. Most of the other. You still recommend that, or you will ask them to go for cycling?
No, cycling is important, sir. What happens during push pull? No? See, we are reversing the conditions. The tension phase, compression phase. Cycling is the only way out. Because I remember when we tested almost 50 column beam joints, single, isolated, sub-assemblage level, we reached the failure. And the failure pattern is really unique, which needs to be understood. And that failure pattern can only be assessed when there is a cyclic load. Now, my beam bottom reinforcement, typically what happens in precast construction or even in composite precast construction, wherein partial in situ and partial precast members are there, we can continue the bottom reinforcement of one beam into the another beam. But continuity of top reinforcement is possible. Now, with this joint, if I subject the member only in one direction, the real performance assessment
is very critical points. But congratulations to you that you have been able to prove that particular personality who was like telling a lot of criticisms on your
yes,
and that's close to your
Professor Murthy attended all these 8 tests. All the 8 tests. Thank you. Thank you. Yeah, please. No, no. No, no. Here we don't go with the typical dowel tube connection. In our case, see, I have the wall connections. It's ensure that there are 2-3 levels of connections available. Rather the load path. The most critical is joint at lower story wall and upper story wall. Another important is joint in between. So what we do, we make a precast wall shorter, a little bit shorter, and the middle joint is actually all the time casted in situ. So I am able to integrate reinforcement of one element into another element, and then from the lower level there is a one continuous bar going into it. Then the wall and the floor level joints are concerned, we make sure that a pocket is left in the upper story precast wall. So whenever any engineer or anybody visits the floor, he will always see that the joint is properly grounded or not. And it's a sizable site. It's at least 156 inches wide by 500 to 750 millimeter high, depending on the development length requirement. So that kind of joint is left, a pocket is left at the story level, and then it is filled with a non-shrink ground. Those are shear joint you're talking about, joint between the wall to wall. Monolithic joint between wall to wall. It's not only shear. See what happens when I need to consider a complete in-plane stiffness. Then it's not only the shear which is going to decide the in-plane stiffness. It also depends where exactly is the neutral axis or which is the compression zone and tension zone. If my vertical joint falls within the tension zone of that level stress, then my detailing will have to be different. Thank you.
Thank you, sir, for giving an exhaustive talk on the physical testing which you have conducted. Next speaker is Shri C.A. Prasad, who is President of PSI and also the Director of MET Engineering and Consultancy. Yeah. Please.
So, a short announcement before we start. We'll have Prasad sir lecture now, and following that we'll have Dr. Gopalakrishna's lecture. After that we'll break for lunch, and the rest of the lectures will be continuing post-lunch session. So, thank you.
Right, good morning to one and all. Very good afternoon. It is very happier to note that I'm here in ACRC amongst you research people who are testing a lot and all that, which is quite interesting and very much important to our precast structures that are being built. I'm basically a designer, right? Who designed the structures, and I'm also and Amit and myself are very closely crisscrossing at various conferences. Yogesh, I'm seeing him and met him for the first time, but even though we are meeting online so many times in the conferences, right? But I know the way he has been doing the work and he has done the work at Jodhpur and all. We all have this information and all that. Well, Gopalakrishnan Garu is very much close to us. I have been to his CBRA retreat as well. He was also a speaker at one of our conferences. Right? He has this extensive knowledge in finance. Now, what I'm going to take you through is now the various precast structures that have been built across India for a period of time, ever since we have set up the society. We have set up a society in 2013 and going around into that. Just very brief information about PSI. Like-minded consultants from Hyderabad, they have set up this particular thing. Back in 2005, I have returned from Gulf, having worked there for about 10 years, and mastered the design of a precasting and various structures for about 50 to 60 story structures that I have designed there. And then returned, I thought precast is a go for India to improve the quality of construction and the good construction technology to be developed and all that. And since 2013, I have been in the various forums and then canvassing about precast and other technologies. And it is now that my office is today is flooded for the last 5 years is only precast. All the developers are coming from a design precast. Okay, so I have been now branded, even though I design monolithic structures and other technologies, I have now been branded as a precast designer rather than other these things. Fine, good enough to know about it. So through this society, we have been constructing some various workshops. So far we have constructed about 10, and then through our efforts, I am very glad to know that we have there are now number of precast companies which have come up, and we have also conducted once MES people have asked us to conduct one workshop in Delhi. Whenever we are conducting at Vijayawada, Hyderabad, or Bangalore place, they are not able to come. When we have conducted in Delhi, there are about 50 engineers have come and sat in our workshop, and they came to know about the advantage of precast and all. And then now MES is calling for tenders in precast construction only wherever precast company is existing. That is one good thing that has happened after us we have conducted that particular, because in recent tenders at Bangalore, Chennai, Pune, Mumbai, they all calling for tenders only in precast. That's how the precast is now going into the Government of India sector. And then CPWD has also put up these particular rates of doing the precast construction, so that has given a good advantage of going into the precast construction. Now, we also have, through our society, we are also demonstrating the various construction technologies like shear wall, monolithic construction, and what you people will call it as Maiwan. The name has come like that, even though Maiwan is a formwork which is being manufactured from Malaysia, but the name has come like that. It's something like we call Xerox, but it's actually photocopy. Yeah. When I went in the Dubai and they said Xerox, what is Xerox? Why are they calling Xerox? Call it as photocopying. I've been connected with the British. Right? So like the Maiwan is the name. Insulated wall panel, what we mean is shortcutting the concrete, which HCRC has also done it with a polystyrene, and we shortcut the concrete. And we built the buildings for JSPL for their colony at Angul, Odisha, where we also noticed that there is a 4 degrees centigrade temperature difference between outside and inside. Light gauge steel or cold form steel construction again. We have designed the structures of 5-story structures for the JSPL at Raigir, okay, Raigir area for their colony. Of course, precast close to our huts, and then composite construction is also taking up in a big way. Even in Hyderabad, there is a 41-story precast construction. One Mumbai already has come for 50-story composite construction being designed by number of designers. Now we can also see that there are a number of precast companies which have come into India since 2013. I have seen that there is a lot of development, okay, which we have through the society that we have created the workshops and all that. There are the number of precast companies. Okay, of course, BJ Shirke has taken it wonderfully well forward. Okay, and they have initially started with a U-shaped beams and all, such a much bigger element need not be carried. It's a very unique way of doing it, and then pouring the concrete inside. Okay, and well, of course, later on is the solid beam elements which have come into. Okay, and then we have this number of precast companies coming up. And Urbanak is one of the company, I can say it started the Become guy in Ahmedabad, Okay, and the PSP is also doing very well in Ahmedabad again. Okay, and then there are a number of companies which have come like this across India, and some are passionate guys like Precast India Infrastructure in Pune, where he himself is a civil engineer and doing wonderful structures, right? So like this, we have this, but while you look at this photograph, the beauty of precast is that it's a large column-free space structure. Okay, when you create such a large column-free structure for a shopping mall or anything, the fellow have the luxury of putting his racks wherever he wants. Okay, so that's one of the beauty of the precast, where single tier, double tier, hollow core slab floor systems can be provided on top of the beams into that. And of course, we can also make coloring pigments into the wall panels and then construct the structure. Thereby, there is no need of even painting also. It can be a gray and color pigment. Nowadays, people are doing it in India, right? And of course, facade panels, which can be precast, okay, instead of cladding and glazing. We also have done these 8 lakh SFT residential structures for DRDO in NCR, Delhi. Okay, Dr. BJ Shitya have also done wonderful structures for the Delhi Development Authority, right? So for DRDO, we have built these structures. Again, the Zone 4, okay, structures have been built. Well, of course, there are the mass participations and all that. Again, it's checked by IIT Hyderabad, the proof checking and all. And various different ways in which the structures become, because the odd shapes sometimes for 8-story structure, 160 thick wall is sufficient enough, because our code gives 160 thick as a minimum concrete wall for a 2 or 5 resistance. That is a bottom line. Okay, and depending upon the shapes, and sometimes when 160 is not able to give me the torsional effect and all restraint, then we have gone for a 200 thick rarely. Otherwise, predominantly we go for 160. The GHMC in Hyderabad is a 2-bedroom apartment. Is again the precast. The internal walls, we said it can be built with brick masonry. Does not matter, because hollow core slab, the minimum span, if it is not utilized for 6 meters, then it is underutilized hollow core slab. So that's how we are doing these structures. All right, and then there is a very typical structure here. You can see that the structure is coming up like that, and then we have told the architect that, gentlemen, you need to create one element here to control the structure, one element here initially which is not doing it, then it has controlled the torsion and other things, giving the stability to the structure. But we also gave the architectural solution also, how it can look beautiful. Where sometimes as structural engineer we have to give that one also to convince the architects. This is a duplex story residential apartment again, but here the developer has used the pre-stressed precast solid slabs. Okay. On top of that, even we have provided, he never wanted any brick walls inside, so we have even put that pre-stressed precast solid slab. It's designed to take care of 100 mm thick non-load bearing walls also. Okay, that's how we have designed this structure, and it is just nearing completion. About to, if someone comes to Hyderabad, we can even show that. Now, Government of Andhra Pradesh thought of shifting the footwear park to the outside of Vijayawada, because they are all polluting the canals and all with the leather cut waste and all that. So we have provided a 12 meter by 36 meter long spans, saying that the government can build the walls on top of the hollow core slab, okay, and to whatever the space that they can lease it out like that. And then yes, we see lots of buildings mushrooming for buildings, because all these buildings have come in the Middle East. I was there from 1995 to 2005, and these mushrooming of buildings have come just because of precast. When I stepped in 1995, there are hardly about 3 precast companies. By about 2004, there is about 20 precast companies have come. Because of the precast technology, and so many companies have come, the towers have mushroomed like anything and going faster and all that. Having said that, if you talk about Burj Khalifa, they did not use any precast according to that. They are still worried that precast people might not be able to catch their speed. So they have gone ahead with cast in situ construction, considering that, but it is like, the formwork all the time is bearing about 3 stories load. 3 stories load in order to catch up the speed of that Burj Khalifa structure. Okay, that is one of it. I was there up to foundation, then I returned back to India as one of the designers and all. Right? And then there are apartment structures in abroad. They built like this with color pigments also beautifully. Okay, this is what is the quality that we can achieve. Even in India also, number of industries like BJ Shirke and others are already doing LIT. All the people are doing it fantastically. It's only a question of adding the color pigments such that you can avoid paint also to the structures. But abroad now, even in India also nowadays, I am seeing lots of architects are leaving the grey walls like that. There is no need to do painting at all because the concrete wall, most impervious. Why should we do the painting? Okay, just because of beauty? Absolutely no need. Yeah, inside you can go with a wallpaper such that paint can be avoided and our health also will be good without the painting nuisance of lead and all that. So this is some of the beautiful buildings. Now we will look at some of the buildings being built in India. This is in Pune. PRECAST India Infrastructure have built this particular one, 16.5 lakh SFT. This building is just built in 4.5 months by Preca in Hyderabad. Okay, and BDA project again, Shirke has done this. We placed still place 18. Yeah, this is in 2000. Yogesh, you need to tell me when did you build it?
This is Dodabanalli. Dodabanalli was built in 2012.
2012. In 2012, they have done this we placed S plus 18 structure. Okay, and then there's a hospital building that's built in 4 months by Preca. And then in Chennai, this hotel is built by VMB PRECAST. Okay, and then Gindi, Chennai, the canteen block just built in 38 days. And a school is built in 20 days. So somebody wants to start a school, within a month your structure will be ready. That is the order of the PRECAST, right? And yes, one client has come to us from Bangalore saying that he wanted the building. We started in March, we handed over in May, right? And he started his school in June. So from Hyderabad, we shifted all the elements. At that time, even Katera was not there. So we shifted all the elements and then got it constructed, posting one of our engineers over there. So like these buildings can be built fast. And Jindal in Sonepal have built this building. Okay, they left the building like that. There is no need. They just only added color to the railings. Okay, it's a beautiful grey color building, but inside, of course, they have done the paintings and all. This is one of the beautiful building, okay, which cannot be built with Cast Institute. Yeah, and this is built in Pune again for Infosys by PRECAST India Infrastructure, right? And I will come back to that a little later. Right? And then we have these are the building that we have built about 14 towers. Yeah, my co-consultant, Mr. Surya Prakash of Sachivani Infrastructure, have convinced the Greater Hyderabad Municipal Corporation that there are 36 towers, and he said, you call the tenders and free of construction technology. So in this site, we have demonstrated that we have built Cast Institute RCC frame construction with infill walls and monolithic construction with the shear walls, and then the precast construction, but we delivered all of them at the same cost. So that's how to say that the precast construction is not costlier. It has come on par with that. Okay, this is the structure that we have built there. 14 towers is completed and handed over. And these are the building that I am talking about for DRDO. Again, we have the steel to floor, and then the RCC wall structure above. Then we look at in the steel floor also. It is not that we have kept the columns all along, but we have run down some of the shear walls and managed the car parking to go nicer into that, because we ensure always that about 70 to 80% of the stiffness is there existing in the steel floor, such that it gives you the structural stability, right? So that is how it is. Okay, and then there are some of the buildings which are completed on that. And then Mr. Bob is the consultant again from abroad, settled in Delhi almost. He has done this 16-story precast wall structure again in Ghaziabad. Okay, it is built by Bharat City developers. Okay, this is one of the building again in Hyderabad.
Você captura a tela.
accidentally someone is
Okay. And again, the duplex story precast building, what I'm talking about is, this developer is very fancy about the landscaping also. So we have created from the wall itself a cantilever beam coming out. Okay, he wanted to put a very big plants of 10-story high and all that. So what we have done here is, from that cantilever, we have provided the precast element again to put the flower pots to come into that. Okay, a huge one. Okay, they were initially thinking about it, but then we have provided a precast one, lifted it and placed on that cantilever. Okay, such that you can provide this. Okay, so that's how the buildings are built with from the walls itself. We can take the columns and then provide the landscaping and all. Well, in Hyderabad, it's very fancy that there's a building just adjacent to a lake side and all that. Okay, that is how the things are coming. And then we say these are commercial industrial structures which I am talking about. We frequently use for columns and all. That's why I have asked you, Yogesh, that a grow-tech couplers, okay, such that I can avoid the 50-time diameter, 25 mm 1250 big dowel is not is going to be a big problem. And then 2-story column, 3-story columns, we are constructing it, leaving the reinforcement, as you can see there. Beam reinforcement will come into that junction with the bend, and then the junction only we will just concrete that one. Right? This is how this building is built, a 6-story building, and then a 2-story precast column has come there, erected it, and then the junctions are grouted into that. Again, this is another project done by Precast India Infrastructure. From Pune, they have transported the element 200 kilometers away and then built this huge 1 meter by 1 meter precast columns, okay, with the beams reinforcement to come, and then leaving the junctions there and to that, and then they have built the precast columns also, because 200 kilometers away nothing is available. So he has taken precast footings, columns and everything built there. Right? So this is how the elements are, and even the walls, the compound walls with a precast wall footing come wall, he has built it at one go and then constructed there. And then is a pharmaceutical industry. One of the industry wanted us in Hyderabad a building to be built in 6 months. They have already ordered the material. So Inventa has come forward. So we have designed the structure. So what we have done there is we have done even a 3-story precast column. It's a 3-story structure. 3-story precast column, 2-story, 1-story, wherever it is possible. 1-story, wherever the cantilever beam is coming, we said 1-story. Otherwise, the 3-story precast structure, such that the time will be saved. And then we have long spans of 12-meter hollow core slab, 8-meter hollow core slab, like that. And the building is completed in 6 months and given it. Later on, architect has beautifully covered with his cladding and glazing. Precast is not visible anywhere. Right? Here's some of the pictures, the beautiful interiors for a pharmaceutical company. Doing that great interiors is fantastic. Okay. Also, of course, now in the industrial structures also, yeah, the precast has gone into precast columns and the beams. Only the top is the roof with the purlins, the roof shell, because that is cost effective rather than hollow core slab and all that, creating a dead load and all. Okay, that is also done there. The Coca-Cola factory is now has adopted precast a lot. I think L&T is also building one. This is Inventa, who have done this precast structure in Hyderabad. What they have done here is a column of 24 meters high, and it weighs about 88 metric tons. So they've taken about a 500 metric tons mobile crane and then lifted it and placed it. It is an 8-story like this, in 24 meters high. Right? Only the foundations are cast in stone, beautifully lifted and placed. And then they have a beam of about 2 meter deep, okay, and then about 28 meter long. If 28 meter long, first of all, your trucks and all have to be made specially for the jointed and take the permission of the police. Okay, all that it is done, but then he starts with, I will go bigger. End up jointing and all these headaches and all. So this is again weighing about 132 metric tons. Okay, yes, transported it and then got it done. So that's how now Coca-Cola, after this experience, they are going with precast everywhere. They have done one in near in Gujarat state also. They are done by PSP. L&T also, I believe, have done one of this. Okay, so this is how the so precast means longer elements. That's the beauty of it, especially for precast structures. And for the Odisha government, Yeah, we wanted to we showcase one precast for the water tanks also like this, because we wanted to build a 4-story column at a stage, but they said no, Bala, they are worried. No, you do stage by stage. It's too silly for me to do it, but then just to demonstrate, we have done that with the cast institute monolithic joints at that level. But by this way, even KEC have saved about 3.5 months time. Okay, only the top one. Even now, after getting confidence on this, now they are telling please do the EG strength on the top also. We are given a proposal. We are going to do it shortly even that. Okay. Well, Pavani is here, who has championed this particular precast water tank. Okay, why not like this? Okay. So we were initially worried how she got the idea is fantastic. Please, Pavani, please raise up and show yourself to everyone. Right? She is from LIT. Okay. She has done this. Come up with this beautiful idea. Right? I'm very happy with the day. See, she got an H frame, that, and when it gets a connection here, there is another H frame, but this side one will get at a different level. So we are not looking at a diaphragm action, everything coming at one level. Okay, then we look at it whether it's taking the force or not. Okay, fine, it is able to take it. Then we look at what is the force and all. Okay, well, this is still structurally stable. But then the Government of India is now sanctioning thousands of crores for the rural water supply schemes. So most of the time what we are doing is we are not going with the RCC tank on the top. Okay, it's a GA tanks which are coming up. Okay, so if we create this type of platform like this faster, and the GA tank coming on the top with a liner inside which can take care of the quality of water, okay, very easy to construct. Now this way, Madhya Pradesh, Odisha, or Gujarat government are all going with this particular technology into that. So these all the innovations are coming up, okay, in a various way. And then we have precast sponge piles also. Precast sponge piles also, we have a factory in Andhra Pradesh, okay, which they are doing it, right? And this is spinning the material, pouring the concrete, then it will go to the edges, okay. So this is being used in the clay soils and other thing where they will drive it, okay. We use it extensively in Andhra Pradesh where BC soils are there. Now I take you to PSP precast. This is another wonderful form. PSP is a contracting, okay, and then he was telling me that they have about 100 batching plants across India, about 20,000 labor, but during the COVID period, all the labor have gone, only 1,000 left. Then they thought of creating one precast factory, so he has put up, and he got a huge order from L&T for bullet train project. So at all the railway stations, they are constructing a precast boundary compound wall, precast walls for the compound where the sound should not propagate out. Okay, and L&T have taken about 5 companies also to do this particular work of precast compound walls. All that is a fantastic way into that. And ever since that, they have done so many other works also, not only compound walls. Okay, so many factories and all that. Ask them to send the works that they are doing. This how even what are the shapes you want also can be done in precast. Okay, like this. And then you can see these got with another industrial structure, and they have come up with this precast columns and the precast beams. But of course, on the top it can be a steel structure. Okay, and if in between, if you have any flooring, yes, they will go with precast flooring, floor slab with a hollow core and all. So into the industrial structures, replacing the steel and all. So precast has gone into. That is one great advantage which is driving it, right? And of course here again the precast column with the steel beams. Okay, steel has an advantage, right? Lightweight being into that, right? And this is again Nestle with precast columns and a precast structure built by again PSP in Ahmedabad. Okay, this is how the structure is fantastically, and then here they are provided in a pre-stressed precast beam. No more steel again. The steel beam is a pre-stressed precast beam, which is hanging onto the another beam as supporting. They also done this sports stadium. Precast is a beautiful thing for the sports stadiums whereby they can make these L shapes. They can sit on that. So this is how the elements are. There's a beautiful stadium that they are doing it. And then there is a trussless roofing system, like a precast structure. Put you this thing. Well, CRC have already have the examples of trussless roofing systems also. Right? And then this is how they are doing this precast footing and the precast compound walls for the bullet train project in Ahmedabad in their factory. Boundary walls, yes, The type of boundary walls brought, and people are also doing it in India also now. Whatever the shape you want, whatever the color you want, you can make it. Okay, you just provide the liners and all. Yeah, you can get the beautiful shapes into that. Right. So this is how the beautiful precast boundary walls can be made into that. Right. And then we have lightweight walls. Some companies have already come up in NCR and in Hyderabad. They are doing very well. There is no steel, no precious whites or anything. There is solid concrete with the holes into that. It's a lightweight. Yeah, 600 in width, and it can go inside. Okay, they can make a partition with a channel at the top and bottom. It can be simply pushed in, and the tongue and groove system, it will go into that. Okay, it is extensively used. It can be changed and provided electrical conduits wherever you are. Now people keep on saying that what are the challenges in adaptability, right? Awareness, lack of full awareness of advantage of precast, one of the thing. Change, we have a lot of resistance to change. Expertise, lack of expertise, and we are trying to give this expertise knowledge through the various workshops and all. Misconception that technologies are more costlier. Just now I shown you that in one location we have done 3 technologies, but demonstrated that the cost is one and the same. Precast is not costlier. On the other hand, it will be cheaper if you have repetition of buildings. It will come down by 100 to 200 rupees per SFT. That we have demonstrated also in one of the projects. Standardization, yeah, more the number of the repetitive elements you create in design, then it becomes cheaper in precast, right? So awareness is being created by PSI and other bodies also at various locations through the workshops, and attendance by government bodies, teachers. We have been telling them, please come and sit down on the workshop, know something about precast, such that you can take up your other projects into that. Okay, misconception of precast costlier is not there anymore. Okay, because earlier, being like a finished product, they were putting the GST at 28%. Now they have brought it down to 18%. So that's why people are now choosing precast more into that. The resistance to change is a human centric, but it will go up once you build number of buildings. Okay, people are coming into that. So precast, as you can say, it can address the housing shortage fantastically, especially on the government side also. And then the challenges include the specialized skills. Now so much of skill is required. Even Yogesh will tell you how they are coping up with that. They are taking the non-technical people, training them. Your LIT has this thing, but poaching is also happening now. I can see wherever I go to a precast factory, somewhere the fellow saab kaise hai bolte hain. So the fellow is somewhere for me. And even if I go to Gurgaon or this thing, the fellow has earlier worked in some factory, has gone there. I see them in Gujarat, I see them in Maharashtra, everywhere our engineers are there who have earlier worked with us. Okay, so there's a beauty, but poaching happens for some time till we do it, and we are also looking at how to do it. So the GST rates that we have, now precast is now putting to 18%, so number of developers are also now getting into that. Okay, so there is one advantage of 18% only on precast is now being taken well. Now precast, now we have it in various locations. It can come. Predominantly is now happening in cities predominantly. Towns in less, rural areas very less, villages also very less. Now we are trying to see how to take them down to the villages. We have commercial buildings, we have residential buildings, infrastructure, municipalities, drains, culverts, footpaths. We are doing it in Hyderabad municipality. We are doing precast a lot for them. Institutional buildings, we are also doing this precast for the Telangana government of educational institutions, saying also, telling them also that no need for any flooring. We grind the concrete and give it. Okay, we are grinding the concrete and giving the surface, such that there is no other tile for flooring and all that. Yes, of course, industrial we have seen it, right? And then MSME industries, Government of Andhra Pradesh have asked us recently that they are going to set up a lot of MSME industries. They are looking for precast as one of the solutions. We are giving them the solutions onto that. They are coming up with in about 1 acre area how to create MSME industries. Okay, so we are going to give them the details onto that. We will create the precast knowledge. We will give the awareness, and then costing details we have to give it to the people whoever wants to set it up, and encourage entrepreneurs by giving government works and all that. In the rural areas, recently Tribal Welfare Department have told now these precast should go to the tribal areas. How do you take it forward? We are looking at engineers to be trained such that they can even keep the tables, catch the walls and slab, and then erect it there itself. But a question of concrete challenge, can they mix the concrete mix design? So we are even training some entrepreneurs. Tribal Welfare Department is calling the engineers, so tribal engineers especially, such that they want to upgrade them. And then we are giving some knowledge and all, and some people said yes, they will take up. Government is even giving them the loans to set up this particular thing and all that. Right? So the present positives are, yes, DRDO is calling for tenders only in precast construction. And Nitin Gadkari, you can see some videos that is the future of precast construction. Is there in the videos in the YouTube and all, you can see it. And then the challenging structures. In Hyderabad, my home developer is building the structures of about 6 basements and then 8 basements, even 6. For one structure I have seen the 6, others saying 8 basements. The issue is that it's not that all the basements are going down. The land has come like that, okay, to him, and then it's 34 stories above, right? So they are coming up with a massive construction, including basements and all. It's going to be about 40 million square foot. Okay, leasable space itself is about some 28 million square foot. Okay, there's a huge building for which the construction is going on. I invite you all to come to Hyderabad and have a look at it. There's a massive development of 40 million square foot totally with the precast construction, right? And so this how some of the things. They are also giving you some of this thing. I shall leave this information here. And they are trying to lift the massive weights, not like the smaller elements and all. Some are with beam and slab at certain occasions where hollow core slab is not coming in full. So why to put shuttering again and then put the small gap? They're coming with beam with slab also like that. Okay, so the huge elements which they are building it. And even what they are talking about is some planter boxes which are coming up. They are making with UHPC. They have manufactured UHPC by themselves. Instead of depending on someone, they have done the R&D and all. They are, by going for UHPC, then the planter box thickness is reduced. So that is the beauty with which they have come up with that, and then they are making the precast of that particular one, right? So this is all about the information about the factory. See, so the building is coming up there on the left hand side. One building is rising up, second building is rising up there with the basements and all that. There's a huge spans, again 12-meter spans, and columns are also precast. Okay, beams are prestressed precast beams there. So it's a wonderful construction. One of you can see. This is another challenging structure done by PRECA in Odisha. Okay. Now you all know that Sri, that master is there from Bangalore. So he wanted to build one structure, which should be a good meditation center also. And then you can see how the structure is tapering down into that. Okay. So this tapering structures is very, very interesting. But then these people have done this, like, you know, your column itself is tapering, then some of the column and the beam they have casted together. Column and beam casted together and then lifted and placed it on the top. So you can look at the way they constructed. They have casted this column and beam together and then lifted it and placed it on the top. Such that there is no junction at all. Okay, that is the best way to go into that. Okay, so some of the challenging structures, what I say is, some of these can happen only in precast. Okay, so that's how. And I also said about this particular structure is another wonderful structure. The beauty of this structure is that there is one concave element and one convex element. So the Infosys have appointed about 3 architects, and out of them they have taken one of the best this thing. Through this, the air will come inside, ventilation will come inside. In the daytime, there is no need of lighting at all. Okay, so that's the beauty of it. And then the air is also coming up. Okay, and then they wanted a good facade, not like a simple box select section. They have created a beautiful architecture. So I was asking Precast India Infrastructure, will you build another one? He said no. Because with a passion, when he started with the precast, he said, I took it with a passion, but I know the difficulties in this. I don't want to build another structure. But there's a beauty with the precast that is there. So thank you very much. Yeah, so it is. And say here one thing, precast here is to stay. It will come up in a beautiful manner. But as Yogesh said, the testing can be done. In Japan, whatever the new joint that we propose, they simply say test it, construct, test it, and then go ahead with construction. Similarly, we are doing a lot of testing here and there. but then the precast industry, we need lots of engineers also. Even I am teaching the precast subject in one of the engineering colleges at MTech level at Vijayawada. Okay, I also taught at NIT Varangal. Okay, on formwork subject I have introduced, precast subject I introduced. I go and teach at MTech level. Right, we need precast engineers. We need formwork engineers. Whatever the failures that are happening in India is because of non-design of formwork in a proper manner. Okay, very few companies are doing it like L&T or Shapoorji. Does really the formwork design and others are not doing it. So I'm trying to get that engineers giving that know. Thank you very much. 3 questions. Only buildings, no question. Please.
You said spoke about standardization. I have 2 questions. What is the basis of the standardization? And can we see standardization in many projects? Like for one project, suppose we have some certain columns and things, can we use it for other projects as well?
Right.
Like a retail catalog, where a structural engineer can pick and choose from existing, which would benefit the production facility as well.
All right. What happens is we usually get the plans from the architect, right? Architect will keep his windows at different locations, right? So we will tell them when we make this, suppose if it is a wall panel structure, we tell them that gentlemen, we want to standardize the wall panels, right? We give them an alternative of, we want to keep the windows like this, such that my panels will be similar. Same window will be coming in a panel like this. So this is how we are looking at the standard. So we will also look at it, then give a few sections. Now, in some panels I have to be like this. So maybe we'll create it in like 50 panels are with this type of window here, and 50 panels are like 2 windows in a panel. Like that, the number of elements that I'm increasing in a repeated manner, that comes as standardization. Then what happens in a table where they are going to produce this one element, the formwork that they keep for the particular one will become a standardized thing. Then the reinforcement that comes to that in a standard manner. Then the repetition of that element becomes easier. Similarly, columns. Maybe in the loading wise, one column may get 100 tons, other column may get a 50 tons, but I'll try to standardize them in such a way that it is somewhere between 100 to 80, 90 tons, like that somewhere there. We put all of them into one load. Forget about the 10 tons. Okay? Then maybe I can change my reinforcement, that does not change the reinforcement also. There also we standardize. But once we standardize that, then it helps a lot in the formwork preparation and casting and all that. The small 2-3 bars in the column does not matter, it won't be a cost at all. So that's where we do the mathematics and standardize. Similarly, the beam column spacing. Beams also we standardize such that it can be repeated. So for each project, we see the standardization and repetition of the same number of elements, such that it helps in precast production as well as erection easily. Okay?
So, sorry to cut short, just a moment. Yogesh sir wants to leave because he has a flight to catch. So we just want to give a small memento on behalf of SERC. Kind request, maybe we continue it during lunch because we are already running. Yes. Yes.
Next speaker is Dr. M. Gopal Krishnan. He is former director of CSR CBRA and also former colleague, chief scientist at CSR SERC.
I'll try to complete it very fast. was the director of this institute called Central Building Research Institute. Before that, spent nearly 2 or 4 decades in SCRC Chennai. And my experience comes from the various tests that we have done here as well as in Roorkee over nearly 2 or 2.5 decades. So, let me go to kind of academic the version of what Yogesh as well as our Prasad Garu has presented. So, then I introduced these kind of things into this institute called Central Building Research Institute. So we are running a project on mass housing, so which was CSVR mission mode project, and then we are trying to put 4 things, and ACRC was doing, and CBRA also was trying to do, and many of my learnings came from running this. Prior to that, during 97 or 98, Tony was head of the time, we had a very active entrepreneur who was working in Australia. Why not test these glass fiber reinforced wall panels for cycling? So that was, I think, the first foray into precast, prefab, insulated wall panels kind of things. And that's a very tricky business in the sense that I don't know, you would have experienced. Wherever wet areas you will have problems, wherever dry areas you can do that kind of thing. But then the experience that we got for combining 2 wall panels or a plus or L kind of things or P kind of things, trying to do that in the only uniaxial sheet table we had at that point of time. Then we went on to augment our facility with a large. And then it is so noteworthy. The fastest building. One of the criteria for any prefab buildings is, even though we put 3 S: speed, safety, sustainability, and so on. The speed is the prime construction. The time is the prime construction. Time is money, and whenever a big company wants to create a facility in Bangalore, it should have been done yesterday. They have to do that, and they tell that it is only 4 weeks of time availability. I mean, right? So it is only 2 months time available to you, and L&T or Shirke or those companies, there are half a dozen, 1.5 dozen companies which are existing. They have to speed with the time and do. So that's the main thing. And I had my own experience with Yogesh. Yogesh is not here. But then when Delhi Development Authorities gave a 28-story building to Yogesh, we started doing the quality control at field. And then I was kind of flabbergasted with that thing being done here, not being very familiar with the precast this thing. And we had our own fingers crossed. And then we tell that I'm going to Yogesh, I'm happy with your thing. You have a lot of experience, but let's not experiment that at Delhi. Let us do that in Bangalore, Hyderabad, and confine only with that. And we had a very heated discussion with him. I don't know, I'm telling things very plainly. Yogesh knows all those things. And we had a very heated discussion at Mumbai airport. And then I'll do free of cost. I'm walking away from this project, but then do free of cost some of your joints, whatever you want. So we need lot of sub-assemblages in Roorkee, and the experience that it gave to us is phenomenally good. And the personality which connected me with precast here is a guy called Shivachikamba. You know him very well. And then who gave us a lot of window into what has been, what we should do and what we should not do. In a very limited sense. But 2 or 3 days alone may not be sufficient for an institute like that. And given in SCRC, it's going to be the driver. I'm telling you, even at 4 or 5 years back, when I was actively there as a researcher, the driver could be precast. Because I have seen what these Gujaratis were talking about. You don't have time. Somebody has to manufacture that. It has to come here, assemble that and do the whole thing within 4 weeks or 8 weeks. I don't know for age stone building administration. So you have to do that in a neck-breaking kind of speed, and then masons or artisans are not even available to do them properly. So that's a driver. So India is much more in that kind of thing, being one of the third or fourth largest growing economy, third largest economy and the fastest growing economy. So this is going to be a driver which is going to drive you, and whether you wish it or not, it is going to push you into that. Am I right, sir? So that's the kind of thing that is going to happen. So I don't know. I'm not pretty sure. I do that. Yeah. Okay. Let me go back to. Sorry, I'm wasting your time. Little bit pedagogically, little bit kind of academic kind of thing, you divide the joints into a dry joint or a wet joint. So the evolution is you put a carbon and put a beam on the top and have a bolt, a J bolt, cleat angle and all those things and just that. But then it doesn't work so easily like that. So you have the wet joint coming into there, but partially I make this. These things are factory made, and some portion is a wet joint which can be done. Like there is a double kind of thing here, and there is a serrated kind of thing which gets joint, and you have cast in place construction partially and a precast construction partially, and a hybrid kind of things where you have rods welded on you. So the one question which Yogesh was trying to emphasize as well as Prasadji was saying, what is the displacement capacity? This is a $1 million question. What is the displacement capacity if I have to do that? Can I have 3.5% of the height or 4% of the height or that kind of car rotation, will that be possible? So that becomes a very big question for some of these. So he has also been talking about this thing. So how am I going to? I will cover the whole of this thing on only concentrate on what is called as a couplers. Precast industry is a little bit worried about what is happening in the buildings. The bridge, it is well established, right? In the bridges everywhere it is precast, girders, precast kind of things. And as in the first lecture, Professor from Sunny Professor was saying, the damage angle, how am I going to, and the tessellated kind of restrictions. These are all the kind of thing which has been in vogue for bridges. But how are we going to take it and adapt to the normal building is a big question. So can I tell that I will have a thing and then make it rock and then tell that there's an energy dissipation? Keep your fingers crossed. I will not be very happy if my columns are going to rock here and there, back and forth, and give a large displacement. No, I'm not too much for that kind of thing. But then there is influence of play area. Play area is what they tell between this this element which is a coupler to somewhere in between. They are not exactly at the end of the column. There is some area that comes where you have this thing. What are the use of all these things? You will just see in this thing, and they are all taken from the work done by Shivachidambaram. After we had a very probing question to Yogesh that I am very not happy with this DDA project, and then try to do 50 of his because much more than that. Okay, much more. So effective and resisting seismic clouds. What is the effect of shear keys? What is the wet connections and all those things? I will try to cover in this particular this thing. So the interface element. So whenever I say I give a very pessimistic picture of this whole thing, like you have a building and then Rockford said that now the buildings, because buildings wait. One ground story building, which is for a school, failed in India, I will not mention, but then it gave a lot of lessons. We have come a long way. We have come a very long way after that, I will put it this way. But then there is a failure happening, and very ironically, the failure happens even at the gravity load at trains. I have assembled my precast and then go away, or there is a very small kind of mistake here, everything is under control. The progressive collapse happens without even you are thinking that there is a progressive collapse. Maybe some of you can defend that kind of thing. That happens. So how do I prevent? How do we have redundancy in the force part? How do we have a kind of thing like if a small thing happens here, how the force distribution or redistribution happens on this thing is a big issue. So you have starting from these kind of things where a small this thing is made, and then you can very well visualize that could be unseated. So you have a beam coming into tension, you are thinking that the beam in the interfacing beam is not having a tension or compression, it is going to have a tension, it is going to be unseated. And when a single beam unseats, you will see that the entire load comes to the ground. How the garage structures, you will see that I don't know, I'm not very sure. I had this opinion, that kind of thing. We will go only for garage structure, we will go for only these kind of structures. At least in the seismic areas and watch what is happening, but not to go into. Up to Mumbai, it's also okay. For me, it is all okay. But when you come to Northern India and then try to have a totally stored buildings, maybe that was in me. I'm trying to change my opinion on that. So that's a kind of thing that can happen. So this is Anna University has done some kind of work on these kind of things here. And partially, this is what you have been telling for. Huge beams with kind of seating here. They are all seated on this clip, and then you will put the reinforcement there, and later on do the concreting for this, as Shishke was trying to do. So this could be an alternative where you have a bigger portion which is to be concreted, and you have the couplers here, and this red portion is what you introduce in the later on during the casting stage. So this gray portion is what is being done. So this will be done as well as these things are done in the field. So you have any number of possibilities that can exist, and the last possibility here is you put a steel plate embedded inside the column, and the steel plate continues here and joins with another plate which is in the middle. So a lot of possibilities exist, but which is a good possibility. And whenever you see the failures, sorry for taking a little pessimistic opinion on that, all the elements are on the ground. You have 1,000 elements, 1,000 beams and columns, they are all invariably at the ground. So only at the joint there is a very small time. But that you tend to take a kind of opinion, what are we going to do for this? Okay. So how the sequence of construction, how the masons have to be bothered about, and all kinds of things with 24 meter span of your hollow block pre-stressing and all those things being done. So we have our conventionally we have some problems in this, and in this particular portion we try to do only this is the one that we try to do. You have a kind of curves where both the things can be both the things can be grouted, or one portion is grouted, another one is Ramarao may be here, and then he will tell about what has been done for the Shero. I think that was for Amit's project there. And one portion is grouted, another is threaded, or both of them have, I don't know, coupler and all those things. My remembrance tells me that coupler has performed well. Maybe he can throw some good light on this. And then bolted from the sharp point. Secondary results is so we try to investigate a joint, something like this. And we call that as hybrid kind of joint. And there are steps, these are all evolving. Again, I am telling you, these are all evolving in the sense that they are moving towards perfection, tending towards perfection. That's what is happening. We have a code of practice which is coming. I think you have a role. IDEA Hyderabad is playing a major role, and I think so. And many of them are giving input to that so that we can fine tune some of the tests that are to be done. And starting from static tensile test, our game is very simple. So I have a joint which you can call that as emulated. Emulated means tending towards the monolithic element. The monolithicity is the keyword that is to be followed. So I have a joint which is emulated, and then I have a force deformation curve for a very good joint with beam and all those things. How much I am going towards that by all these things that I am trying to reduce. What is the slip? You have a bond. Slip comes where? Whenever there is a bond
and the bond, the failure relationship. You give a small slip, maybe it locks after that, but then there is a slip that can happen. Cyclic can say low cycle, or earthquake it is low cycle failure, etc. These are all the things that can happen here. So sometimes you do the fatigue here, and beyond that, you allow it some damage to accrue on this, and then go and test after that, and whether you have the same curve that is happening. A small UTM. The irony of this whole thing, when I went, I was trying to take your attention on this. When I went to Roorkee, this guy who did that was doing his test in open air. Can you imagine? No lab, nothing, and then open air he was doing all these guides and other things. Then we built a lab, then we built another lab, then we took a Ghaziabad lab and tried to do what can be. It was a small light at the end of the tunnel that was going on. So, but they are in no comparison with the kind of facilities they have in these institutes this year. One of the very largest institutes. But still, I will feel that one more reaction now has to be done and you have to go for maybe 12 meters, 14 meters. So, with this, given the spark in that individual, we have been able to make some small this thing in this. So, he was trying to have a hybrid coupler. You can have the important things is the pre-stressing. The precast can't go without pre-stressing or grout or I don't know 2 or 3 keywords for this. You can't handle precast if you can't handle grout. If you can't handle pre-stressing, you can't handle what is the various other aspects. So these are all the key elements of this whole thing. And then crimping. Crimping is another way of doing that, like you do your electrical cables. So these are all the kind of things. And let me go to this few tests. Some of them behave like this. Some of them are good behavior and all. So these are all the elemental level tests that have been done. And universal correction. But how it was proposed at that point of time? Maybe we come back on this. So I have a joint which will work for beams, which beam to beam, it will work for beam to column. It will also work in the same fashion for column to position. Can it develop a joint here? So that was the kind of thing. Maybe we are successful, maybe we are not successful, but we try to work into this kind of thing. So there is a so this is a portion which is cast at the site, and this is all available. And I have a shear reinforcement here. There is a rebar coupler. Rebar coupler. The first time I saw a rebar coupler, Bharat was not there. Is for the metro. When the metro thing was opened, there is a solid bar of metro. This thing. Top down and bottom upward. So the metro is a very challenging kind of construction, 24 meters down. Now it may be maybe 48 meters down, much below the existing zone. So that's a kind of challenge energy and all those guys are facing. So the first thing we saw there is there's no reinforcement protruding from the walls, only couplers. So how are we going to connect the couplers and then going to do the shear? So we try to develop these couplers here, and there is an interface, and you give a coating, and there is a friction developed here, and there is also a shear key that is being kept. So let us see how all these things are different. And then the NDT of this grout that is going. I want to show that the grout has gone very well and then outside all the places. No way. So is there an NDT available? Not even NDT available for this. So how are we going to take care of those things? So precast beam and column elements. The first thing I think he has taken is between this beam and column. So what he has tried to do is take this, introducing these couplers not at the column level but at the beam level here, and the alignment of protruding bars is done by the coupler, and there is some kind of FRP or the polymer kind of this thing which was being done to confine that couplers. The disadvantage I did. 2 times the diameter, 2.5 times the diameter takes away a lot of space there. So you have left with a very small portion which is a cover, and how are you going to take care of it? The essential dimension increases. I'm not only for the couplers, but when you see, I have visited, I could not visit Yogesh practice, but I did visit KEF factory, which was a brand new, I don't know, should you go here before you hit Bangalore? There was a massive, you might have gone there, sir. So there is a massive factory there by this company called KEF Catra. Initially it was Catra, then bought by
Now it is with JSPL.
JSPL. So 2 or 3 hands changed in between. But see, but I will only tell that the forerunner of all these things is 70s. And nobody thought that this is going to happen. We are perfecting our monolithic joint, but then they have started thinking that this is going to be. So that's a kind of foreseeing that Shikya has tried to do here. So there is a loading history which is as per ACA. See, this is the problem. 3.5%, 4%. That's the kind of that you require. Suppose you have 4 meters or 5 meters tall single element. So 5 meters into 4% of that 5 meters. Okay. So that's the kind of displacement demand that you want to get from that. So how much it is for 5,000 into 4 by 100? 200 mm, right? So that's a kind of displacement that you have to get for a single. How is it possible? So where is it coming from? So that will be a kind of thing. So what we try to do is see this hysteresis curve. This is for monolicity. This is for monolicity. And when we introduce some problems in that, like I will not follow the detailing as has been given in 1390. I intentionally will not follow the detailing as has been done there. So the development length I will reduce, or I will not take this bar and bend it like this, but take it upward and all those things. So all of them will apparently just to see this curve compared to that. So you have 19.4 and 25 kilonewtons here on this side with a displacement of something like 6% drift for the particular big car. So you have, I don't know, here he has given millimeter, but then 21 and then 30.3, you have an asymmetry coming here, and then it is getting pinch, right? So for everything, but so the lesson that you need to know from here, so it's precast is not a panacea for skipping some of the detailing provisions that which 13920, but I follow those detailing as much as possible. Then you have the precast also. So after, okay, this is okay, these are all bad things. So this is the kind of thing where detailing was followed and all those things, and it is slightly better. So these are all the kind of things that you learn here. Okay. So you can plot some of these things. Envelope curve, then the damping behavior, cumulative energy, relative energy. There are 3 things there. One is stiffness degrading factor, strength degrading factor, and what is a pinch. Okay, take your hands and press your skin like that, the kind of pinching that is happening. These things have to be within the limits. Strength degrading or stiffness degrading or the pinch. And how much close you are to the actual structure is that you have done a very perfect kind of design. So here it is the second case study where there is a connection between precast column to the foundation. You may see here some of them are like this, and there are many experiments that have been done on this. So you have a joint which has been this thing coupler bound by cracks, crushing of concrete. Let me try to get some keywords on this whole thing. So, okay, let me see. This may be. You can see it here. It's exactly like this monolithic. So that actually shows that you are not followed. You have been trying to follow not only the detailing, but the kind of thing that is to be followed, despite the fact it's 2.5 times the diameter of the main. And it is confining only from this thing as well as a ground. There is a ground whose help you really do not know after that, but then you have 90 mm here, slightly more here, 20 kilonewton here, and slightly more than 20 kilonewton, and 30 unsymmetric, and here also it is slightly less than that. So you have almost gone tending towards the monolithic thing. So one is with One is with normal concrete, another is with high strength concrete, ECC, then steel fiber reinforced concrete and all those things. So he has done some works on it. So you will see some other results how this is. Then the last one that I am going to present here, you're happy? The last one I am going to present here is, I will take a pure flexure member like a beam and introduce a hinge at exactly at the middle and then try to see what happens. So this length, this small length which is away from the coupler is varied. Either they are close to this or somewhere removed and all those things. And cracks are not going to happen here. Cracks are not going to happen at the place where you are coupled. They are going to happen a little bit away. We would like the cracks to happen in these kind of places. And the joint should remain as such. That's a far cry, but then that is what you are expecting that to happen. So the couplers are here, are moved away, and there are very many kind of possibilities that can happen here. So that is what has been done, and these are all the various things. I will maybe this will share to Bhati will share to you. And when once you have done these kind of things, so we have. Okay, let me finish this. You can observe the single large crack is always a problem, right? You don't want that to happen, but that's what is happening here. It is opening. I would like the damage to happen widespread. I don't want a single large crack to happen and then consume your thing. That's an indicator that it is not a very bad, it's not a very good detailed kind of things. But then that's what happens here. And just to see these two curves, which are here, and that is TS8. I think so. That is this fiber reinforced kind of matrix connected with this, and there are some conclusions that you think that this is your dots for making your displacement displacement measurements. So lessons that we have learned. I'm not going to the I don't know what to tell here. So you have some of them which are exactly like the black curve is the monolithic kind of curve. You are exactly going to that, and you have this is the place where coupler is there, which is relatively unaffected. The rest of them are affected. But is it going to the original concrete? We may not be able to. We may not have achieved as much structure as that. So this is the last one. Resist the slips of coupler given with short fiber length due to fiber bleeding mechanism resulting in excessive multiple crack formation is what it tells. Near to the element interface includes severe cracking besides supposition. Evaluative connection failure to conventional beam with optimized coupler length and all the coupler length. How much it is close to the beam column. There are very many design parameters that needs to be followed. Absence of shear key. You have seen, you have seen. I will just skip wherever the shear key is removed. Okay, let me go back to that. So the last one here is without the shear key. The shear key which is here, which is having a protrusion inside and then going that way. Okay. The last one here is without the presence of shear. Somewhere the curve is bad, the interface is not having a proper friction mechanics. So you can see very many things which will show up in your test, and that is only supposed. So when are we going to do, at least in CSER, CSER, when are we going to test ground plus 3, as Murthy was all the time. So that's still a way off. But then we have learnt a lot. We have been also slowly doing, but the practice is not going to wait for you anymore. The practice will push you and better catch up to what the practice is trying to push you. And it is high necessity that this kind of things are being done at SCRC. You have a necessity to do more topics on this. Not only 3D printing. 3D printing is okay to me, but that is on the peak of the Gartner. Gartner curve has to be undergone, and then you need to have a criticism. It will fall. It will fall and become a practice. I don't know how many of you have seen what is called the Gartner curve. I have a hype which is dictating that. I have a very big hype, and afterwards it falls and gets settled down to the regular practice. So, how are we going to evolve this to that level? There is a necessity, better take to that necessity. So think in that lines. It is not going to be a homogeneous or monolithic kind of things anymore. So you need to think in a kind of things where your imagination matters, but safety is paramount. With this I stop. I will forward your doubts if conveyed to my colleague there. He will have a better listing of this. So, thank you.
If there are any quick questions, you can take.
Yeah.
Every time we hearing that all the joints, all the rods could not be.
No, you can't do.
But
sorry, you can't.
But in case
you need to have, you can't do that. I have a coupler here, break it and stagger them.
But in case of because most of the things that they are doing in all the couplers are all.
That's what I am telling.
That's the problem.
You have no other way. But then develop.
Just left. Even in precast also, we are staggering the couplers.
Yes, sir.
Not all of them are coming from that.
The new code term
Ask him. I was having an opinion that you may not have you may not be able to stagger it properly. And there were too many things. Staggering is going to introduce another rigid kind of portion where steel is occupying all of it. But you need to have a yes, sir.
We are staggering.
So I have to be the bad person here to stop now. We'll proceed for lunch, but before that, as a token of our love and gratitude, we would like to present mementos to both our speakers. I request our director to do the honors. So thank you so much for attending the morning session. We'll break for lunch now. I request everyone to please try to assemble by 2:10 so that we'll start the next lecture by 2:15, which will be by Professor Vaisi. He'll be joining online. So enjoy your lunch. Lunch is arranged in the dining hall. So for the online participants, we are breaking for lunch and we'll be resuming the session by 2:15. Yes, ma'am. Just waiting for a few more people to join, so we'll start shortly.
அவங்க பேசுறது அதுலதான் நடக்குது இதுல ப்ளே பண்ண மட்டும்தான் just take the videos play
No, you're checking the presentation. Record video?
No.
This off?
Okay.
Good afternoon, Dr. Professor Ravindra Singh. Yeah. We are audible, right, sir? Professor Vaising, are we audible?
Yeah, I can hear you.
Okay, sir. Yeah, so, dear participants, our next lecture is by Professor Vaising. He is a renowned faculty member from Department of Earthquake Engineering, IIT Roorkee. Sir, you can please share your screen.
Okay, I'm I guess my screen is now visible.
Yes, sir. PPT is not yet visible.
Is the PPT visible now?
No, sir. Yes.
No.
Yes. It is visible. Okay, sir, you can start with it.
Okay, so thank you very much. Thank you.
Sorry to interrupt. Sir, it is not in slideshow mode. It is in presenter mode.
Sorry, it is not in presentation mode?
Sir, it is coming with the next slide. So it is coming as a personal presenter mode. I think if you have multiple screens, maybe you need to. Yeah, now it is.
Try changing the slide.
Now okay.
Can you please change the slide, sir?
Is it okay now?
Yes, now it is.
Okay, sir.
Okay. So, good afternoon and thank you very much. I wish I was physically present there, but I am missing that opportunity. Anyway, I just want to talk at least online to this other gathering about seismic safety of PRECAST system. So I work in earthquake engineering department, so naturally my interest is on earthquake safety of PRECAST systems. There is no doubt that PRECAST systems are the construction systems of future buildings and structures will be cast in constructed in constructed in factories, and then those will be assembled on site. So precast construction has to be there. There are some problems and there are many advantages of precast systems. We have to cope with those, and then we can make full use of the potential of this technique. So there are many advantages. All of us know that it is providing very high quality control as compared to what we can achieve at site. It provides good integrity and durability. There is design flexibility. We can get different colors, textures, shapes which are difficult to get in situ, and then construction is quite fast. So these are all advantages. I don't want to repeat. There are many positive points in favor of precast construction, and hence in future we have to go for precast construction. Now there are some issues, and the issues are that it needs transportation of heavy components. So heavy weights are there which require lifting and handling machines, and high accuracy is required in design and construction because the margin of error is less. As compared to monolithic construction, we are working on smaller margins, so we have to be very careful. And the connections are the main issue. So connections between different members, those are difficult and complicated, and those connections are subjected to large forces and displacements during earthquake. And sometimes some people say that it becomes a monotonous type of design because we are repeating the formwork and we try to take the advantage of scale. So sometimes it becomes a little monotonous. And skilled labor is required. The construction and joining of the components at site requires relatively more skilled labor. And most of the times it is one-way system. Achieving two-way system is difficult, and the tolerances available are small. We have to work within those tolerances. Now, as we know, and we see around us, the precast construction has become very common in case of bridges. And one of the reasons why it is so common in case of bridges is because the superstructure in a bridge does not have much role in seismic resistance. The earthquake is resisted mainly by the substructure, and superstructure is just sitting on the substructure as a mass during an earthquake. So that's why in case of bridges, there is much common use of precast technique, and different methods have evolved where the superstructure as a whole, or it may be constructed in segments. So similar common adaptability in case of buildings is not there, at least in India. And the reason is that in case of building, the integral frame action is the key of earthquake resistance, and where the beams and columns both together make a frame to participate in lateral load resistance, and the joint between the beam and column becomes very important. So the design philosophy for earthquake, which we currently follow is that we depend on both strength and ductility. So if I present a schematical design philosophy which we are currently following, so we get the demand in terms of response spectrum. This blue curve shows the demand, and then we reduce that demand by a response reduction factor R. This response reduction factor R is responsible, or it takes into account the overstrength and ductility. And we depend heavily on ductility. So this response reduction factor currently in our code is 5, which is being increased to 6, and in some codes it may go as high as 8. And then we design with some factors of safety. Actual strength of the structure is higher than what we have used in the design. And that difference we call overstrength. But still, this overstrength or the capacity of the structure with overstrength is also much less than the demand. And this is taken care of by the ductility. So we depend on a combination of strength and ductility, and ductility is responsible for energy dissipation. And because earthquake is a cyclic load, we get a hysteresis structure, and due to inelasticity and ductility of the structure, there is low and energy gets dissipated. So whatever energy the earthquake is imparting to the structure has to dissipate the energy at the same or at a higher rate. Then only it can survive that earthquake. So this energy dissipation is the key issue in our current design philosophy for making our structure safe against earthquake. Now, this ductility and energy dissipation capacity varies from structure to structure. So, in case of steel structures, like I have shown in the previous slide, there is good energy dissipation, but in case of RCC structures, as compared to that, there is pinching action, there is cyclic deterioration. So due to that, the energy dissipation capacity decreases. Now we are not sure that what capacity we are going to get in case of precast concrete construction. Actually, people are skeptical that how much energy this system will be able to dissipate, and that depends upon the joints between different components, and that is why most of the codes, including our code, does not allow precast construction in seismic areas because the energy dissipation capacities are still doubtful. So two types of systems are common. We all know that, and I'm sure the previous speakers have talked about that. One is the equivalent monolithic system, or what we call the back connection system. This system is similar to the monolithic or cast-in-situ system, and we can get good energy dissipation capacity here. On the other hand, the jointed system, or what we call dry joint system, there the connection is the weaker link between different components. And here the connection undergoes a brittle failure, and the chances are that we do not get good energy dissipation capacity in this case. So here is the first figure here is showing a bad construction or equivalent monolithic system where the reinforcement from the precast systems is projected and overlapped with other components, and part of the structure, especially the joint part, is cast in situ, and the reinforcement is either overlapped or it is connected through couplers with the reinforcement of other components. And it is almost similar to the monolithic construction which we are getting in situ construction, and that's why here we expect that good energy dissipation capacity will be available. On the other hand, in case of dry-jointed system, the connection is weak, and generally it is just an anchor which is to keep the precast elements in place. And this is the weaker link, and failure, there is stress concentration and failure occurs at these connections, and due to that, energy dissipation capacity is not available. So this jointed system, this has limitation in terms of energy dissipation capacity, and in past, most of the failures during earthquakes have been observed due to this dry joint system. And the failure of dry joint system occurs by shearing of either studs or pull out of anchor rods, splitting of concrete, then brittle failure of the beds and bolt threads during earthquake. And this dry or mechanical connections are a point of high stress concentration, and that's why most of the failures are localized in the joint region. The workmanship of the field connection, that is also of questionable nature, and the site welding, which is generally required, is of brittle failure. And then the dry connections, these are more suitable for panel walls and floor system of low-rise buildings. These are not very suitable for frame or lateral load resisting system of buildings in
high seismicity areas. One such example is this where we have this peripheral column spandrel beam system. So columns are more or less monolithic type, and the beams are simply supported on these brackets which are projecting from the columns, and those are connected through some anchors. And naturally we can see that during earthquake, when the force as well as displacement is applied on these systems, the beams may get dislodged from the columns. So another system where the beams are simply kept on either brackets or projected part of the columns. So during earthquake, there will be movement, there will be relative displacement, and due to that relative displacement, there is a possibility that these beams fall during earthquake. Now, the seed weight which is achieved through this bracket from the column, that seed width is small, and because energy dissipation is not there, yielding of components is not occurring. The displacement during earthquake is going to be large, and this seed width is not adequate to accommodate that much displacement, and failure of or falling down of these beams from the columns is commonly observed. Now, different systems to safeguard that have been thought about, and one such is we use pre-stressing cables. So just an animation I have here, which will show that how the relative movement between beam and column is taking place. In case of a monolithic system, when this type of movement is occurring, yielding of beams is followed by that, and that leads to energy dissipation. But in case of a precast construction, no such yielding is taking place, and as a result, there is damage in the joint region, or there is unseating of the beams from the bracket. As we can see in this figure, the bracket portion projecting from the column has got damaged, and it may lead to unseating as well. In case of many earthquakes, this unseating and falling down of the beams has been observed. One such photograph is shown here, where the columns have, the beams have dislodged from the brackets and have fallen down. Falling of precast flooring system, floor system, that is also observed in past earthquakes due to the large movement. Again, due to lack of energy dissipation, large movement occurs, and generally the precast system is not able to accommodate such large displacement, and it falls down. On the other hand, if we have equivalent monolithic system where we are having wet connections, then this is more or less like the in situ cast system, and it has excellent performance during earthquake because it behaves monolithically, it provides continuity, and because the joints are monolithic, then it provides redundancy and integrity to the system. As a result, we get energy dissipation. One such system, how it is obtained, is shown here, where the reinforcement in the or the reinforcement which is projecting from the other components is overlapped, and then casting of some portion, joint portion, is done at site, and as a result, a monolithic like construction or system is achieved. One example we can see here, the columns and beams are cast separately, the reinforcement is left projecting from the members, and that projected reinforcement is overlapped, and then the concreting in the joint portion is done at site, and we get a monolithic construction. At a site, how it is achieved is shown in this figure. In case of exterior or peripheral columns or peripheral frames, and in case of interior frames where we are having beams coming from all the four sides, we have to leave some brackets so that the space for concreting is left.
and concreting can be done in the joint to achieve monolithic construction. Another a very promising system is this column tree system. In column tree system, the beam column joint is also precast. So the portion of or a small part of the beam, or sometimes the half length of the beam, is cast along with the column. So it looks like a tree with branches. So the column is, the beams are forming the branches, and these are assembled together in such a way that this monolithic cast in situ construction, cast in situ joint is not appearing at the beam column joint. Rather, it is occurring at the mid span. And we know under earthquake loading, the bending moment diagram in beams is such that we are having zero moment or very small moment at the mid span due to earthquake. Although the moment due to gravity will be acting here. So we do not expect any yielding here. So this joint is not subjected to excessive stresses, and the portion where, or the joint where we are expecting the inelastic stresses to occur, that is precast monolithic portion. And as a result, we expect good energy dissipation capacity here. Different types of connection details have been worked out. So as we can understand that roughly a portion D from each side will be subjected to or will participate in yielding of the reinforcement during earthquake. So that portion is not jointed at site. Distance D away from the face of the column, this joint is provided in the center of the beam, and then this acts like a monolithic beam column frame. Different types of reinforcement arrangements have been worked out. One such arrangement is using diagonal reinforcement, which we use in case of spandrel beams of either coupled shear walls or frame tube buildings. Now, what we have seen in the past earthquakes, that precast construction has, although it has many disadvantages, it has some, many advantages, it has some disadvantages also. And one such problem is during earthquake. So its performance during earthquake has not been up to the mark, and that's why the people are skeptical in using this in seismic areas. So many of these earthquake-related failures have occurred from poor design, deficient diaphragm action, inadequate detailing, and deformation issues, because earthquake not only causes force, it causes deformation also. And our structural system should be able to absorb that deformation. And it has been observed during many earthquakes, Tangshan earthquake, China, Michoacan earthquake, Mexico, Northridge, and also during Bhuj earthquake. Some precast buildings were subjected to earthquake test, and damage was observed. Then poor performance of precast building is due to improper design and detailing, as I said, and mostly the poor joint in case of dry joint construction. So that has been responsible for the damage. And collapse of floor was due to loss of seat width, mostly because the displacement was more than the seat width, and as a result, the floors and beams fell down. Now, same was also observed during Northridge earthquake. With this challenge, some people have thought of this challenge as an opportunity. And one approach which is coming up in literature is using energy dissipation at the joint. So rather than dissipating the energy through yielding of the structure, because here large movements are occurring at the joints, that movement can be used for energy dissipation with some special devices developed for this purpose. One such device is for the shear walls. So when we are using shear walls in monolithic construction, this will be either a monolithic joint or it will be connected through coupling beams. Now this can be, this joint in case of precast construction, because it will be a clear joint, this can be provided with some metallic connectors, and those metallic connectors will dissipate energy. I have downloaded a video from the internet, and there you can see that how it works. I will show only the relevant portion. So you can see here between the portions of the panels of the shear walls, these devices are provided, and when these walls will be subjected to displacement, these will also be deforming, and these deformation will be inelastic, and as a result these are going to dissipate the energy. Then another type of system, similar system where energy dissipation has been used, where this energy dissipation device is provided at the column. So rocking type columns are used. Pre-stressing cables are also provided in these columns to keep these in place. And when it is deforming during earthquake, it is, you can see that when the column will rock, these are going to move and energy will be dissipated. Another system is where in the beam column joint, this type of devices are used, and when it is subjected to deformation, so this animation shows how these devices are fixed, and when it will be subjected to movement during earthquake, this will be subjected to deformation. These sleeves will deform, and as a result these will dissipate energy. So that energy dissipation which we could not achieve due to yielding of material, we are trying to achieve through yielding of these special devices at the joints, at the base, so that the displacement can be controlled and the forces also can be kept in the limit. So thank you. That's what I wanted to talk. I hope I am in time, and if there is time, I will be happy to take up some questions. Thank you.
Any one or two quick questions we can take from the audience, offline or online.
Am I audible?
Yes, sir. You're audible.
Is there any question? I will be happy.
Yeah. One of the issues is like we have the precast wall connections with the shear joint, with the shear loop we provide. That itself we'll call it as a seismic dissipator. In the case of an earthquake, that will dissipate the energy there, and then the element jointed will be grounded. So that is already doing the work. Why do we need a separate dissipator? Are you able to hear me?
I think maybe.
Professor Vaisen, could you hear the question?
Sir, could you hear my question?
Hello, am I audible? Dr.
Yeah, now you are audible.
You're audible, sir.
Are you able to hear my question, or shall I repeat? Hello?
Hello.
Hello. Sir, are you able to hear the question? Is it audible?
Sorry, the voice is cracking. I'm not able to hear clearly.
I think signals are not good. All right, we will send the questions to you.
You can tell. We will email you.
Sir, we will send the question to you. Okay.
Okay.
Problem with
He's
So
able to
you are sending the question by email.
he is able to hear whatever you are talking, right?
You can ask. Yeah.
Sir, should I relay the question on the
You can read out the question in the mic.
I think he is able to hear Sunil.
Only
You can do that, huh?
maybe mic is only.
Right. Sir, are you able to hear me now?
Yes. Now I can hear.
Alright. See, in the question of precast walls, we do two connections. One is the shear connection with a shear loop, okay, across the joint, leaving a 20 mm gap with a backer rod and all that. And that is principally provided to dissipate the energy itself. In the case of a seismic force, let the element crack at the joint, but the wall element will not crack. Right? So have you studied that particular system? When we are providing that, there is no need of any separate dissipation element between the wall panels. Do you agree?
Yes, I mean, although I have not studied this particular system, but many solutions are possible where we dissipate energy because the limitation of precast system is that it has limited energy dissipation capacity. So if we supplement energy dissipation by some means, and that's where we have to use our ideas, our creativity, that how we can dissipate that energy. So we can dissipate that energy in many ways, and through some testing we have to show that that energy dissipation is adequate for the target hazard level, then it can be used.
All right, thank you very much.
Thank you, Professor Vaising. Thank you for promptly
Thank you.
deliver the lecture.
I will close now.
Yes, sir. So we'll move on to the next talk. This is by Sri Amit Bade. He is currently heading the PRECAST initiative at LMT Construction. Welcome, sir. Yeah.
No, he will present from there because he needs to share his presentation from there. Not like it is a way.
After time, I feel working at an insurance company. That's a class, all the videos then class.
Is filling, but for the past 2 hours he is telling.
I'm just looking for that link.
Link
Yes. He has to change the slides. Or we temporarily put a chair. Yes.
Yeah.
Share it.
You can connect it to
Yeah, we have C tape, sir. Power. We have C tape.
You can just connect. Yeah, we can keep it on. No issues.
But you need to unmute it. Unmute the mic. Oh, his mic. It will be working on his mic, right? Yes.
Charging. Charge. Yes.
Sir, I think you are muted, so you need to unmute it.
The other one was muted.
Yeah, the other one is muted.
His PC is connected, not our. His laptop.
Okay.
Okay.
Can you all hear me?
Can you all hear me?
This is the echo.
I think
This, hello? Better, no? Yeah, now you can hear me.
Wait. Unmute ours. I think he muted his. Unmute ours. So just a second.
Now using online ways.
You are changing the slide from yours, but the mic is picking from ours.
And it will start double.
There is echo. I think you have to mute the IPTV thing. I think.
No, ma'am. Now we
Can you hear me?
Yeah, ma'am. Now we have muted sir's thing, and we'll be picking the audio from our system. Ma'am. I think now it should be okay, ma'am. Is it okay now?
Previously your laptop speaker is on laptop.
Ma'am, are you able to hear us now?
Yeah.
Okay, that's fine.
What's happening?
All good? Yeah, I was just telling him that a lot of times we feel like we are working in a defense company more than a construction company, but we have now, I think the size has gone so much, projects have gone so much bigger, information is gold, so everything is locked. Almost everything we work on the cloud itself, so but that has its own advantages also, so is what it is. Yeah, good afternoon or good evening everyone. It's always a pleasure to be in SERC, especially for today's topic where we are discussing precast, and we are going to discuss about last decade of L&T in precast, primarily in buildings, infrastructure. Like we said, we have been doing precast for long, 30-40 years. I'm going to show some pictures. But whatever last 10 years precast that L&T is done in the building space is because of the blessings of IIT Madras and SERC. So I want to take this moment also to appreciate all that whatever entire test program we did, and all over India we still boast that we are, I think, one of the first to get that program done Dr. Gopal Krishnan was there, so he was actively involved in setting up the entire specimens, whatever testings that we did. So we really appreciate all that help. Like I said, we are going to discuss more on the buildings and the whole precast what L&T has been pushing. The topic today is recent precast works. When I went to the speakers list and I'm sure the crowd here also more on the research mode, academic mode, and our discussions was you tell whatever that you have been doing, and that's what my focus is going to be. I'm not going to focus today on the test or research part of it. We have spoken enough since morning, and it is in very similar lines. Whatever we did also, we got a very similar behavior, similar responses. In our mind, the entire test programs, what we are still doing, is still a due diligence type. That okay, we want to build our comfort, so let's test it and do it. But before even we get into the design drawing board, we know the systems are going to work. Now, why we know? Because if you heard Professor Singh also now, is whatever that I am showing, whatever that we are doing, is all emulative detailing. Like that, I want to be very clear right from the beginning. We are not there where we do jointed systems. I worked in the States for about 10 years before I came back to India, and I had not seen wet connections before I came here. Everything was jointed, everything was welded connections, much faster than what we are doing even today's age, but over the time it has to evolve. We have to do a lot more testing there. The systems there also are evolving. They are also doing a lot more work in terms of the energy dissipation. What you show, I think there is our Dr. Sridharan is there. He is doing a lot of work in that. So that will evolve. But right now, whatever that we are doing, whatever that I will show you is going to be these emulative systems. Again, like I mentioned, topic today is to give you a flavor. So if you heard Dr. Gopal Krishnan, he made a very subtle point, but I'm going to pick on that. The practice is not going to wait. He mentioned that your academia research will continue. Practice, industry practice will push. And why industry practice will push is the industry is changing drastically in last 10-15 years. The India what used to be 15 years is not the India anymore. I was discussing something over the lunch, and 2019, one of our this mass housing order was 5,000 crore. We had cut a cake saying one of the largest order of the business. That is entire buildings and factories unit with a huge revenue even in that time. 5,000 crore was the largest order. The orders that today we are seeing are 50,000, 56,000 and 60,000 crore. The scale has gone 10 times. Maybe not in our industry but everywhere. And that's the kind of scale it is already demanding the speed from you. Right? 2 weeks ago I've had and sat with saying I want 40 lakh square feet built in 16 months. This used to be 46, 60 months 10 years ago. That's the kind of expectation, that's the kind of delivery is coming. That's why we are doing. Because otherwise L&T is a contractor. We are not in the precast business. We are in the business of building buildings. We used to use beam column. We moved to aluminum formwork because we wanted that speed. 2010, our management, blessed with vision, they felt that this aluminum formwork is also not going to be enough. The kind of speed, the kind of demand is coming. You have to do something else, and we switched to precast. We've been doing that for 10 years. Some of the structures, if you see on that whole thing, practices we have been doing. Like Narendra Motera Stadium has been total precast. We are building the high-speed railway now. And believe it or not, the team is more excited about that straddle carrier that we have built in-house than the girder. The girder is a day-to-day business for them. It's a 1,000-ton girder. It's a 40-meter long straight. Actually an engineering marvel, but they still talk about how they build the straddle carrier and all, because the girders they do day in, day out. We have built the Atal Setu, if you see. This is of course not RCC structure, there is RCC, but this picture particularly is from a steel orthotropic deck. The scale what we are looking at, the scale that we are looking at this is 150 meter long, it's a 12 meter long girder, and it was placed between the piers in 2.5 hours. That's that rapid construction what we are looking at. Why we are spending, this is at least 6 times more expensive than even RCC construction. But they needed that speed. If you want to put that scale in the picture, it doesn't become obvious. But you focus here and those are the people sitting. And now you look at the picture again. The entire barge was built to carry that on water. It is hydraulically controlled. The beam doesn't even move up and down within 5 millimeters. And 2.5 hours, regular construction will take anywhere between 3 to 4 months to do that. And this is where that technology, what we are looking at in most of the projects that you see across these pictures are across Mumbai, but you will see that. And this is where that pressure started coming 10 years ago on the buildings industry itself, saying, okay, this is what we have to build faster. Then the mass housing scheme came, PMAY came, and the scale of housing industry itself changed drastically. Right? What used to be a 200 houses project, 600 houses project, 2000 houses project started coming in terms of 20,000 houses. We are looking at now 2 lakh houses in Mumbai. Give me in 36 months, which used to be 80 months, 90 months. And this is where the technology is coming from. So we built this because I think it was more of a what the technology can do. But whatever that building, it's a real building what we have done. And this building was built in 36 days, flat structure, like 3-day floor cycle. Every floor was built 3 days to showcase the technology, saying, okay, we have built it. That practice is not waiting; is practice is developing that capability, saying, okay, if you want that, we can deliver. Right? This structure that you see, this was done about 4 or 5 months ago. It's a total precast structure, beams, columns, hollow core slabs, 4 shear walls, and was built in 40 days, including the paint. It's a 330 car park structure. If you do in conventional ways, our own L&T speed itself, it will take at least 180 to 200 days. So that's the takers. People are there, people are wanting. We are moving towards now saying we have built the structure fast enough. We want to finish fast because finishing has stayed right there. So this is where we started doing, saying I will finish also in the factory. I don't get people to do that at the site level. So if I have to summarize this again, why we need precast is, as a construction company itself, we are moving towards a technology company because of the inherent needs of the system. And what we said, the new mantra, if I have to put it in 2 ways, is the mechanization and digitalization. The mechanization is going to bring you that efficiency where you build faster. That efficiency is being tapped by your digitalization. That digitalization is telling me what is working, what is not working, which fuels the innovation to more mechanization. Right? So we talk about in various forums and people say why India doesn't need mechanization or why India needs digitalization. But that's the link. If you want to move towards that business excellence, this is the crux of what construction industry has not seen this for many, many decades, right? Especially the building industry. And what we are doing again, if you see that is the big changes, industry is very slow, not susceptible, so the big changes will come marginal, you keep improving things. We have evolved, I'm not going to spend a lot of time. But this one slide, I think one of the big takeaways, and probably most of you may not be directly exposed to this. Why I need to do precast? If I do conventional construction, we did our own math, L&T's working similar projects, 2 adjacent sites. I need about 5.5 man days per cubic meter. Whatever, if I have to do a 1 cubic meter work today, I will need 5 people through the day. I have to pay them and get that work done. That includes your concreting, shuttering, river, that split is also there. If I move to precast, that 5.5 changes to about 3.5. Basic precast, I reduce some manpower. If I go state of the art precast, that 5.5 becomes almost half. That's the productivity improvement I'm looking at. 2.5. That's the motamoti what a contractor's head will tell is, I want less people, I want to do it faster. But if you look at even closer, why that precast we are pushing a lot more in today's age in India is out of that 2.5, only 1.5 is happening at site. So what you are spending about 5.5 people to get them at site, make them climb 20 floors and get them work, it's becoming, earlier we used to say it's difficult, it is becoming impossible now. So instead of that 5.5, I need only 1.5 people at site. Rest of the entire work is happening at my factory level, control environment, what we call it. Retention time, retention of the workforce is better. The risk is in managing people, managing activities at site. That is moved to factory where I can manage that risk better. 5 years ago, we used to say ultra rapid construction. We are now telling it's rapid construction at assured delivery, because your client is now wanting that guaranteed delivery more than the speed. Right? If you go any realty developer, especially building construction, more he waits, more she waits, they sell higher. So they don't want building faster. Okay, government housing faster is different. They want the buildings later, but they want that promise. You tell me that I'm going to deliver in 27, you deliver in 27, not 29 and 30. And that's what the crux of it, why we want it. Where we do precast, how we do precast, right? Precast is, we don't force precast. Again, we are in contracting company. So we have built this very simple metric now, is efforts versus rewards. And without spending a lot of time, you will see that exterior 3D parts, they need heavy efforts. It's not easy to do precasting. If you look at it that way, conventional construction is much easier, much more forgiving. You put 3 bars here and there and nobody knows. You put 20 mm less bearing and that structure will tell you that you gave me less bearing in a week's time if it's not monitored well. So that high efforts, okay, you do look at it. You look at your columns, beams, okay, I can precast it faster, but I can do it at site also much faster, so that benefits are low but efforts are also low. But if you look at your slabs, I don't need anything to do a slab at precast factory, very simple formwork, but same slab if I have to do elevated at 4 meter, I have to do entire shoring work, put the people formwork. That's your best bet. And this is where that hollow core is becoming very popular, because the productivity, what we say 30-40%, it is 150% more. Right? Where I do a 3 or 4 square meter a day per person, in hollow core system I am doing 125 square meter a day. And this is where you have to do that engineering, what elements you do, how you do. Right? On that basis now, what we are doing residential, anyway, lot of work, so that has become, these are the real-time products, real-time buildings. Whatever you see in this picture has been built in about 16 to 17 months. It will take at least 30-36 months if I do conventional construction. This is that same building what I said about that 36 day and 96 day that we do. This is our upcoming repeat order, so that we are even more proud. About 11,000 houses. They said precast, whatever you do earlier, I want even faster in precast. So what we used to do in precast, 42, client has told now 36 months. So accordingly, we are also scaling it up. Whatever factory was 20 lakh square foot a year, this factory we have put up is about 33 lakh square foot a year built up area. That's a massive scales. The first factory we put up was about 4 lakh square foot of built up area a year. So from 4 lakh in 2010 to we are now at 33-35 lakh square foot a year. Within the factory, you will see how what mechanization and various things we are doing now. We have engineering wise itself. If you see that wall panel, what we used to do earlier traditionally is one room has 4 walls. So if you see the one face, we will have one wall will cover one room. We started covering one wall with 2 rooms. Here in this project, we are covering one wall, 4 rooms. So that many elements are less. The sunshades used to be separate. We will cast the sunshade together. So 8 elements cast together, lifted as one element. The crane doesn't care as long as the capacity is there. 8 elements lifting, you are going to take much more time than one. My joints are reduced. My work goes on joints structurally, leakage, both ways you have to build it. So that's the engineering behind it. Toilets, we are doing 3D toilets so that you don't have to worry, everything is monolithic cast toilet. We are even pre-finishing the toilets. So that's the engineering innovation. What we are doing in factory is we have evolved again. What we used to do flat work, this is one of the first fully automatic hydraulic battery mold system in India that we have put up. If you see the one delivery system, which is also mechanization, where concrete now we are not using the transit mixers anymore. The shuttle brings directly concrete from the bathing plant. It brings it to the battery mold and dumps it. So the concrete delivery is only 6 minutes. Most of your quality concerns in concrete are in concrete delivery. You never know what's happening, what is going in TM, how much extra, how much time it has waited. Now this is, everything is in front of our eyes, directly from bathing plant getting delivered. What best advantage I get is, this is all hydraulic systems, there is no slurry loss. That is another your quality challenge. Usually is your slurry loss, whether in your shuttering, whether you do in precast factory. So this is all hydraulic system.
It has its own built-in vibrators, very good compacted concrete. Results are you are getting what used to be earlier. We used to get little pinholes, little bug holes here, this, that. We don't get it. Flat concrete work usually has one manual face finished. So you will get some sort of undulations. Even if you do paint putty, you will get to see this. In this system now, both are mold sided. We are getting very smooth surfaces, directly paint and putty. You don't need to do any grinding, which is what one of the big activity at the sites. Structures like this now, this is in Reliance Jamnagar solar plant. The building is 250-meter long. It is modular, same systems are repeating. We did it in total precast, almost 50% time improvement. From outside you don't see that, but inside you see all these concerns what Dr. Singh was noticing. Okay, we also said Jamnagar, this is zone 4. We wanted to do precast, we want schedule was there, the joint connection. So finally we took that call saying I will do all the movement joints monolithic. But instead of just doing one monolithic, we said I will go 3. So what you see is this double E side elements, all my key spanning sitting over 3 columns. Each column has those 38 couplers. We used to see earlier this China video. If you see this corner here, where you will see that they are sitting. We actually now adopted this in India here, where each element is being installed in about 15 to 25 minutes over those 3 columns with your seismic detailing, with that stitch connection in between, which is joined by the couplers, where he was just mentioning that mid-span you don't have the seismic movement, you can deal with the gravity movement. Same way we said, okay, another structure where only the beams and columns are converted to precast, because that's what our schedule need was there. It's heavy columns. So what you see in the picture are 11-meter tall columns. To do that 11-meter tall shuttering was a challenge, so we said only columns will do. There were some heavy beams, horizontal, we converted that to precast, and then we stitch everything using wet concreting as a system for the slabs and all. So that call, that engineering, we are looking at it, what works, what doesn't work. These are small buildings, substation buildings in Vizag. On a project of 3500 crore, this is about a 30 crore building, which is the heart of the project. If it gets delayed, everything gets messed up. Right? So that 35 crore project, they said, I want to build on time. In conventional, because of all these activities and their region and area and all, this used to take 12 to 14 months. Because workforce is not there, they are not available, heavy work is there, this, that. We are now finishing these buildings in about 2 to 3 months. Same complexity, everything is same, but total precast system, going very comfortable. First building instead of 4 months has taken 8 months also. We did lot of work. This building, one of the buildings, we finally finished in 2.5 months. And that otherwise conventional system, it will go for, based on the challenges there, whatever that they have. Stadiums, this is another unique system is becoming because that modularity and repetition. So this is now become a bread and butter for us. Any stadiums, we are by default, we have taken molds which will last for 20 years that we will repeat work. This is Varanasi Cricket Stadium. It will be inaugurated in probably this February or March. And that is being in total precast systems going on. Some of the hostel buildings, we took it up as a challenge. This is Tirupati hostel building. So one of the funniest or maybe we have to pat our back. They wanted 2 floors later. So the design became like usually 3-floor building, 2 floors future, because building won't get completed. I want to get it started for this year. We converted that to precast and we built it fast. So they said, no, you add these 2 floors also right in the beginning, and we still handed over the building in that time and they opened it. So the 3-floor building before the project ended became a 5-floor building and we handed it over. So these advantages are there, right? Other thing we look at it is a hybrid. Like I don't have to force precast everywhere. Wherever the need is, lot of projects we do like this. One specific case I will show is this. You see 150 villas are there. This is a project in Bangalore. Modularity is there, and if you see these caps, they wanted that full English look, which is a tapered cap, and it's a 2-story height. So if you have to do a taper pyramid cap at 2-story height, you have to shore it all the way down. That shoring, supporting and casting the cap used to take 25 to 28 days. Sequential activity, brings, slope, concrete and all. He said this is not working. So only the caps we converted to precast, and the 6-ton caps we were installing in 6 to 8 hours and doing the treatment. And all under 150 modularity is there, so 6 types of mold. Daily we set up the yard at the site only, no fancy factory, but same quality control. Same way with the facade and all complicated systems where your block work buildings are not working. This is for our newly opened terminal in Mumbai. 15-kilometer compound wall is there. Right? Compound wall usually now these levels we do precast anyway, but if you have seen traditional we do the plank system. We said I don't want time to do plank system, so I will do one vertical full cast panel with the logo in, so activity is less. 20,000 panels became 5,000, and we have now in 3.5 months built that entire 15-kilometer long system. Going through some other projects pictures in terms of generally residential, now we are very comfortable. Like I said, repeat order we are building, but in that again, engineering wise, design wise, what we look at it is you will feel that the look, touch and feel of the system is same for the end user, whether it's a precast building or a conventional building. Right? And that is management is very clear. You will see the same such as the balconies, the architectural treatment, the finished buildings. You are not going to see any different than conventional, whether it's exterior or interior. And in this picture itself, we have multiple joints of precast somewhere above the door, somewhere in the corner. But once that is finished and done, even our own engineers not able to find out where the joint was. That has been the design philosophy right from the beginning. Various commercial buildings, like I said, we discussed beam columns. I think this becomes one of the issues is lot of coordination for MEP services. That's a challenge, hollow system and all. But if you plan it well, it is done really well. These are the structures which have been standing for 10 years now. All of the projects. This is one unique project, hollow slabs, what we call it, IKEA store room in Mumbai. So this is one of the largest 16-meter span. It has an industrial 750 kg per square meter load, 400 deep slab. Right? We did it for the first time. Hybrid structure, it was steel structure, and the slabs were changed because it's a 8-meter height and they didn't want to show it. And more than 50% productivity, whatever their time that they are looking at, because it was switched to hollow core. An entire shoring went, you are just keeping the slabs, and the diaphragm is still monolithic. So that emulative concept is still, the hollow core slab is only taking the gravity load, whatever bearing that you need, and the slabs were stitched and anchored so that there is no slip of bearing, and then the diaphragm was put to act as a structural topping. We already looked at this. This was another system, like wherever that engineering comes, the architect wanted the C shape, and the entire C shape was done in block work in Hyderabad. So in block work, we said it will take much time. It's a full high-rise building, so we just converted the C shape into precast. Then the architect said that the finish is much better, so I don't want to do plaster, so we did the horizontal. And the entire building was clad in precast and then painted. And this is the finished building. Once you do the joint detail finished, it's been standing for last 2.5 years now. Where we want to go forward is, like I said, finishing is now lagging. So in finishing, we said, okay, somewhere in steel structures, we will do precast panels. We can pre-paint at the site and then install it and put it. Steel hybrid combination. If you see this panel, these are steel connections and welded connections with the steel inserts. Whatever precast wet connection will take at least a day and a half, this will take in 20-25 days, the crane is released and you will finish. So equivalent block work 3 days, precast wet connection a day and a half, steel welded connections is 30 minutes. So like I said, that has its why the outside world is using these welded jointed connections is not because they wanted to go challenge themselves and prove that they are sizable okay. They are much faster to finish and build, and much less people needed. Right? Whatever conventional I will need 30 people, this welded connections can be done in 2-3 people gang. For the same reason, we are doing this pre-finished part. So we have multiple buildings now in place where this whatever you see in the picture, left side is finished at the factory. So none of that work is done at site. Entire waterproofing, testing, tiling, all insert fix, everything that is inside that toilet pot, we put it and then build around it to finish it. We did the same thing at the commercial level also, where the larger ones they were put in and it's working wherever that we want to do. With that background, I think I have last probably about 10 minutes. The second section I thought, what are the key challenges that we see as a designer or a contractor? and we'll talk about that. So maybe some how we are looking at the challenges, how we are dealing with those challenges, and maybe some pointers for you to take it and take up further projects. So last 10-12 years now, if any forum, any client meeting I sit, when they say precast, we have only two big concerns. One is seismic, second is joints and leakage. Right, so we are going to talk about that. Third that we see at site level is the repairs and spalls and chips and cracks. And that is a very unique phenomena that we are seeing. Is if you have this room in conventional concrete, nobody looks at it. You look, there will be hundreds of cracks and all, but nobody is paying attention. But the same precast slab comes, there will be 20 microscopes and they will roam around saying, hey, this hairline crack, what happened, this is cracked, this is not good, that is not good. So I'm going to talk about that and what we are doing about. Structural system, this I was saying, this is the whole test program that was done at SERC. I have the video links and all, but you heard enough in the morning. But the idea was to show that the emulative system works. Right? So what we said is that I don't even care what my connection is performing. I will mimic one connection, similar capacity connection in emulative cast-in-place system, which is for specimen 1. And then I will do my 2-3 other joints in precast and test the same and see if the same similar kind of performance is getting or not. And that's your standard force displacement curve. Lot of times people, most of the people will jump here, hopefully not that, oh, this is my cast-in-place and precast, but your cast-in-place is this curve, and that what whole emulative system, what we wanted it is actually this test readings we did 2-3 different specimens, different levels, but it was very obvious that you get that emulative behavior, right, whatever within that accepted percentage. What this last specimen was of equal capacity, we did it in grouted coupler system. And that is, this is in terms of your area under the curve, slightly higher R value. We are not using those R values, but then we started looking at why we are getting that higher, and that is because of the grouted coupler confinement effect. That same capacity, the lap is working better, is what our conjecture was. So we took that test. At that time, we didn't have the reverse cyclic setup here, so 2015 or 14 time frame. So we prepared some specimens and we took it to Hong Kong and tested it there. Now we have set up here. But for this grouted couplers, this is a type 2 requirement that ACI and European courts are following, and it's a very stringent, rigorous test for reverse cyclic loads. So what it is doing is you take your tension setup and run 20 cycles from 95% tension to 0.55 compression. So that is your reverse cycling. After 20 cycles, it's going to pull twice the yield and run 4 cycles. After twice the yield, it's going to pull 5 times yield and run 4 cycles. And then it's going to break to failure. And this is how the couplers are tested. So in general, broadly, you get about 50% more capacity of this coupler, grouted coupler, compared to your lap. Now somebody asked a question in the morning saying you are not allowed to lap this coupler at same junction. Why the outside codes are allowing? Because this system has that 50% extra reserve capacity built in. Our code also is not saying that you cannot lap. Our code says you can lap but provide 30% more ready. So this 30%, 50% is inbuilt. So that's why the couplers, even if you lap it at the same junction, it is not an issue as long as it's looked at design, you looked at the capacity and what it's doing. One of the other bigger thing it gets mixed in the practice also is the grout. We tested this system with 50 MPa grout, which is what the manufacturer was saying, and 50 MPa grout, it develops the bar. Perfect, fine. That 50 or 60 MPa grout failed miserably in reverse cycling. That system did not even pass the second yield. Then we started improving the grout, and at 90-95 MPa grout, these specimens were passing. So last 8 years we have adopted these couplers. We are using that 95 MPa grout, but half of the practice or the outside community, lot of them don't even know. Manufacturer will also say for standard tension you put 50 or 60 MPa grout and that's enough. But now we have brought that in our design code itself, saying if you are using this coupler for seismic or your lateral systems, they should have that 95 or 90 MPa plus grouts. But you will see that classic system, your ductility, the pin formation and all everything. If you don't have that grout, we were seeing the brittle failure where the bars were pulling out. Same way later we did SARC only the whole setup, then we looked at the vertical connections, we looked at the your overall collector and diaphragm forces. In that vertical we did not get decent capacities for the loop connections, that's what we are using. And since last 7-8 years we have stopped using the loop connections for the vertical joints. So we are doing the wedge stitching now. Earlier we used to use the loops. So loops we are now using only for non-structural uses, because in the test we found out that it was not performing at that satisfactory level. Right, so these approvals and all is there, I am not going to go over. Now your second thing, joints. Now here there is no magic, you just have to be at it, you just have to be with whatever excessive quality you can do, whatever measures you can do. At least in structure the precast will forgive you some, but in joints it won't. If you don't do good treatment, if you don't do good system, it will show in next 4 hours, right? So we have evolved, like I am a structural engineer, now moved to business, but between 6 years I have been more of a waterproofing engineer than structural engineer. So whatever that we have done, detailing, we have our own detailing, but we have now evolved a system where we are building water tanks here. If you see these pictures, we are literally flooding the whole house, not just the toilet or kitchen, the whole house with 1 inch water, every flat for now. We took that internal call for now. Down the line we will maybe tone it down, but right now we are taking that call. Every house gets flooded for 4 hours. We check it. It's not that we don't get it, this is a real video just for the sake of reference. The whole house gets flooded, 4 hours. After 4 hours we drain it out, and then we check the inspection happens from the lower level if there are any seepages around. And this is the level that we are seeing now as of today. Right, I'm going to take a pause right here. Yeah, you see that corner there, little spot. You see lot of cracks. We shot the video like, because inherently precast has cracks, right? This you will see in conventional system also, these are shrinkage guide. Whatever you one slab you pour, it is going to crack some, there is no more. Precast also cracks, these are even thinner slabs, we see more cracks. Because we use 2-layer system, their cracks don't align. Today I will challenge to flood any conventional cast in place room and it's going to leak all over. And that's fine, it's expected, it is going to seep water through. Here that doesn't happen because those cracks don't align. So we have seen now whatever countless tests we have done, the slabs don't leak, the joints leak, the slabs don't leak. I have 2000 toilets in one project for last 10 years. Usually the SRA projects, that's one of the biggest complaint areas. 2000 toilets, not a single complaint in 8 years that my quad is leaking. Joints here, there, that we treat and on. So it has its own thing, it needs its own engineering, detailing, but once you did, you are able to translate it, deliver it as an engineered product. Right, where we stand today is 2012, I used to have 10-12%. We are operating somewhere around 2-3% seepage that we are treating, handing over. They are lesser than my conventional system. This is where management is now allowing us to do bigger projects because that risks are much lesser. Same way we are doing the external tests also. We look at it, yeah. So the entire joint gets exposed. We are recirculating the water if in case anybody is worried about sustainability. We took that call earlier. It used to, now we are recirculating. But the entire joint for 2-3 hours gets exposed, tested. Wherever we find, we repair it and then move forward. Right. And then the last item is the elements. Right. Like I said, this I have put the worst pictures. Usually we don't show this in outside forums, but this is an academic we have, I think we have to also learn. This shrinkage is 70 millimeter slab, no matter unless you do steam curing, but for whatever reason we are not able to do that here. You will get some hairline cracks. What cracks to what levels, we have explored and done detailed studies at our end itself. I will show you these pictures. Right, these are shrinkage cracks at the surface. They don't go more than 5-6 millimeter. If I open that same crack, behind it is a sound concrete, and this we have done countless times. We have now, this is usually that same building what I showed is we are looking at every corner, we are looking at that whatever percentage that has drastically down. Learned a lot, detailed change, that continual marginal improvement, that what we call it, then wherever required we are taking course, monitoring that. But with these cracks, we are 105% sure that these are not structural cracks, right? The same slab what I showed with the worst picture, we took that same slab, put the screed and load tested it. Not even 1.5 millimeters of deflection. So these cracks are not affecting your strength. They are superficial, but they are aesthetic concern. They have to be repaired so that there is no further moisture seepage or anything that goes on. So based on that, now we have our own, we call it a standard repair guide. Usually people get irritated saying, what do you mean standard repair? I said, no, there are repairs. These are elements. We are not like carving marble out of this concrete. It's a concrete element. It gets damaged, it gets hit and all. If what happens, it is everything is defined. What is a chip? This is our internal guide, but what's a chip? What's a crack? 0.3 millimeter is a structural crack. More than that, what to do? If it's less, what to do? Those guides are there. We are addressing those concerns. Same way repairs. Now we lot of times, because element by element it used to be an issue, so we started doing a repair system, saying each element, what is the fault, who is the root cause. They will certify, engineering will certify, quality will certify at the end that the repair was done, and this is the signature, then only the project manager will accept and go forward. So that system we have built now, we are openly accepting, saying these are elements. Transporting a 4-ton element 20 kilometers is not an easy thing. Right now we are looking at even 30-ton and all. That's where I said in the beginning, cast in place is much easier. If I would have hundreds of people to do, we would have still done cast in place, but we don't. We don't have people. So with that, thank you very much. I probably took a couple of minutes longer. But, thank you. Yeah, if you have any questions, otherwise I am here through the day also. So. Yeah.
So how are you solving the crack if you are getting it between the hollow core slab? Are you doing an injection grouting, or how are you solving?
Between hollow core slab joints, we are not grouting now. So we put the backer rod and grout the joint, but not, so the joint that you see, the user see, there is no grouting, because no matter what you do, it will open up. So we have stopped it to that joint, but from the top we put the grout, non-see grout, we put the backer rod and put from the top.
Even that, so that is leaking, then what do you do?
Yeah, see, I think wherever that hollow core we don't have issue of leaking now. We did now just IIT Madras, they were using a hollow core roof. I don't know if you are there, it's a very unique building where we were the pre-finished room, but 14 days we ponded water on that hollow core without waterproofing, just to try it out, because Professor Detu wanted that, no, you show me. We were telling him, no, this is going to leak some. So, of course, without waterproofing, when he was pushing, means there were 4 people standing and making sure that the concreting was done well. That I am pretty sure. Otherwise, at site level, no matter what you do, you will see. But after waterproofing, you don't see that. But that was an experience for us also, where I feel that if there is genuine oversight and good quality control at site, even the regular concrete non-stick grout what we use extremely good quality performance. To do that same at a large scale, no matter what you do, no matter how much quality, which is not possible, every joint, every millimeter will get checked out. So something somewhere I'm going to put that cushion, you have to build mechanisms, one fails, other fails, third, fourth. I have in my joints now 7 levels of mechanisms. And that's where we are building that quality. One won't come, because no matter what you do, something will fail. So we have now built in some, if one fails, second is there, second fails, third is there, third fails, sealant is there. So that we have to build.
Are you filling the whole joint, the depth of the hollow core slab?
We are filling the whole.
Thank you, sir.
All right. Thank you very much. Appreciate it.
Sir, just a moment. We request our director to present a memento and shawl as a token of gratitude.
Thank you. Thank you.
We'll continue with this lecture and then go for tea. So we'll have a short tea break for 10 minutes and post that we will continue with our lecture. Steve.
Tea break. Okay. Where is the box?
Which one? That plant is in back. No. No, sir, he's here. He has just come. Can you open? Open
Box is
அது கொடுத்த பாக்ஸ் அவுட் சைடு இதை ஓபன் பண்ணி வச்சிருக்கேன்.
This you can.
Bhimani. Is currently the technical head in Teamage Precast. So, welcome, sir. Yeah, please.
Shall we start?
Yes, sir. Yes.
Yeah, good evening. Today I was given with 25 minutes, so at the end of 25 minutes I want what I have formulated is both academicians, researcher, industry, and all three. So I have to give some input. So I have distributed to all the three. So at the end of the thing, one can understand that whatever you can do it in cast nature can be done in precast, and whatever the ductility you can achieve in FREC, you can do it in precast. So these are the two fundamental things. With that objective, we are going forward. So as an ethical being an employee, so I just want to tell a few slides about the company. So this is a mantra: easier, faster, and better, and we are also making the connection in the same phenomena. And we are around 42,000 employees and 19,000 crore turnover we are doing. And as a teamage, this is our order book. So we have a pan-India presence, and this itself is a precast building. This building, 28th day, we sat in our seat, including finishing. This is just next to the railway station, very congested area. This slide I included to show that whatever you can do it in precast, you can do it in conventional, it can be done in precast. So the spectrum of project will give you the proof of that. And when we started in 2012, architects, they would have finalized the structures in conventional. So by the time you would have approached. So with the same architectural intention planned for conventional, we have done the precast. So by that way we got emulated. So that's why for the mold and everything we got trained ourselves. That's why we can confidently say that whatever you can do it in conventional can be done in precast. So I will skip this. So these are the things. So the technology came in such an extent that this is a Tirupati temple. The largest and the smallest details can be captured. So the technology has grown to that much. So that will, on the right hand side, this shows the with the fibers, we can go as big as panel as we want, and this is 75 mm thick. This typically for a compound wall you can reduce the cost. And they approach for the Chandrayaan launch. They approached us for having a larger gallery. Initially, everything was planned in steel. And as you know, the Sriharikota is the highest corrosion map in India. So later they understood that they should go for an alternate system which has a durability of, say, what they expected is 140 years. So that's why they came for a precast, and they given me a time of 90 days. So that's why if you see all the connections, there will be no wet connections will be there. At the same time, all are seismic resistive. So this is a structure. The first few slides is for the academicians to know what it can be done in precast. So that's why I included those slides. So this is the IT Park largest project we completed recently in Bangalore. So this highlights the importance. This slide I included to show the importance of precast in the coming industry as it moves closely towards like a production industry. So we are also going to move towards the production. So that's why the advantage of using the precast, you have an early time. Wherever your time is a remuneration, such as your rental or business or money is coming in, there precast is surely profitable. I can say it is 15% profitable. Example, Chennai Silks. Before, actually we started for our captive consumption. Before 2012 we have 8 shops. And after 2012, between 2018 we have 34 shops covered all the districts. And in T Nagar, after the fire accident, we came up with 90 days in that congested area. You can say per year turnover will be around 420 crores. So if you would have done in T Nagar in such a congested area, we would have taken almost 4 years. So almost 1,200 crores is a saving for our parent company. For them, precast is viable. So wherever time is money, precast is cheaper. So that is the reason I have. Similarly, Vaishnavi, they are going for a IT building where the clients have been finalized. So they can have early rental. So that's why they went for a precast. Of course, the pollution, all those sites, particularly for the Delhi area, GRAP and all. Now we got a special permission where which we can go for a precast, even in the GRAP. So because the number of labels, if you see, hardly it will be 8 to 9 members. So accordingly, every hindrance will get reduced. escalation will get reduced, all the associated problems will get reduced, the dust-free condition. So this is typically to show the effectiveness. Unless I show, it is very difficult to convince the others. So that's why I shown the dates. This is for the core industry people. So I heard most of the industry people are there. That's why I given the full numericals so that it is qualitatively and quantitatively it is proved. First, I didn't go into the seismic. I will go there later. But as a technology, it is promising. So both qualitatively and quantitatively. So from these slides, you can understand that whatever I told earlier is nearly possible. This is a finished structure of the same building. Actually, the idea, this slide particularly I given because actually they planned the facade all around the building. Then later they understood that my cost is around 300 rupees per square feet, whereas the facade is almost 900 rupees per square feet. Double glazing, all those things. Then later client, after that they changed their mind and we convinced them and we made everything into facade, like this facade, this one. So we reduced the cost. So to show that one, I just included this one. Now the ACP, you won't find, now the coating system came into such an extent and waterproofing came into such an extent that even you can coat over the ACP, you won't find you take any stone in India and give them, they will match it and give it to you. Any stone, granite or whatever may be. So it came to such an extent, so nowadays the waterproofing and external cladding is not a big problem where when we started, the brickwork is going to be a very big problem that time. But now we have these options. This is the toughest project we done, and this is the first ATC in India in precast. And this is the first, I think very few, not more than 10 I think around the world, where you won't have any peripheral column. It's a composite, and you won't, and only 3 in the world where there is no mullion also there. You won't have even the mullion. But this is being designed for 450 km per hour. So this is including finishing everything. So this also explains, this is gate to gate composite project we done. ATC Vijayawada and ATC Tirupati. Why I included this one is I will show you. When we reached this stage, the airport director called us and they told at that time around 8 ATCs are going around India, and they given an option, anyone can do without the column. Actually, we also planned with the column. That's why these peripheral was there. But later he asked, can you do without column? So among 8, we taken as a challenge and we didn't disturb anything. Only thing I shifted fortunately we have a, fortunately we have a central core. This central core. So I have used that as a similar like that of pipe. Above that your raft is going to sit, and after that your composite column is going to come. So what we here, why I included this is, you can combine conventional judiciously with precast even if you want to become cheaper. So it is not that for everything we can go for precast, because when your time is not money, then obviously you can go for, of course quality is add-ons, but unfortunately we are unable to convince the client. When we tell 140 years, in Coimbatore if you come and say 140 years, he will say that I will stay for 30 years in the world. What is the use of 140 years for me? My son is not going to come in the business. So this is the problem we are facing everywhere. This is a very serious problem. When we talk about the durability, they talk about the business. So we are unable to sell our durability, but of course for that also clients are there. We are selling the things, and we almost replaced 80% with the GGBS. So our entire concrete, whatever you are seeing, having an early strength of almost 18 MPa for the demolding at 18th hour, but 20% cement. To move towards the carbon neutrality, we adopted this one. Yeah. Now, so till this time, first few parts I just summarized. So first few parts we are I included these slides to show that anything can be everything can be done in precast. Second few things is what is the advantage where time is money, you can go for a precast. And it is cheaper and quality is the add-on. The third thing is you can judiciously combine the conventional and precast to have a very hybrid system which is more robust also in terms of seismic. But nowadays even the technology came so that your precast itself is a robust. So that is why the remaining part of my presentation will prove that even the precast is a robust with respect to your ductile detailing for the highest seismic zone. Yeah. Now, actually, I included some of these slides. This is for the entry-level engineers, so that when you go for a precast, before going into the precast, the code alone is not a governing factor. The code, as when you go into the field, you will come to know that the code will be the last parameter we have to satisfy because the given site condition, whether we can go vertically or whether we can go horizontally, floor by floor, determines your framing system. So that's why I given this topic like precast. It is both segmental or it is a non-segmental. If it is a segmental, then obviously you would have a proper concentric lateral road system may not become possible due to the project condition. So you have to bound to go for an eccentric system which will create a torsion, all those things you have to take care of it. So that's why that will become a second parameter because ultimately we have to satisfy the given condition. So that's why that is the main parameter we will decide whether our precast is going to be a segmental or floor by floor as that of conventional. Because this is a main factor based on which your entire seismic framing system is going to depend on. That's why we have included this slide. For the example, IIT Madras. This has been certified for 140 years. Actually, as you know, IIT Madras, I should not cut even a single branch, and they won't give any land other than my footprint area. So this is the condition. So I have to go for a segmental construction. So what? So fortunately, I have this way multipurpose hall of say 3-floor height and almost 25-meter wide. So we placed the crane here and we completed. We came out. We completed this one. So what I want to say is, suppose here long span is going to come. Yeah, floor vibration we have to do. Vertical acceleration we have to check. No other way. This is a side driven factor which we cannot avoid. Like good, when we have a secondary beam or when we have intermediate column, we can avoid. But here both functionality, it is a sports complex, and the site condition also pushing us to go for a very long beam. Okay. Then come the construction. So the 24-meter, the turning radius is not within the IPS. So I should not cut even a single leaf also. That is the first condition they told. So what we can do? So what we did is we done the post tensioning. That is, we done the pre-tension and it is a post tension. It's a both combined. I don't want any suffering to be here. So post tension, if I go for a normal post tensioning, though it is a parallel, I don't want a suffering because it is of 10 meter height. So every term of safety is there. So what we thought is first constraint for it is there should be no problem. At the same time, I should have early demolding because I don't have site. So every beam as and when it's casted, I have to erect it here. At the same time, until I do the post tensioning, it should not interact with the structure. So these are the parameters. So what I want to say from this slide is there are numerous parameters. We are site based, project based, or need based. We have to finalize those parameters. For the given those parameters and limitations, we have to satisfy the code. So that is what I like to insist on this about the precast. Yeah, I'll go. Again, this is a typical example. Yeah. So normally in India there are two types of system. One is whatever you see is a frame system. Second is a shear wall system where there may be beam or there may not be beam. So it's like a slab shear wall system. So based on this plan we are going to have. So these are the normally two systems we are following, and I can probably say that we are the first in India to introduce this carpet because again need based. We want to go Chennai hills every day is too close. So we want to do faster. So we can't everywhere by the time 2012, everyone is keeping the contour over the wall. Then we realized that this is not going to work. So we went and kept on the carbon so that the screening fellow will go parallel. The main thing is we will decouple each activity because we don't know who will create delay. Suppose my screening person is not there at the side, then I cannot wait in the side. It is ultimately going to affect my schedule. So what normally the fourth dimension is we will decouple each and every element as much as possible so that we will not have any uncertainty. Not, I mean that we will not have any uncertainty, but we can reduce the uncertainty. So that's why we introduced this thing and it is quite successful. We are happy with that. Yeah. Now I think up to last year we have a data. So I think above us means L&T might have done. This is the largest commercial building standing on base isolation as of now. As I know. Each floor area is 1 lakh square feet. All 326 column is standing on isolator, base isolator. So I think SAR is one of the consultant over there. I think that here my advantage is everyone I have been except Gopal Krishnan sir indirectly I have been associated. So okay, so that time when the sliding pendulum isolator was just introduced, by the time we have used the double sliding pendulum, it actually is a triple sliding pendulum isolator. The only thing is you will reduce the diameter. When you have single, 2, 3, you can reduce the diameter. So the entire structure above the superstructure is just, it's a zone 5 they told us to design, and the entire structure moves as a rigid body. So we are designed for the minimum lateral force. That time the minimum lateral force, there is no code exclusively for base isolation. So we are supposed to do for some increased ductility. So we done for that. And one interesting part is here why I shown this slide is this entire thing is a gas tube. This is of 2.5 meter depth. The reason is the ground floor it is hanging like this. The entire left floor is just hanging, there is no foundation. So that when earthquake comes, the person will come down, he will reach the basement. Once he reaches the basement, he won't feel the earthquake. That's the idea. So the entire, this is a basement, the entire left floor is will be isolating along with the superstructure. So that is the most difficult part we done in this project. So yeah, this is point. Okay, no problem. No. Actually, this is isolator level. So actually, I kept above, we kept above the podium level, so that the below podium level you won't have much effect. So that's why the whatever the ductility we want to reduce above the floor level, we kept the isolator there. So we kept the isolator at this level. Yeah. Now comes why I want to why I have kept the base isolation is today my other fourth point I want to stress that base isolation is going to be a much viable system. Because of not using widely, the cost is being higher at present. But as and when people start using more and more, cost will come down. That is my main request. That's why I purposely today we are talking everything about base isolation. Yeah, this is what I explained a few minutes before. So before finalizing the structural framing plan, I have to take all these people into consideration. After satisfying this one, then I can satisfy my highest score. Yeah. Yeah. Way back, this is actually IIT Madras, but way back before coming this kind of view, it came in 2016, but way back in 2009, we done Kochi Metro for Zone 5. And by the time we taken from the New Zealand code, so first our emulative moment correction is UP. So, lot of difficulties will be there in matching the reinforcement, and you won't have the quality, the coupler will not be good. Even if one hammer, if you hit the coupler, the thread will go. So we can think coupler is there, but it will not be performing what we have. So now after seeing that, we started moving towards like a foolproof technology. Like it should have a minimum skill requirement. At the same time, if anyone minimum chance of doing the error, even if anyone does the error, that will not affect my system as a whole. Majorly, I will say for the service condition. So this is the stand we took. So after this, we definitely we thought that this is not going to serve me in long time. So definitely we want to migrate from here. Then after that, we taken from the New Zealand code. This also now in the revised code it came, but we started applying in 2014, I think. It also came in 2016, 2021. This connection came in the revised IS 15916 in 2021, but we done in 2014. As usual from the New Zealand code we taken. Okay, here what is the problem is, I have to make the junction concreting, and here this point will be understood those who are there in the field. This beam reinforcement and this beam reinforcement has to be alternate. That means per piece, this rod will be in one direction, other rod will be another direction. That's my piece drawing I have to do. This is not difficult. The main difficulty is when any fellow sits here, if that element goes first to the side, and imagine that rod is going to be coming here, then he has to wait until this beam has to come. I planned like this, but this fellow went to the side first. You see, it is like a, what you can say, the cord, this thing, everything will get stopped. If one element didn't get casted means gone gets. 7 days I have to wait. My crane, everything will go. At present, this is the certified one we are using. Then we realize that okay, this is actually selfish also because my labors are becoming very costlier. Because I think since we started way back in 2012, all my employees is being posted to all big companies, and many are now heading the company. So I have no other option. I can't give the pay what they are paying. So what I have to do, I have to simplify the piece drawings. So what we thought is there should be a single piece drawing so that everything can be done. So that my labor also less, and when the piece drawing is less, production error is less. When the production error is less, my erection will be faster. Just we done the looping. So that's why we migrated to the next level. This is it. So I will show step by step. Here there will be, this is particularly we done. Another condition is posed as is, we have good projects with the Japanese in Delhi. Delhi is zone 5. Japanese after Myanmar earthquake, they have a common Takinaka. They have 4 and years old company. They have a common policy they taken immediately because they are ethically driven. So what they immediately they given a circular to all the countries where they are operating, all 43 countries, that they are going to appoint a centralized committee which will evaluate each country's code. So they are very stringent and they want, if they visit, they want to be still safer means I have to provide the facility. So this is a condition. So I have no other way. So those Delhi structure also the second condition which posed me is each column is of 20 meters. At the 20th meter, I have to make the moment connection, which is virtually not possible to maintain the quality. That too in hot sun, you can't touch this rod. If you touch the rod, it will be 50 degrees. Then where quality will come at 20 meters? You can't expect. So these are the factors decided that this even this connection is not going to help us in that. Some connection, see, wherever IT park is there, wherever your area is one, suppose I have an area where 1 lakh square feet is there, then okay, I can wait here, the people will come do the junction concreting, I can erect there with the tower crane, so I can manage. But where it is becoming series in erection, not parallel, then this is going to be a redundant for, it's going to be a hindrance for me. So that's why that forced us to go for this type of connection. And now Dextra, I think for L&T they are reporting, I think you are using in Varanasi Stadium, I think. Because I was trying this for 5 years, they didn't given me, because I am the only person asking this coupler, they told me it's not possible, we are not going to supply. Then luckily they have started using, so I also got benefited with this. That's all. So it's a double sleeve coupler, no need of threading, no need of end preparation. So just you can slide it and you can forget it. So another thing is whenever you have a half beam, you will have an imperfection. See here it is neat because I taken a photo for a presentation, so it is very neat. But if you go for the site something, you see there is a concrete slurry is there and sometimes this fellow will put the concrete like this. So you can't put the top bar. When the moment it reaches there, you can't break also because all stirrups are there. And Japanese is so strict, they should not have any cement slurry on this bar. This is a main parameter which forced me to change my connection system because they don't want even a slurry. We tried anyhow, we couldn't able to, like we couldn't able to have a steel without slurry because it is going to be poured from top. They are very strict, they are zero tolerance. You do whatever money you want, I will give. That's all they say. So I had to go for a full precast system. It is also advantage for me. When I go for a full precast system, it will be a prismatic, no quality problem on this side. Most of the main load carrying member will be done in the factory where their QC persons are there or our QC persons will be there where factory quality control is always higher than that of site. So that's why all these things posed as this one. So the same thing. So here I will have a double sheet. So I will slide the entire strip on one side. I will erect it. I will have a through hole here, and before erecting the right hand side beam, I will check what is the tolerance. I will give accordingly here more diameter of bolt so that you will have a tolerance. Obviously, it will not be because here the template will be done. So the tolerance is not needed, but still be given. This is second beam. You see, particularly we cut out this one. This another thing is we have to ensure inherent safety in our structural system. So that is the philosophy because we have a major accident way back in 10 years back. So from that on, we have there should not be any prop. Even if it is prop is there, it should be a secondary. And the element should be sitting on its own stability. The moment he kicked, he can leave. Because this is the way we have to do. Because here Indian erectors are not trained actually. Suppose I started, it's like our condition is literally like a BPL. BPL who introduced phone now is nowhere in the field. The same thing. We are also is slowly competing because now we created a base. We created a base of manpower, technology, everything. Now when big players come, we cannot. We convinced all 10 years with the clients about the precast. We struggled a lot. Everything we came to a level. Now when big people start, Adani they started investing, they're going to have a precast throughout India. So like that, if it comes, it's really tough. So what they will do? They will take 3 times, 4 times of my manpower. It is going to be in Coimbatore. I will tell you, 8 precast companies are there. All the QC head in our factory was production head now. All 8 factories. So this is a condition. We are like BPL, so we are trying alternative methods and we are moving ahead with the technology now. So yeah. So the second, it will be casted. So exactly, that's why to make the stability, this portion will sit on the carbon. So you need not to have any propping. Then I will slide it. I will grout it. I will do the UHPC or whatever fiber reinforce in this small portion, which I will give as a dry mix. Just he has to mix the water and fill it. That's how my connection is established. And this connection is independent for my hollow core erection because I have designed for the one thing for the newcomers and even industry designers. They are very even 10 years also they have one typical problem. See, please, who are in the webinar, not you experienced people. When I keep my hand, my load already reached my floor. Now this fellow is simply supported only. After that, whatever connection I am making with here, for the load which is coming afterwards, after making the connection, that only will create the moment here. So that's why ours is a pre-tensioning is very easy in the precast factory. That's why my for the dead load which forms the major portion, I will make it as a simple supported. So my end moment will be less. My end moment will be less means my joint ductility, all those things, joints, column sizes, moment hinge, blast, shear hinge, all those checks will become simpler. So that's why we used to adopt this one. And it also inherently helps us that my hollow core erection will go separately, my junction concrete will go separately. So at any point of time, no one is dependent on no one. Yeah, this photo is just to show the effectiveness. This is the first Japanese project we done way back in 2013. This is a portion they started and they came to first level. This is 7 meter tall. All Daikin Panasonic done every after 2012 we have done. After that, they realized it is not going to stay. It is going to take time and quality is also not as per them. They called it the completed full. Still they are doing. So this is a photo which we shown to show the effectiveness of the precast. After that, we got into MOU with Takinaka. So we are the authorized partner for India for all their projects. And now we are entering into tie-up with Toyota. They are going to enter India as a construction company. So Toyota, Takinaka and teammate, the triple T. So we are expecting good growth because I have to not to be BPM. So I have to find a way. That's the reason.
What do you mean by BPL? Below power.
No. BPL phone, sir. The first is they introduce phone, but they know that in BPL. So that's why same condition is for me also. So I have to strike. And even for them, all the girders, the curve girders, everything is precast. Because we are given a solution which is lesser than the steel. Cost is lesser than the steel. And we are going to propose another system which we are going to do the patent where which your the huge PC. With the huge PC, I am going to make the same IV with a nut and bolt connection. As a steel contractor, you won't find any difference. So you will have a reduced weight. At the same time, you have an increased durability. So you will have a rigidity also in the midway. And you can replace also, you can remove also, because wherever I go to point to the industry, people will say after that I want to remove. Though they will not remove, they will ask, they will remove, they want to remove. So that's why we propose that system and it is been under the patent. So that's why I couldn't be able to show. So typically this is an architecture building, how it will be. First we will, all the zonation we will do. So I will go to the soil structure interaction way back in 2012 we started doing soil structure interaction, but now it became mandatory in the IS code in 2025. Yeah, so this is only for the academician and the new designers. Whatever we are assuming in the analysis, that should be executed inside. So whatever the diaphragm connection, you have to design this rod for the shear friction so that it will take then only that fellow will, when I go like this, then it gets slipped, then this person will not take any role, right? So that is the thing. So we have to make this connection very good. Otherwise, whatever ductility you done it in the cord or beam, it will go waste in the intermediate. So this I'll just, what are the plans how we are achieving in the field? So this what I told. This they are literally not allowing. You see a lot of slurry. There is no gap. This fellow, whatever he can able to insert, that much only he will insert. That too in 9 minutes got this. So that's these kind of the factors forced us. Now we migrated to actually we are manufacturing coupler since 2014. We are using for ourselves. Because Sakchi Foundry is very famous in Coimbatore. They are exporting to all over the world. They are very good in foundry. So the grouted coupler before Dextra coming into India, in fact, now your Dextra is coming from Coimbatore. I don't know what to say. Just next to my factory. Because we started manufacturing, they found a foundry, they came there, they inspected quality certificate. Now we are manufacturing our own coupler, they are manufacturing for them. The only cost will be double. Mine will be 250, they will be 550. That's all. But we are not selling outside. We are manufacturing our own admixture. We are manufacturing our own grout at the half the price, and we are manufacturing our own UHPC at the rate of 44,000. Now, right now in the market it is 1,10,000, and we made a UHPC with the M sand itself. Only thing the flow is matter. So we have our own quarry. So we control the shape of the aggregate. So we able to achieve 250 with M sand. So it is the first UHPC in India with M sand and first grout in India with M sand. So we are using and it got certified with the government and we are using for last 6 years. These are the various connections. I will just go through it. I want to tell some few points about seismic. Yeah, this is a connection we now adopted to avoid the inherent. Now we moving towards the inherent waterproof in the structure itself by itself. So the whatever waterproofing we are going to make is going to be a secondary production. When I make this, I will make. See now. This is the first time in 2025, I think. No, not it came. It is a draft, white circulation draft, where which they recognize this uncoupled. I think L&T has fought a lot before to accept that, to make them accept that idea. But now it is authorized, it is going to come in court in white circulation. I hope it will come. So either you can make uncoupled, each element will take up its own lateral load, or you can make it coupled so that monolithic action will come. So these things, the monolithic action will come so that I can reduce the reinforcement, your stiffness will be very high, your drift will be very, very low, 0.0001, because fully of shear work. So this will have a high redundancy. So that's why for high range structures we are adopting these things, particularly for the lift core. We now eliminated the loop connection. We are not now using any loop connection because of waterproofing issue. Yeah. In our office, there is no difference between RCC, priestess, column, beam, shear wall, X wall, or star wall, nothing. We will go with strain compatibility. We can decide what is the strain limit there, strain limit at the bottom. We will do our anyhow here these two are C is equal to P. Only here I have to do with the plastics in front. So this is for automation chain. So we will have, so by the way, what is the advantage is I can know which steel is in tension in my column. Those steel I will consider for the shear. Now it is shear check normally no one will do. It will take, even if someone want to do, they will take half the steel, half is compression, half is tension. But here sometimes we will have some 2-3 bars will not fall in that region. So that's why this only single curve. Even wherever I go, I will share this derivation which we done way back in 2017. So this is the derivation. Whichever country code, you just need to change the boundary condition in the thing, and we have to go on. And here what we done is, I don't want to have this much, for this only big equation was there. I don't want, I just made it linear. So this will be easier. And second simplification, because when we go complex, then this also, I can be lower bound, straight, lower bound. So it not create much problem for me. It is of the order of 5%. So that's why it will become easy for this thing. Only thing is for pre-stress, instead of starting from 0, I have to start from the strain where I am pre-stressing. So the same sheet can be used for both. So for the academic students, I want to tell PG students, once your RCC, your PSC is cracked, is nothing but a RCC. So that's why nowadays, though the stand is not being that much ductile, we will use for some cases where in the mid span, wherever the stand is getting wasted in my factory, I can use it in the mid span where you don't need of any ductility. Only it can have the load carrying capacity. So that's why we are reusing those things. So though I think Global Krishnan sir was there, and I want to make one thing in Indian code, sir. I was telling this for past 6 years. There is no limit for the extreme tensile strain, how much you can go. They given minimum is 0.0038 and maximum also 0.0038 is going to come, which is not going, which is meaningless actually. I also fought so much with the sir, but I couldn't able to convince.
Is it for 456?
No, sir, I am 456, sir. For the how much you can go under enforce. So the maximum strain which is allowed, whether it is 1% or 2%, again when you go for 2%, then accordingly the R it will come back up to the R value. So some guidance there is our code, every code is relevant on this. So now anyone decide, since we are doing strain compatibility, we know even if I put a hairpin, I know what is the strain there. Now the question is how much strain I can allow, because now you are using the under reinforced over. In my office, if you come and ask any under reinforced over reinforcement, no one knows. Because we used to take from the rural guy and we will train from first day onwards. Anyhow, he will not study in the college also. So freshly we will start it. So he will not know what is under reinforced over reinforced. So how much under reinforced we can go? That is the problem. Other codes are given 3%, sir, but Indian code we given lot of times comment.
That's coming from the cracking. Minimum cracking moment is equal to the capacity of it.
Sir,
that's what the minimum reinforcement.
No, sir. I'm asking about not minimum reinforcement, sir. When you go for under reinforced in the ultimate stage, when you go for the strain compatibility, what is the strain maximum you can allow in this field? That is silent in code. They given minimum 0.0038, but they are very silent about maximum. Whereas German code, other code, they given up to 2%, 1% like that. But we have only one thing: tension control, compression control. 0.005. After that, everyone is silent. So that's why that thing, that's why particularly I thought of coming in the morning, but unfortunately, actually when I was 16 years, 17 years back, we will be operating, we will be sitting inside doing the mass modeling. And at that time, I was doing internship with Anand ma'am, so only those person can enter who is doing in A-Star lab. Then he was little, like, he is strict, he is little less strict, so he will find a loophole. think he will forget, he would have forget because he won't recognize my face by the time. Ramakrishna was there. We will tell my name is Ramakrishna, I will go for the testing. That time Adal Sundaran sir was doing G+2 with 5 or something. She catch hold of me. Who told me to come? Who told you to come inside like that? He shouted at the lab assistants also. Okay. Now comes. This is the final thing. Is very important. What I want to say is the structure should be. Please make the structure as simple as possible so that the post flow. If you disturb the load, he will disturb you a lot. That's what my thing is. Please allow him so that he will allow you sleep very happily. So that's why mostly we will have a load path very simple. Whenever you have a load path very simple means I have to see these are the parameters. You have to increase the redundancy. At the same time, it's a trade-off. If I want to make the load path simple, I have to go for a field. But if you have more field, you won't have a redundancy. So it's a trade-off. So wherever, that's why I want to say don't make every beam as a moment connection. Suppose sometimes if you feel that like in data center, your load will be 21 kilometers per meter square. Your beam will be this much depth. If you do the joint ductility, your column will become very heavy. Why are you making him to fight with 2 people? You remove one beam, make it pinned. So these 2 people column will fight with that fellow so that you will have a very normal size. You have lot of frames, no? You can make everyone, any one of them to make the required drift I have to satisfy. Normally data centers G+3. So that's why what I want to say is based on this project, you decide your controlling parameter. If you are thinking as a owner, another thing, very important thing is everyone is doing mistake is in precast, increasing the grade will increase only 400 rupees. Suppose from M50 to M60, hardly 40 kg. 40 kg means 200 rupees. But your saving in steel will be very, very high. So for the highly, heavily loaded central columns and all, you please increase the grade, don't increase the size or steel. You can have up to 1.5% economical. Other thing is in precast, everything is tonnage. When you reduce the tonnage per MQ, your crane cost, your production cost, erection, everything is coming down per tonnage. When you reduce the tonnage, it will affect until loss. So that's why for precast, conventional is not a problem. Whereas precast with dynamics is there, you please don't increase the, obviously up to M70 and all, okay, after that you have to reduce the compressed strength, but still you will have advantage. That's why we are going for the UHPC, where a column size of 1.2 into 1.2 is reduced to 750 by 750. You can see the advantage. So, yeah. So, after consider those things, you please finalize the framing plan. Don't go with the framing plan right from the first day itself. Anyhow, you will be end up with a lot of trouble. Always try to like the problem because it will give you the solution sometime. Okay, first 2 days it will be because my owner is giving me salary, so I want to complete the vetting within 1 day, correct? But if I don't think means then I will have the same problem. So whatever the analogy which I shown, tomorrow I have to pass because all my wettings are involved in IT method, so I am going to explain the same thing there. So anything is double purpose, and this presentation also we are going to build our own hospital which is to be world's safest hospital. That is the projection we are going to make. So that's why I combined both. We have no other way, we have to work for the company also. So that's it. Okay, we are going to have a emulative connection because at present emulative is much proven because we don't do any lot of testings here. So until then you stick on to the emulative, and now rocking is being, the word is being introduced in our IS code. I am very happy so that we can go for a mechanical connection, rocking connection, where which you can dissipate the energy. Only see, my thing is after getting the fever, taking the tablet is before that we can make the what you can say, protection. So that's why you go for, that's why before earthquake energy hits your building, you try to make them to go anywhere direction so that your building will be safe. When you allow that fellow to come inside, then problem will be there. So that's why my intention is better to go for a base isolation. Of course, lead bearing and all is less costly. Sliding pendulum is more costly because only 3 companies dominate in the world and they are very costly. One company came to the sale. If you want, you can buy it because they approached us. EPS. Both the sons, they went to software. So he is having excellent technology. So he is approached our MD to buy. So 100 crore order is there.
Tailor devices.
Sir?
Tailor devices.
Let's start. EP, yes, actually, I think you know EPS, no, sir? Yeah, it is for sale for you. Okay. Yeah, see, don't, since having said that, I got lot of pinned connection here and there, don't worry about the effective length and all. If you take the curve, you will end up with the error. If you calculate the stability index, no one is now ready to do the stability index in the BTech level also, don't know also, even they do also, my life will be miserable. Better you go for a P delta and finish the job. Another thing is, whenever you have a model stability, you first check the P delta. Anywhere, definitely in the model you will have some nodal discontinuity will be there, which will be effectively shown in P delta, so that you need not to break your plan. So that's why P delta will help you in both. And next you always run the model analysis before starting all the load cases. First you fix the dynamic characteristic of the building, then you start doing all the, because every load case it will run for 1 hour. You please, what we will do is we will switch off the P delta, we will do the first this thing model analysis. In the model itself, whenever the time period is coming some eccentric value, definitely go to that mode. Some discontinuity will be there, or some cantilever or some mechanism will get formed. You might have not given the support. Next you come to B delta, then you do all your analysis. That will be best. Yeah. So my thing is, because to check every design is not possible. As a manager, what I will do is, everywhere I will try to put the stirrups near the junction. So that fellow will help me at last as a lifesaver. So that's why. See, if you put stirrups closely, your confined stress ductility will increase by 3 times. That everything will cumulate to the R value. When your strain of the concrete is increasing 3 times, is 0.0035 into 3. So that will increase your curvature. Curvature ductility will go. So it's like this. Then my R value, whatever 5 you are assuming or 4 you are assuming, I am very happy without checking. Because otherwise we cannot sleep. So that's why these kind of things depends upon the engineer. We used to take some decisions. Another thing is, this is the main thing I want to say. When you put the more stirrups, it will avoid the buckling of the bar. When he stays strong, he will make the core to be strong. When the core is strong, your plastic hinge dissipation will be more. You will be safer. So that's why stirrups, stirrups, stirrups. At least if you don't design for respect, if you put the stirrups also, you will be safer to some extent. So that is the point I want to make here. Yeah, this is the thing. Finally, I want to make. Before coming, you can introduce even a press system. See what our idea is. Like a fuse, tomorrow you can go. I need a 200 kilonewton strand with 200 plug. After the earthquake, you can remove it, bolt it, and retrofit it. That's all. Because here the building is being attached as a sentiment compared to other buildings. So even if it is not damaged, if it is a crack also, the client is not going to. He will again please whatever spending. So when he will tells the word whatever amount means, then we will be happy. So we will give lot of retrofitting. So that's why we will better go for a jointed system where which all your crack will, instead of here it will be concentrated somewhere unknown there, which will be hidden by the screen. So he will be happy and we will also be happy, so that we can remove it like plug and play. So base isolation is, first of all you reduce the force. Second thing, whatever force coming there, you provide the post tensioning, unbonded post tensioning. After the phase, if you want, you can remove it. So that will take care of all the ductility. Now this road is being introduced luckily, so I am very happy. So that's all. Minimum ductility for the aspect, if you design, it is one logic I want to tell the juniors. If you design for the head load and provide the stirrups, you will have minimum ductility. So that is the final I want to tell. Yeah, I think that's all. This is for my company. So this is my ethical duty. I have to do this one. Yeah, I forgot to show this one. See, I am telling definitely base isolation is going to be cheaper. That's why I have taken all the hospital building in India. They proved it is cheaper. That's what I am saying. See, here I am taking only the capex, not the life cycle cost. If your building is being serviceable immediately after the earthquake, because all your medical equipments are very, very costly. So all these are live example which will support our idea. And this is the ATC Vijayawada again. This is for me. Sorry. It's a marketing, you can take whatever you want to take. Yes. This is the first ATC in India. We can proudly say there will be no mullion. Sorry, not getting open. ಏನು ಮಾಡ್ತಿದ್ದೆ ಹಿಂಗೆ
ಸರಿ
ஓபன் பண்ணிருந்தீங்கன்னா அது ஷேர் ஆயிடும்.
இல்ல நீங்க என்டையர் ஸ்கிரீனே ஷேர் பண்ணிருங்க.
ஸ்டாப் ஷேரிங்.
டிஸ்ப்ளே செட்டிங்ஸ்ல போயிட்டு.
இல்ல சார் அது தெரியும்.
So here Mumbai company which done the Mumbai ATC, which is having 2 column center, but it is very big. It is a class 1 airport. They came up with a proposal that entire top cabin without column, without mullion, we will do it 8.5 crores bigger. For this one, we completed in 1.6 crores. And the aluminium, whatever the PRECAST deflection, we done the real scale testing. It is 1.2 mm deflection. They proposed 62 mm glass with air gap. We given 36 mm. Aluminium also we reduced the half. And we tested up to 2.5 kN per meter square and 3.5 there is no facility to reading it. Yeah, that's all. That's all. Yeah, very good. No, okay, this is what I was saying. So it's because of MD, because other than MD, all the consultant, all the engineers, they are opposing not to take risk because we are first time we are doing ATC and they came with 8 crores, better give 8 crores and sleep it. But we decided we want to do it, so we done it. We done the actual testing also. So we can probably say we will be the cheaper. If anyone want ATC, you can come to us. Yeah. This is a whole project we done, and yeah, this is the difficult project which we done in which we are doing in. That's all, ma'am. I am going to finish. This for the company. That's all I have to do. He given me time, so I have to give him time. Oh, again I'll come on.
Yes, sir. Next கொடுக்கணும் சார்.
சரிங்க. இல்ல அது ஒர்க் ஆக மாட்டேங்குது. மறுபடியும் இது பண்ணணும். I'll close it.
Sir, full screen the entire screen தான் கொடுத்திருக்கேன்.
Okay. So this is a very difficult right now we are doing. You see the condition of the site. It is 4 levels. In the Cochin Chinmay University, it is at every floor, at every level. We finish the things within 6 months. Okay, that's all. And finally, I want to show industry institutional. Yeah, this is where I was put into as a project manager. Because in our thing, everyone should have a cross dimension. So 4 years I stayed in the site. This site, this is a site when we took the site. This is what 2 meter down. I have to do the filling. Everything is up place. Just 300 meter next to the sea, Karaikal, NIT Puducherry. This is a site given to us. This is a condition. The government is also getting toppled because this contractor was given 90% compaction, bill is passed. So like vehicle, government also is getting toppled with. Yeah. Okay. So this is a Pentagon. So we finished. We hand over last week. Yeah. That's all. Thank you. So even this one we can do it in precast, means anything conventional you can do it in precast. Thank you.
So thank you, Mr. Satyasilan, for that wonderful presentation. As a token of our love and gratitude, I request Dr. Gopalakrishnan sir to present a small memento.
Actually, I forgot to tell another interesting about him. 2,000 crore reduction. First precast, I was asking you how to do all the things. He is saying, don't worry, you are an engineer, don't worry like that. That is the one I met him. That time I was a junior to engineer. No. He was sitting there. I was somehow trying to meet him. Nothing. Nothing. I just entered. So not.
Still previous. Is a long press for that. You check So our next speaker is Dr. G.V. Ramarao. He is a principal scientist working in ISTAR laboratory at SCRC. Welcome, sir.
5 p.m. Good evening. I think we're given only 10 minutes. Quickly, I'm going to talk on the seismic testing of precast concrete shear walls. I think my voice is okay. So I'm going to give a brief introduction. Then I'm going to tell the basic seismic testing methods. That is push-over test and cyclic test and shake table test. Here quickly I will run with taking one example, which is actually not precast. It is a shear wall, and the similar dimension shear wall as tested in all the three tests. I think morning onwards we are talking about a lot of testing. Which one has to choose? This will give an idea. So here the same similar dimension specimen is tested in all three tests, and then we will see what are the merits and demerits based on the experience with this test. Then we went for the seismic testing of precast concrete shear walls. Here, how we made it simpler and which test has chosen out of this push-over, cyclic, and shake table test. And then in that, I'll just quickly discuss about the wall horizontal connection, wall vertical connection, wall slab connection in seam mode. So basically here, the push-over test is basically we fix at the bottom rigidly, and then top we will apply progressive loading on one side. Okay, it's a static test. In cyclic, we do both push and pull, and the ideal one is the shake table test. That is we will place the specimen on the shake table and give the electric excitation. See here the need is we need to simulate the mass, then only inertial forces will get down. So from the push-over curve we'll get a push-over curve. So from that we'll get all strength, stiffness, ductility, etc. Then come to cyclic, either we can do a load application or a displacement curve. Based on that load control or displacement control. So suppose if you we'll get a hysteresis. With joining the peak points of hysteresis, we will get an envelope. This envelope we can compare with the push-over curve. That we will see. Okay, this is the ideal one. Shake table. This shake tables available in ISTAR. We can place the specimen on the table. Here I told we have to simulate the mass. This is the ideal one. It's a real situation we are simulating. Now quickly, I'm taking on shear wall that we tested same dimension, everything loading condition, everything same, material, everything that was tested in push-over, cyclic, and shake table. These are dimensions 1.56 meter width, 3 meter height. These are reinforcements, and these are for a push-over test schematic diagram. You can see here the load is applied through the next slide. I can show you. See the height through the jar and a load cell and a distributor beam. We applied the load manually, and The problem here in the shear wall, it is strong in in-plane direction, but out of plane it is very weak. So it will simply topple, and so we need to have a lateral restraining arrangement. This will be a laborious one. We will see in the later when it comes to the precast testing how we eliminated this issue. This outcome for the pusher curve. So here if you see, actually we always tell pusher curve is a bilinear curve, but in case of shear wall it will come as a trilinear curve because of the sequential yielding. So next one, the same dimension shear wall we tested in the cycling. That is a both push and pull. When you want to earlier we put just distributor beam and the roller support, but here we want to do push and pull. We need to have a encasement in the top slab, and then we should have a hinge arrangement. That's what we can see here. You can see the hinge arrangement here, and the slab is encased. So we applied the loads displacement cycles, and then we got the hysteretic loop. The next same shear wall we tested on the shake table. Now the issue is on the shake table, we need to simulate the mass. Then only because table will give base excitation only, the force will come from the inertia of the mass. Now the thing is out of plane, it is very weak, so we need to have a protection in the out of plane direction. So that's what we did is we put an encased steel frame, and that we given a out of plane direction, we given a restraining arrangement. And then here we applied a spectral compatible time history. We have gone to 0.1 G like that. We don't know where when it fails, so we have to go gradually. And then here also hysteresis loops will come, not like cyclic test, not it will have so many things. And here also we can do as well. Now quickly we can see we have tested totally 5, one on pushover and 2 on cyclic test and 2 on the shaker. All 5 specimen similar dimension, all reinforcement is set. Now you can see the lateral behavior. The pushover is more predicting. So compared to cyclic and shake table, we have a 20% more in the both in force center displacement. So I think morning there was a discussion. Cyclic test we can't able to go. We can go further thing on pushover test, and then we have to take a real thing is 20% less in both load and displacement. Now if you see that compared to cyclic and shake table, because shake table is a fast one, so initial stiffness will reduce. So this was the thing. Based on this experience, we moved into the precast concrete shear walls. This is actually the sponsored work from the L&T, and I think this here what is actually there is no beam collars, completely precast shear walls. It takes both the lateral load and vertical loads. So here mainly the connections only we need to do. We have connections will come wall to wall, horizontal connection, wall to wall vertical connection, wall slab wall connections. So what we did is, come to first wall to wall horizontal connection. So what we did is, based on earlier experience, we choose cyclic test is ideal for the component or joint or element testing. That is one thing we understood.
Audio is not coming up.
Somebody is muting, I think. From outside, someone is muting on. Mute all if they give it to mute us.
Mic is muted, I think.
Madam, now my voice is audible, madam.
Again, it is muted. Yes, now it is unmuted.
Madam, my voice is audible.
It's muted again.
Maybe keep that down.
We are not able to hear anything.
Someone?
Madam, now voice is.
Yeah, we are able to hear. Once we talk, I think somebody is muting the mic. Okay, you carry on. We'll see.
The first one. So what we did is earlier we did a single wall. Now the problem is we need to give a because out of plane we need to have a lateral restraining arrangement. That what we did is here we gone for two walls. So there is no need of any lateral arrangement. So now the what is the load taken? It will share into the two walls. We divide by two, we will get a wall. Displacement is same. That is one simple case we did. The another one is until the load what we did the last time is so much of arrangement, encasing the top slab, all these things. Instead of that, what we kept is we kept the bars inside the slab. I will show you the coming slide. Actually, in the wall connection, what is the methodology we followed is as I think morning we were mentioning IS 3920 is given that here there is a joint at from the base at 0.5 meter. So it is comparable with the monolithic one. It is better than monolithic one. Then it is this connection thing is followed. That is the methodology followed. So what we did is we have casted one monolithic one. That is the reference one. And here there are three different types of connections. The connections are one is the double and duct and put the grout. Grout is like varying with 60 to 85 like that. In the second case, we have kept the end down bars continuously, and then the next connection is we kept a grout coupler at the end, and then put the M85 grout. So that are different connections. So all this thing we have just compared with the monolithic one. So here that's a construction base draft and all the is a construction thing. And here I was telling that in the top slab we kept the rod, I think around 1.2 meter, 20 mm diameter rods, and then that rods are connected with an end channel, and that channel has got a hinge arrangement. And so why I'm telling is over the years we made it very simple. When it previous test we have done a lot of arrangement. Then when it comes to here it is very. So here this is the thing. This is a monolithic one. And now we applied the displacement cycle and got the Hessian loops. For all the four cases, this is the envelope curve. So now it's the here SW1 will be the monolithic one, that is the reference. So you can see all the connections are passed, and so that that is the methodology we follow. And all other key performance parameters also we have drawn from this. Next, here the what earlier I told is that is a slender wall. The next one is in case horizontal connection, sometimes you will get a square wall will come. There what will happen earlier is a flexural thing, now it is a completely it is a shear downward. So for that we tested one wall with aspect ratio of 0.8. So here because it will take a lot of loads, so we can't be able to accommodate with the two walls. So we went for single wall. When we go single wall, we need to give a lateral restraining arrangement. So here this is how we measure the shear deformation angle by measuring the long range displacement laser based sensors. Now this is the wall slab connection. Actually basically this is the four pieces, the one with the wall and then two side wings, and which has got reinforcement arrangement, and the top one. Four pieces. Actually these four pieces we have joined, and then here the loads are applied on the end beams. So here what is the methodology we followed is, here we measure the displacement at three places, and there should not be any differential displacement. The other one is the final failure should be below the wall, so that this joint has passed. That is the methodology we follow. And next coming to the wall vertical connection. So here there is a two pieces which are connected. Here also we gone to different connection like stitching, like two bars from two things, and then middle one bar will continue, and there are shear trees, and then put the ground. There are wire loops, two wire loops, like different things. What we did is we arranged a self-training frame. In that we put our 50-ton actuator. It is actually its stroke length is plus or minus 250 mm, and then we applied. Actually I showed only one, but it is actually both push and pull. So through that we done this different. Here also we have whatever the design thing is, it has passed means the particular connection is passed, like that criteria we follow. And these are the different international testing standards, ACI 550, and then AST also will section 14.2 will talk about this. And now I think the new BAS code is coming. It's in the draft for testing of structures for earthquake damage. Thank you.
Screen share பண்ணி
ஷேர் பண்ணிட்டேன்
screen தான share பண்றீங்க
ஆமா ஆஃப் so it is already on long press for off
Thank you, Ramarao sir. So the next lecture will quickly present the facilities at A-Star Laboratory so that it will give a rounded effect of what we have been starting from the morning and what we can contribute also. So this will be a very short presentation. Mohit will be presenting about the shake table test facility that we
Yeah. A very good evening to one and all present here. And I will be talking about the full-scale testing facility that we have at A-Star Laboratory. And I'll be focusing on the shake table testing while my colleague Dr. Bharti will be focusing on the pseudodynamic test facility that we have. So just to give a brief outline, like this is our lab, which looks very calm from outside, but once you enter inside, you can see the kind of testing we are doing that is not at all calm. So to give a background, our laboratory was founded in June 2007. It was set up as a national facility to cater to the dynamic testing needs of our country. And it is the largest built-in state-of-the-art laboratories which houses very two unique facilities. We have two different shake tables next to each other, which is I think only present in ACRC in India, and which gives us an opportunity to do different kinds of tests. And we also have our founding scientists who worked hard to make this facility a reality. Dr. N. Gopalakrishnan and Muthumani sir is also here. So to show you the specification of our shake tables, we have two shake tables. The first one is a 4 meter by 4 meter shake table, and it can support a dead load up to 30 tons. And next to that, we have a smaller shake table. It's a 6 degree of freedom shake table. That means it can give free translation and free rotational. So 2 meter by 2 meter shake table can support a dead load of up to 5 tons. And one of the unique features is that we can use both these shake tables in the synchronous mode. That means we can put an extended payload on these two shake tables and do the testing, or we can also do a multi-support excitation where we have different inputs to this shake table. So coming to the testing part, over the last few decades, we have tested different kind of structures using our shake tables. The first one that I'm showing here is the majority of the research that we started focused on the RC frame structures and also the masonry structures. And here I can show you some of the testing that we have carried out. So we have worked on the irregular structures, the open ground story structures, the various kind of retrofitting schemes, and also on one second. Yeah. So also on the plan and vertical irregularities for these RC frame. So the next part is we have also worked towards various kind of precast elements which we have tested in our lab. The first one is shown is a cold formed steel structure, which is a G+7 structure, which we tested on the shake table. And next we have a shear wall testing, which was carried out on a shake table. And similar to that, we have also worked on development of our own technologies such as EPS panel and a Setro-built wall panels, which were also tested in our laboratory. So this is a very unique facility because whatever testing methods we have seen till the morning basically focused only on the quasi-static testing where we were giving the push and pull. But I think if we have to go for the full scale, the full dynamic testing, shake table is the only method, and that can only be done in our facilities, which is very unique in our country. Yeah. So the next one we have, besides buildings and the precast elements, we also cater to the different sectors such as the nuclear power plant components. So our shake table testing facility is not just limited to the earthquake, but we also test for various kinds of vibration profile. So there are various components that exist in a nuclear power plant, Some of them are shown here, such as the valve system. The bottom one was a very unique one. It is a spent fuel tank assembly where they wanted to check whether the stored nuclear racks are safe, whether they have the safe distance or not. And that was carried out on our shake table. And similar to that, we have also tested various control panels, various non-structural components. And you can see, like, sometimes we get a component which can't be fit into a one particular shake table. So there we make use of two adjacent shake tables, and we can do testing for the extended payload on this kind of facility. So after that, we have also worked catered to the strategic and the defense sector. Here are a couple of examples that I've listed. It's not exhaustive. For the exhaustive list, you can refer to our website. So recently, we have tested the spent fuel tank for the LCH aircraft, and also we are working on the vibration qualifications of some of the submarine components that are shown here. Yeah. Thank you.
So this is going to be the last presentation of the day. So you can breathe a little bit. This is about our pseudodynamic facility, which will be very relevant for testing the prefab structures that we are talking from the morning. So to give you an idea, Mohit showed about the shake table, but we also have a pseudodynamic testing facility, which is adjacent to a test space of 10 meter with a strong floor, where we usually test components which Dr. Ramarao was showing. So apart from that, the heavy anchor grid of 1 meter by 1 meter is available for a wall of a total height of 14 meters. So that is one of the unique testing facilities that we have, which is a box reaction wall. And to support testing of big structures, we also have overhead cranes of 20-ton capacity in our laboratory, and the plan dimension of 10.5 to 14 meter heavy grid test floor. So both sides of the walls can be used in our testing facility. So that is one of the unique nature of our testing facility. So we have two different kind of actuators. We have 4 numbers of 50 kilonewton actuator with a stroke length of plus or minus 50 mm, which can be used for push and pull of any kind of components, sub-assemblages and things like that. But we also have a very big 500 kilonewton actuator with a stroke capacity of plus or minus 250 mm. So this can be used for full-scale testing of structures, cyclic testing of full-scale structures also. So both of them have a frequency of operation up to 50 hertz. So to give you an idea of how we use multiple actuators for multi-support excitation in our testing facility, this is a classic example for a nuclear component where we use actuators at the required height, and we'll emulate the conditions of seismic excitation across the height distribution, and then we'll see the effect of the structure. So this facility is purpose built for full scale and large scale structure and structural assembly testing. And some of the tests from morning we have been seeing different kind of moment resisting frames, and we have also tested some unique structures like storage racks where you have the structures are so flexible that the bending capacity of the racks are so high. When you are keeping the almost 8 tons of weight on top of it, they act as if they are on springs. So that's the unique kind of facility that we have. And coming to the prefab structures, we have done prefab structures for in-house prefab technologies as well as to other companies outside. So these are the push-pull mechanism that we use using our bigger actuator, 500 kilonewton actuator that we have been talking from morning. So that is for EPS panel system, that is the technology developed in-house in SERC, and the Secro-built system. Both of these systems have been tested in both shake table as well as in the pseudodynamic testing facility. And recently, we have also done a monotonic pushover test for a prefab structure from Coimbatore. So here I just want to give you a preamble of how we do the testing and what is the testing arrangements that we do when we are using our pseudodynamic testing facility. This is the beautiful aerial view of our lab. I know that there is no time, otherwise we would have taken you to our lab also. So this is the aerial view of our lab and the overall view of our pseudodynamic testing system. And as you can see, we can use any distributed beam of any arrangement and can be testing the structure. And this is for one of the strategic sector applications, so I'm purposely not showing the structure. but the arrangement will be very clear. The exhaustive arrangement that we make for testing the structure can be very clear. So using our test facility, we have the vision of testing prefab structures. So we have given you a small preamble of how it can be done, what is our testing facility dimensions and everything, and how a 3 meter by 3 meter full scale structure can be, G+2 full scale structure can be kept onto this and can be tested. So this is a G+2 building, 3 meter and 3.5 meter height. That is what we have assumed. And this, if we are placing in our the other side of the wall, which is having the 14 meter of height, then we can go for full scale testing in our facility also. So using the actuator that is presently available and using a purpose built push-pull mechanism in the top, which may be similar to how we have done in MNIT. So the same kind of testing can also be done at SARC, and this is what we are planning with all the companies that are available here. We are looking forward to go in this direction so that we can contribute more to the precast and prefab industry in the future. So with that, we close our lecture today. Thank you so much for patiently listening. So the last part of the day is just a closing remark from all the members who are available here. So that will give a what will be the future direction that we are looking for as a research institute as well as a practicing engineer. So this is what is the key takeaway that you are suggesting from today, whatever is the talk that has been happening from morning. So for that, I kindly request everyone to join us on the stage and give you a few points, and I'm kindly requesting Dr. Gopal Krishnan sir to moderate it so that we will not exceed the time too much.
I think you will still make it clear. I mean, it is important.
Oh, for you, sir.
Yeah. For everyone. Yes. Come. You also still want how much of time available to us?
Sir, if you can finish in 20 minutes, that will be
20 minutes.
Yes.
Maybe
10 minutes.
people have to go home, and then it is no point stretching a few unknown faces here. What I will ask you is Dr. Muthumanee is still unspoken. So I will first give us meeting, set up the lab, and we create a taking steps. You can talk anything, but I have listed something for each of you. Prasad on futuristic technologies, trends in and Amit on technology drivers, which are going to push this. Then Satyasilan on proliferating this for domestic building makers. Who will make that? I do it yourself. DIY. How do I make my own precast thing and build a house? It's prohibitively costly in Tamil Nadu. Compared to the states which are a little bit away, you have to bleed through your house. Then Dr. Muthumanee, very important topic on developing testing infrastructure. You can still talk anything in English. And for director,
Madam will be coming shortly.
So R&D in precast, performance monitoring, failure documentation, they are very important. So we will start with Dr. Muthumanee on whatever you would like to talk, more so on developing testing infrastructure.
So thank you very much. So we were, of course, you know very well that we are the founding people who started this lab at a very, very cost, closing so many people, and then we got it first. Fully sponsored by two organizations. So we have restrained keeping their demand, and then thinking of the first national facility in the whole of India, how it is going to be. So with that vision we have given, and that is why we are able to keep this lab live right now. So coming to today's discussion, I just make a few more remarks. Like starting from morning, we were always seeing that precast construction is addressing the issue, that is no longer that. But we are all, on morning we are getting 7.8 times the TV. That means we are always looking for load, the important thing. So if you think further, you say we already have 2 work here. Even if you take R equal to 3, 6 times you are getting the real. So all those points apart, what is really needed in a joint or any construction system is replacement capacity or replacement model. So that is what we have to ensure. The force scenario we are 6 times lower or 10 times lower, whichever depending upon our way. So we need to worry about what is the replacement capacity of each joint or replacement level of the whole structural system in earlier. That is one thing. Or if you want to see it in a different way, what is the energy displacement? So maybe how much energy displacement capacity is there. For example, even in a monolithic structure without precast, there is a kind of camping system that exists with the capacity. So maybe how better we can add to get more energy dissipation in each of these joints. May solve one of the examples that he showed us, so 2 walls in between there is a damper kind of. So these kind of innovative ideas will really help. So and most of the people talk here are always going to standard. So innovation is beyond standard. So precast we have 5 decades we have worked already. So we are here today. So any more development in this area should be innovation based, not standard based. So that's the thing.
Now, we all have seen already that a lot of the construction technologies exist today. As I have shown in my presentation, that we have this monolithic and nylon construction, and we are looking at now that will be taken over, beaten over by precast construction technology. As Amit Bajaj has also shown it, the volume which is being lost, like 20 lakh SFT in 1 lakh year, 2 years. So that is the volume, and the people are demanding it. Then precast is only the order of the day. Right? Now, number of precast companies are coming up in the country, and precast is a wonderful state. This is the only technology that we are looking at it. But having said that, I'm also looking at other technologies like composite construction technology is also coming up. In Hyderabad recently, I have seen Phoenix developers have done one structure of 41 story in composite construction. They have come up with an institute concrete core and then provided the steel box columns and then the deck slab flooring and all that. But they have done the structure in about 1 year time. And in another 1 year, they want to finish it off in the finishes. They kept it 2 years time. They thought 18 months. Maybe they will be somewhere there. So these are the 2 technologies that are going to take over in India, which is composite construction. Now, how Phoenix have gone for this? They thought, okay, instead of a precast, if they are going for cast and screw, it is going to take about 4 years time, a 41 story structure. But they are going to finish it in about 18 months to 24 months time. Okay, they are very near to just completing it within less than 20 months. Right? Even when we have conducted a recent workshop, we have taken all the people over there to show that particular structure and all. But then what made them do it? When we are talking about composite construction, the steel and all, you have to apply a corrosion resistance paint and you have to apply a high resistance paint. High resistance paint is costlier by about 2 to 3 times than the structural steel itself, whereas concrete is cheaper. Right? But still they have gone ahead because they thought they are going to get 2 years advance rent from the by letting out the space. That's where they have made their calculations. They already got the parties and all. They have gone for the structure. Yeah, even see that's what Amit also has shown that even for the if there is a party who wants it faster, then the cost is not the consideration. Very good. So this composite construction technology and precast construction technology will be the future drivers, and we need to look into these various types of jointing system that we are looking at it. And for example, in Japan, whatever the new joint system that we say, they simply say, come on,
construct it, test it, and then wait. Like similarly, we can use SCRC and other facilities to test these different innovative technologies and then move forward with this technology to take it further now. Yeah.
Yeah, thanks, sir. Amit on technology drivers.
Yeah, good evening. So when it comes to technology now, I think one of the two biggest drivers that we see is one is the demand, of course. There has to be market taken. And whatever we see last few years, especially after COVID, we definitely see that this has changed from that push to pull. Before COVID, we were going and knocking the door saying this technology is there, it is faster, better quality, you look at it. We have now coming that I am sitting and inquiries are coming in saying I have this volume, I have to get it done. You tell us what to do. So that is one, I think, the demand. Second biggest thing is the acceptance. Right? Because the customer, client, whoever, it doesn't care what technology you have built, just to last long, their maintenance has to accept it. If it's the housing society, if it's the whole buying the house, if it's the commercial, and that acceptance will come with experience, which is what now we have seen. The things are starting, whatever seeing is giving an effect that we see. So that driver is there. What needed going forward is some sort of maybe standardization in the system, so you can build longer term factories. Whatever we are still doing at a large scale, is still setting up the factories at the site, than a centralized factory. So maybe hopefully we get there, where we are already to a certain extent bigger cities, we are doing the visibility is there where we can justify a central factory. The standardization will probably build that case for central factory and lot of efforts for whatever factory that I showed you. It took almost 7 months to build that factory. And the project duration is only 2 years. So you imagine the math and effort behind it. After 2 years, you are going to scrap that factory. And it is built for last 20 years at least. Because it's the same size of system, steel, everything is same. So the efforts that will automatically translate into the cost. So those couple of pointers were definitely there. System is there that would be our.
Yeah, that's good. Like, yeah, for him, the domestic sector, like, I'm a personal way, I'm building my own house. How do I put precast? Actually, it's the right topic. I think most of the civil engineers, once they are asked, you built so many bigger houses that you build it one such something. So I stopped telling to my wife. When I shown the highest, she asked the question. So from that time, it's a thing. What we are targeting for another 2 years, we are all salary people. So when we move out of the town, the main thing is concern is the education and the rent or house, all the things. So what we thought is like, if we can have even in that 50% in our market survey, what we understood is even land you can something lease you can take, and if you have a building in within 2 days means they can easily move to the other company or wherever location you need. So that is the because as a salary person we also.
Our question is like it is like a shop. We go there and buy some.
That's why I'm coming.
Building shop.
That's why I'm coming there. So as a middle income person, we need that one. It should be cheaper. It should be easier. So that's why what we thought is like the steel industry is getting proliferated because so many fabricators are there. That's why you can easily make. The main hindrance in India is we don't have so many manufacturers of precast and education among the conventional. In foreign, as Sir said, you can order a column, beam, staircase. Even my people, we are doing outsourcing to Canada, all those things is same only. If the person will give a dimension, we will give the order. There the factories are centralized. You can order anywhere. Suppose image is there, is a standardized done by the government itself. So you can pick and play. These are the house I want. I can manufacture from here. The one advantage is since the technology is there, I don't know the rate. So what they done is they specify the quality, they specify the base rate. It's a cost per standard. 6% or 7% you can load it. There is a ceiling is there. So what I am seeing 3 point is the conventional definitely hybrid is going to help us reduce the cost. it will come into picture when we have a nut and bolt system or easy installation. Now the precast correction is a skilled one. If you make it easier, everyone will do. Obviously, rate will come down. Then the conventional will not see us as a threat. So now our factory infra contractor will become a supplier. So when the precast companies are becoming a supplier, surely you will get a middle salary person can have their home in, I think, 7 days. So for that standardization, for that already we are working on. Surely in Coimbatore, at least my house I will build in that, then I will protect it.
I think for the director, R&D in PRECAST, documenting failures in PRECAST and performance marketing. Like translating SHM for PRECAST.
Yeah. One thing what is on first is monitoring, I would like to come. Even if it is not precast, also it's very essential that we have to monitor. So precast has got other aspects coming into it. So now the connections, there is where we have to concentrate, because the other things we can do, we can take care with whatever we are doing. Only with the connections, we have to have some methodology specifically developed for the monitoring of these things. I believe that some of the things our own people can take up that one and then work on it. And coming to R&D in precast, I think the first one is materials, like sustainability is one aspect which we have to look into. So these materials, how the recycling of the materials, that we have not thought about. We are building these structures and then we have to think about the recycling and how to reuse all these things. And the methodology, like if we interact with the industry, what is the need of the industry, as well as how to address the difficulties of, say, for example, whatever difficulties you are facing, how to address it. That point we can take as a need and then work on that particular aspect, so that it will be finally applicable to the field. So it will be useful for both of us. So we have to identify those gaps, like where essentially R&D is required. Instead of repeating what one person is doing, we should have a consortium where we can all the people, like from the industry as well as from the research R&D side, they can talk and bring out these are the gaps which needs to be addressed, and we should also prioritize them. What is which has to be taken first, and then there is a stamp can be given for better things. And he was telling hybrid construction, that is another which is required. We cannot go always for precast, hybrid is required. So that is another area we have to work and fast. So by precast, one version is like it may be costly than the conventional one. And if it is standardized and we can get the panel or something off the shelf, then people will try to use it and assemble it themselves with the easier connections as well as I like it. So it will be very easy. I can build my own house. That is the final thing which we would like to. But on other aspects like bridges and other infrastructure, still we need a bigger construction people. They have to work, and R&D always will be a part of it. So we have to learn from the failures. So we have to document it. Particularly this documentation, I think will be very much useful, not only for the industry but also for the R&D. We can take some leads from that, where why the failures are being happening and the repeated failures that can be the R&D program. So in case of we come up with some repeated failure, and these are all certain things. I think still some more discussion has happened, and we have to put that number like 1, 2, 3. We have to take it up. Then we can specific things with it.
Actually, we have been very brief. I will let the audience, and then whoever you want to ask questions, there have been some 1 or 2 lists which is Bharati has given me. Also can be question too. Yeah. But the left out audience can ask to whoever would feel.
Okay.
Yeah. Just get up from me, Babu. People would like to see also. Why don't you come there? Not proper lighting on. हम सब आपको
He's a scientist from engineering.
Okay.
This is regarding divine technology. People are constructing in India throughout India, especially very famous. So, what about the environment? For example, temperature is more temperature is there. Whether it will attract more temperature, because we morning onwards we are discussing about the construction, how to construct all those things. Okay, that is engineers can do. But to stay here, how much temperature comfort levels, how it is. That is some question people are talking. I want to know that. Very good. Yeah.
Good question. See, what we have observed and what we are doing is, if you provide a cross ventilation to your bedroom, like you have one window on one side, other window on the 90 degrees other side window, then the wind will pass through and the heat effect is not there. This is what we have observed and it is working out fantastically. There is no heat gain much into that building. But the same thing will come even if we are going for precast concrete wall also. Okay? So the heat effect is not much. That's the reason why you are going with this Maiwan wall construction and all that. Okay? That is absolutely all right.
So nowadays, now the double wall system and all is came. Now it is increasingly it is started using. That which you can have fill it or not fill it also we can have it so that the air gap you will have the natural barrier. You can reduce the heat. Otherwise, so many materials, insulation materials of happiness problem came. Actually, IIT Hyderabad the same issue. We are done for either G+14 the same method. Radiant cooling is there or insulation board is there. So many methods. Outside coating methods also came. So any based on our budget, we can choose any one or combination.
Actually, one of the systems that SCRC developed is that putting that polystyrene inside. Okay, so putting that polystyrene inside, we have done a 10-story building for JSPL at Anguloris. Then we have seen that it is about 4 degrees centigrade temperature gets reduced. But that is a call that taken by JSPL. Outside developers will not take that. That what we are using short feeding. After doing short feeding, again you have to roughen we just put that. It's a very tedious process. Instead of that, pouring concrete is easy. But having said what Satya said is, yes, there are systems which here you can apply paint, which will refill and then reduce the heat loss.
So like you said, the client is demanding faster construction. Like you said, like all of you said, the clients are demanding faster construction. So, like you suggested, one of them is composite construction. But the main problem that composite construction industry is also facing, that when we are having a glass facade for a commercial building, it is fine. When we are having a masonry construction around it, due to the coefficient of thermal expansion difference, there are visible cracks between masonry and steel structure as compared to masonry and RCC structure. So how do we address that?
So composite construction is first of all predominantly applied only for commercial buildings. It is not for residential buildings. We don't use it, and it is not for facade. Architecture is not as a composite construction where we use it for commercial structure. Even if we construct it faster, developer can get that cost, get that amount faster and all that. Okay, and having said that, for the composite construction commercial building, predominantly go with the double glazed walls and ACP type. Now your second part is like even for an RCC structure with brick walls and other. Cracking is an inherent property of the material, right? So that's why we are doing at the plastering level, we are trying to give a groove. Okay, you leave the groove at the plastering level, allow the crack to develop at that junction. So we are telling the crack you come here, right? So let it crack, and after 3 or 5 years, then afterward, then it is like marriage between the column and the brick masonry. They get adjusted, crack develops. Then you apply putty and do the paint, and the crack will never surface. Okay, that's how we do that. And even before doing that, some architects with their engineering knowledge, they think that they can apply a mesh and then see that cracks are not there. No, still cracks. Don't do that. Give a groove, allow it. They allow the crack to form because it is proper. Because RCC can take a lot of movement, but brick masonry cannot take that. The coefficient of linear expansion between the two is a lot of difference. Okay, that's why you see cracks, and we have to allow the crack to happen. If they have pocket, yeah, later on we just fill it after 3 or 5 years. We apply a putty and paint into the levels.
I think Sir spoke about how climate should really affect all parts, production, transportation, and erection. And we also spoke about UHPC, etc. Is there any innovation in lightweight concrete that would really, you know, help, or any other innovative concrete, the material innovations that are in the pipeline that will really boost the precast industry in the years to
Lightweight, obviously, the lightweight, the puzzle is that where you only have to bear it. Don't need to put that much weight. What I have put is unnecessarily I put too much weight. Actually, that much is not needed. So those kind of puzzle, definitely we can go for a lightweight aggregate further. But the acceptance is not that much steep line limited location to do such concrete like that is the thing. But already technology is there. We can very well go for a lightweight. Only thing bearing, we should not have a tearing period. Only that thing you can skip up. Remaining is a further which should not be environmentally inherent to the damage, environmentally all those effects. If that is there, it's fine. That's why nowadays for all our Japanese, instead of having 150 watt, we are proposing 40 mm UHPC axis. We went for UHPC for that only. Because my entire delta deflection is because of further. So nowadays we are going for further with 40 mm. One thing advantage of UHPC is you can cast as thin as possible. No steel is there, only steel fiber is there. You can cast in any shape what you want. So now we migrated, but as is it, lightweight is there.
Yeah, Professor Surya Prakash of IIT Hyderabad is doing a lot of research on lightweight concrete, structural lightweight concrete. Okay, he's coming up with the various densities and then doing that work. Shortly that work will
Some people have expressed that there was some aggregate problem with the water. It retains a lot of water, thereby delays the curing cycle. So
exactly. He's trying to utilize the various types of lightweight aggregates in preparing the further. He has also given a recent presentation in North our association, technical presentation. I think you will get that information.
Foam concrete is also there, where lightweight concrete, and as well as for the other that also reduces weight. And textile reinforced concrete, as you were telling, you can make thin elements with industrial textile reinforcement, so it addresses the corrosion problem, as well as you can cast to any shape. So that is another advantage. And the ACRC is working on these areas. So number of technologies is available on the textile reinforced concrete as well as on the shape.
Right. What about others? Yeah, also.
I'm Ramadan from Santa Industry Academician. So I'm also thinking about the concrete because I'm working at concrete. So as you were saying that the thickness of the concrete can be reduced. What about the material replacement? Using the lightweight aggregates, as the we call this expanded clay aggregates kind of things, so that we can maintain the same thickness and also the weight can be reduced.
That is two things. For the same thickness, you have a reduced weight. If the client is not okay to get that aggregate and they are not okay with the strength and all, see, normally the consultant what they will is the client when they don't know about the element, it is little difficult to convince them. So in that what we have taken the next step. Go for a thinner element so that we will have a lightweight. Our intention is to reduce the weight. Two ways, you are right. Either you can have a lightweight aggregate or you can go and reduce it. So since it is easy for me, I will already do it.
I just want to know about the curing of the concrete. Yeah, the concrete which you use, the curing time. The duration of your concrete.
I want to tell, I forgot. Everyone not way back in 2012 the same question, why 7 days curing is not done as that of conventional. It is a constant question. We have been asking with 2012. So you can check no problem. See, now here if door is there door is there. You can run directly. If even 20 people is there, they can run. Suppose you make this zigzag. In order to reach that place, it will take so much time. So that is the thing. So whenever your Delpo formation is such that when the interconnectivity, like a clay, your water interconnectivity after 60 or 70% strength, interconnectivity will break. You can nowadays, previously the instrument was not there. Nowadays all microscopic instruments are there. So that's the idea. So when you have a 70% strength, you will have an interpore connectivity disconnected. so that the water color will get arrested inside it so that he won't evaporate. So by the time you can stop the curing. That's why we have stopped curing by say second day or third. By the time you will reach around 70%. Now UHPC we are reaching 150 in 24 hours with the steam. Even if you put pressure, you will get it much earlier.
So in the hollow core slab, what our production is not, we will send the steam curing from the bottom of the plate. Okay, that means we are hastening the hardening of concrete. Right? So within about 8 to 10 hours, your concrete gets hardened and you get 70% of the time. Then we will distress the wires and then cut the element, remove it from the bed and ready for casting next time. Similarly, even in the tables also, where we are going to cast the walls and all, and some tables also have this seating arrangement. Okay, sometimes they use that. Then the walls can, like the precast wall elements can be hardened faster, and then we will just remove it from the particular thing. Now, as you rightly said, after you get that 70% of the strength, the remaining 30% it will get the air and other things from the atmosphere. Okay, then it will get its strength automatically. I'm fine with that. It is ready to transport also. Transport and get it. Yeah.
You have a question to ask? Or I went, okay. I think I'm very thankful to everyone for, I don't have any other suggestion of beyond what they have said. Thankful to the director for having called me out. My colleagues are able to see as well as some of the whom I am in contact with. It's a great opportunity for you. My only thing is, I think CRC should work more vociferously on precast because that's a huge trade. I have seen that in Gujarat. It's a huge trade. Like Intel telling that Intel came to Bangalore and the story was such that within 1 month or 2 months, you know that 1 or 2 months the thing is to be ready. And then one of our MTech scholars, I don't remember his name, Raj Rohit, somebody. I think he was doing the design for that. And then we used to interact with him, and the pressure was enormous. It's Chinese money at the end of the day. So they are having, and India can be a rightful thing, third economy or fourth economy, only if the infrastructure requires zero time. They want the infrastructure to be built at zero. You can't do that, but then infrastructure value can take time, 2 years, no, 2 months, that kind of thing is, at least for those commercial things. So that's a driver. Quality is a driver. Lack of workmanship is a driver. There are very many things of it. So you have only Punjab and the West Bengal days coming over. They are all not going to be sustainable. So you need to have factory made, quality maintained, coming here, take care of only those in situ routing. Rest of them have to be done by mechanization. And
thank you. Thank you. So thank you everyone for joining and giving your insightful points about where we have to go and where we stand and where we have to go. As a token of our love, we would like to present a small moment to our Dr. Muthumali sir, and I request Gopal Krishnan sir and Director Ma'am to give you.
என்னோட கொடுங்க.
No, sir.
Now we will also request you to stay back and give a moment to Dr. Ramarao for presenting the testing capabilities of VCRs. And last but not least, this one-day seminar would not have been possible without the support from Director Ma'am, and for also giving all the support to us and also giving a right talk in the morning to setting the right path. From A-Star Laboratory, we would like to give a small memento to our Director.
No, this is why Jyoti, you should know it.
Sorry.
Looks so odd. I'm part of you, like I don't chase me out.
So that we come to the end of the function and the function demands a formal vote of thanks. And with that, we will close the function. So I request Sunil to give the vote of thanks.
Yeah, please sit down.
You can see.
It gives me an immense pleasure to propose the vote of thanks today. On behalf of CSR SERC, we express our sincere gratitude to all the guest speakers for accepting the proposal for delivering the talk during this seminar. We would like to thank all the participants who are present both offline and online for your active participation in this program. We would like to thank our director and advisor for providing constant support and encouragement to conduct this event. We also like to thank ICT team, guest house team, BKMD, SHRDD, electrical division, canteen staff who have provided their full support in successful execution of this seminar. From the bottom of our heart, we'd like to thank everyone who are directly or indirectly involved in this event. We hope that for the participants, this was a good learning experience. Thank you.
Forward to you on the